Most of the data engineers just learn enough Python to create a pipeline. For a while, that works fine until the data changes and the pipeline breaks. And that is when they realize they haven't learned enough Python. And we are not going to do the same mistake because in this masterclass, we are going to cover every single concept possible that a modern data engineer has to know in Python, starting from the core fundamentals to practical pipeline logic to industrial best practices that are implemented in real systems. When I say that this masterclass is not just about the theory, I'm going to demonstrate the concepts where it is necessary. If you want some hands-on experience, work alongside me as we build and break things together. And by the way, all the resources and files that are used in this masterclass, you can get those down below from the description. And with that being said, let's begin. Alright, let's begin our Python for Data Engineering Masterclass. Now, before going ahead, I'm going to explain how I designed this masterclass. Alright. First, I'm going to explain the theory of every topic, and then I'll draw the flow, how that particular topic actually works. And then I will demonstrate if there is an appropriate demonstration for that particular topic as well. That's how the flow goes throughout the whole masterclass. And then the topics that I'm going to explain in this masterclass includes Python foundations. We will begin with that, which includes the topics, the things you have to know before learning data engineering part of the Python. So those are the Python foundation. And then next comes data structures. We'll know about data structures. That includes tuples, lists, and dictionaries, and also sets. So we'll know about data structures, and then file handling, functions, modules, packages. We'll know about all of this, which are part of writing the code. And apart from that, apart from writing the code stuff, we will also discuss about error handling. I will also explain error handling. So not just writing the code. If you face any errors after writing the code, we will see how to handle those errors. That is one of the topic. And then we have logging are nothing but creating the logs, so anyone can understand what that particular code is doing. And then debugging the bugs. Then the next topic, which is pandas. We will also discuss about pandas. I know pandas is mostly used by data analysts or data scientists. Data engineers doesn't have much to do with pandas, but it does play a major role in certain part of the flow. So I will also explain pandas in this class. And then we go to databases, how you can interact with databases using Python. Then APIs, how to use APIs. If you already been following the projects in this channel, you'd also know I used a lot of APIs to gather the data from them live. So I will also teach how to use them. Then we go to object-oriented Python, OOP. We'll also talk about OOP concept. And then performance enhancing the performance of the code, what not to do while writing the code. So we'll also do that. And then we have concurrency and scaling. Scaling Python and concurrency, like multi-threading, multi-processing. We will also know about that. And then we will end with production grade practices. The best practices that are used in production grade to actually make your project professional. So we will cover all these topics in this masterclass. So this is the basic overview. And there is a prerequisite for this masterclass, and the prerequisite is simple. You have to know the fundamentals of Python. When I say fundamentals, you don't have to know about all the topics. You just need to know what are data types, the stuff like the operators we use, and working with loops and conditional statements, so that those fundamentals will do. You just need to know about those fundamentals before you start with this masterclass. Just you know, I have to say this ahead of time so you don't waste your time. So that is the prerequisite. Okay, let's begin with our first topic, which is Python foundations you have to know before starting with Python for data engineering. In this topic, we will know about what Python is in data engineering, what Python is not, where Python sits in the data stack. We have to know one thing, because there is a common misunderstanding between people when they start learning about Python for data engineering. They might think Python in data engineering is about writing complex codings and doing data wrangling, and they also might think Python sits at the analytics part of data engineering, the data stack. But all those are wrong. Writing Python in data engineering is not about writing the code in competitive in the competitive programming way. It is more about writing the Python code which is more readable, and it should be more readable for anyone. So it is more about readability and how you manage the code blocks than writing the complex logics. So that is how we write Python in data engineering. And also, Python doesn't sit in the analytics layer of data engineering pipelines. It sits at a different position, and I will explain you with a diagram later. But now you have to understand it is not about how complex your coding is. It is more about how understandable the code you wrote. That is how the data engineering Python in data engineering works. Because when you work as a data engineer at any company, you're not the only data engineer working with them, right? You work with a bunch of people, and the code you wrote should be understandable for every one of your co-employees. Or even if you revisit the code, it should be more structured and more readable for yourself so you can work on it. So it is more about that. Now, talking about the mostly used tools in data engineering alongside of Python includes SQL and Scala. So these three tools are the most used ones in data engineering. Now we have to know about the difference between these three tools, right? Firstly, let's talk about SQL. SQL is all about asking questions from the data that is already written, the data that we already have. It is so you say what you want and not how you get it. So you just it is like more declarative. And there is Python. Python is about moving, shaping, validating, and orchestrating data. Python doesn't actually more interact with the data by itself. It uses tools, but it doesn't actually interact with the data by itself. So it is more about uh, gluing things together. So it doesn't, I mean, Python works with all the tools, but Python owns nothing. And then there is Scala. Scala is mainly used because of Spark. If you don't know what Spark is, Spark lets us work on the data with multiple clusters. I mean, it scales horizontally. You can work on the same data with multiple PCs, basically, to say that in the general terms. So that makes Spark better than any other, any data tool. And that is Scala. But if Spark doesn't exist, Scala will not be used probably in data engineering at all. And talking about these three tools, basically Python doesn't sit in the analytics layer, like I said. If we divide the process of data engineering on some sort of data into layers, Python doesn't sit in the analytics layer. but SQL and Scala, basically Spark, SQL and Spark sit in the analytics layer of the flow, but Python is more about connecting the systems together rather than an analytics tool itself. It is not an analytic tool, it just connects the systems together. Python is useful to pull the data out of APIs or files or queues, and it also used to validate the schema of the data that we pulled in as an input, and it can also apply business rules to the data, and it can write data into the storage. So all this process can be done by Python, but none of these process comes under analytics layer. After all these processes are done, I mean, validating, applying the schema, and storing the data into some sort of storage. After that, the analytics layer start, where SQL or Spark takes over, and then we create uh, analytical dashboards out of it. So this is where Python sits. Now, talking about the layers in data engineering of a data, let me just show you where Python sits in that uh, flow. Let me create a duplicate slide here, and I'm going to create a flow diagram for that. By the way, I didn't create these slides that I'm going to explain, just because I thought it is appropriate to create these flow diagrams while I actually explain them step by step, so you'll understand more, rather than just showing you a pre-designed slide and explaining that. So I'm going to show you the flow diagram here. This one. Is that? So the flow starts with the data source. After that, this is where the place Python sits. And after Python, have the storage layer, and then analytics, and then business intelligence, which includes creating dashboards and taking decisions here. Say BI, business intelligence. Shapes, arrows. Let me just use some arrows here. By the way, I'm going to give this PPT to you guys so you can just go through whenever you want to, have a quick revision. So this is a flow. The flow begins with the data source. any project, any data engineering project, the flow begins with the data source, which we get the data from, the raw data from. And the data sources includes things like APIs, which we get the data online, where we get the data online. And then there are files like CSV files, JSON files, or Parquet, all these data types, I mean file formats. So we can get data from the files. And then there is Kafka, which is like the data streaming. So the data will stream, so we can get that the data source can be a Kafka data stream. And there is databases, so we may get data from the databases. So the databases are the data source here. So that is the first layer. The data source is nothing but a source where we get the data from. And then the next layer, Python. Python, like I said, it handles ingestion, validation, transformation, extraction, orchestration. So that is what Python handles. And you have to remember this line. Like we already talked about it. So Python touches almost everything, but it owns nothing. It acts like a UI for most of the tools, like PySpark or Airflow for orchestration. By the way, if you don't know, uh, or Kafka connecting to Kafka. So it acts like a UI, but it owns none of those tools. So that is where Python stands. Let me just write those things down here. Firstly, data sources includes APIs. No, we have to start from here. Okay, we have data sources we already talked about, APIs, files, Kafka data streaming, databases. And then we have the next layer, Python. Next layer, Python handles extraction, ingestion, validation, transformation, and lastly, orchestration. So Python is useful for extraction. So it helps us extract the data from the data source. It can be APIs, files, Kafka, databases. So it is useful for extraction. It is also useful for ingestion after everything. After all the transformation, the data transformation process is done, and the data is business ready or data is partially parsed and validated, you can ingest the data using Python itself to any storage. It can be S3, it can be a local storage, or it can be Snowflake warehouse. So Python can help us to ingest the data into any of those storage spaces. Then it is used to validate the data. Before you transform the data, we validate the data. So we can validate the data using Python. We can do transformation too, and we can also orchestrate the flow with Python. The mostly used tool to orchestrate is Airflow, and the mostly used language to orchestrate using Airflow is Python. We use Python to orchestrate the flow in Airflow, Apache Airflow. So if you want to know more about Apache Airflow, I already did a masterclass. You can find the video. I uploaded it as my last masterclass that is like 6 hours long. No, it is 5.5 hour long. So you can watch that video as well. That is about Apache Airflow. I will ping the link in the description down below. You can click on it if you want to. Okay, so that is the layer. That is the Python layer. Next comes the storage layer. Like I said, it can be an S3 bucket, AWS S3, or it can be data lake, or it can be a data warehouse like Snowflake. I mean, the modern data warehouse is Snowflake in at this time. So that is the storage layer, which includes S3. It can have S3 or data lake. It can be warehouse, or it can be GCP, Google Cloud, GCS, Google Cloud Storage. Any sort of storage comes under this layer. And then there is analytics layer. And the analytics layer includes the tools like SQL and Spark. At the initial times, SQL was only used to query the data that is already transformed and ready for the analytics. But eventually it evolved with combination with these modern tools like Snowflake. Now Snowflake or DBT, now SQL can actually used to transform the data and make it business ready. And then there is Spark. Spark is more about uh, multi cluster processing. So you can divide the jobs between multiple clusters, and those clusters work on that particular jobs parallel to each other. So that makes Spark a lot faster than transforming the data using Python using Pandas or any sort of tool. So that makes Spark a lot faster. So that is one of the most used tool in this modern data engineering world. And then we have BI, business intelligence layer, which includes dashboarding and reporting. You can write it down in the notes because I haven't written all this stuff in the presentation. Okay, I just wrote this stuff on my screen. It will be erased right after I click the right click. So you cannot find that this information in PPT. So you can write them down. And by the way, I explaining all this stuff. These are not just Python. These are how Python merges with the data engineering, the modern data engineering. So I explain all these topics so you can understand how and where Python sits in the data stack. Okay, we're done with that topic. Now, talking about our next topic, which is Python installation, virtual environments, and project structuring. You might ask me, why do we have a separate topic for Python installation? That is because we're not going to use any pre-Python installed applications like Anaconda in our case, because Anaconda is very good for data analysts or data scientists, but for data engineers, it is not appropriate to use those tools because there is a good reason for that. Let's say if you're working for a company and if that is a big data engineering project, they probably will not use not probably they mostly will not use their local PCs for working. They buy the virtual PCs, they pay for the subscription, so they get the virtual machines from any cloud platform and make you work on them. And The hard part here is those virtual machines doesn't have any UI. So you have to write these Python codes and save them in .py format and then run them in those virtual machines. You don't have these fancy UIs that we get when we write code in Jupyter and just hit the run button. It doesn't work like that. We have to communicate with the virtual machine to run this particular Python file that I written in the CLI, which stands for Command Line Interface UI. I mean, that is not UI, Command Line Interface. So that is the interface we have to use. We cannot use any UI when we work with the virtual machines. That is why it is not appropriate to work with Anaconda, I mean Jupyter notebooks, when we learn Python here. And also talking about the environment control. I will also explain how to control the environment while you work on a project. Like I said, this is not just a Python masterclass. I'm also going to explain how we manage the structure, how we manage the project structure and the environment of that project. So you don't, I mean, you learn Python the professional way or not the beginner way, who is more focused on the logic more than the environment and these extra stuff that we have to know as a data engineer. We have to talk about the versioning. When you work on a platform, you don't decide the Python version. The platform decides it for you. Let's say if you work with Airflow or you work with Spark or cloud services, you don't decide the Python version. You don't say, I want to work with the latest Python version or I want to work with this Python version. The platform decides the Python version you have to work on. And yes, when you work on a project in the real world, it doesn't depend on how latest your Python version is. It depends on the Python version consistency. So the whole all the process in that particular project use the same Python version rather than doing half of the project with one version and switching to the latest version if Python releases one at that point, and doing the other half of the project with the latest version. That breaks the pipeline. So it is more about controlling the version, being consistent with the version rather than following the latest version. So you have to know about that as well. Now, let's go ahead and set up the environment first. To set up the environment, we have to open CLI. I'm going to use PowerShell just to replicate the real CLIs that we use when we communicate with the virtual machines. Okay, now we're going to create a folder, the project folder. Okay, dir. So for the people who never use CLI, what I did here is I just created one folder in the basic language, but what I did here is I created a directory, which is our project directory, the root directory, and I named the directory as python-de. mkdir stands for make directory, and there is cd, which stands for change directory. Now I wrote this command mkdir python-de to create a folder basically. Instead of using this UI, this file manager UI, and going to C drive, users and username, and here clicking on right clicking and clicking on new and clicking on folder and creating new folder. Instead of doing that, I just opened the CLI and ran this command mkdir python -de. This created this folder right here, python de. So we won't have any UI to interact with the machine when we work with the virtual machines. We have to use CLIs instead in the real projects, and that is what we're doing here. That is why we have to get habituated using CLIs rather than using UI to create or manage the project structure. And CLI also makes it, we can have more control over our tasks that we do when we use CLI instead of using UI. See, I just created this folder like what in 2 seconds, but if we want to use UI, it is even it is a bit late than using CLI. We have to click on the file manager and navigate through the folders and go to my username folder and then create this. Instead of doing that, we can just have more control with the CLI. That is also one of the advantage we can get. Right now, we just created this folder, which is this one right here, but we just created the folder and there is nothing in this folder. Next, we use cd and cd stands for change directory. If I run this, now you can see the difference, right? Right now it is at the root of the C drive users and my username, so it is here. So whatever the command that I run at that position, this location will reflect at that particular location. But now when I ran this command cd python -de, so it changed the directory from my username to python de folder. Now anything I run in this CLI will reflect inside this folder here. So if I create a folder, we can see a folder here. If we create a file, I can create a file here. Let me show you with an example. For example, say mkdir temporary folder just to show you. Now this will create a folder in that particular folder, right? Inside this folder. That's how. Anything we do inside that folder will be reflected there. Now our next step is we have to create the virtual environment using Python -m. And with this command, I'm creating a virtual environment which is located in the root of the repository, root of our project repository, which is Python D. This is the root. Here we are creating the virtual environment by using this command. So when we run this, there you go. It creates a virtual environment and you can actually see a folder created here. And if you click on that folder, you can see multiple folders and files in it. But what we have to do is we have to activate the virtual environment. To activate the virtual environment, we have to navigate to this file. If we want to deactivate, we have to navigate to this file. So to navigate there, right now where we're at this project root. To navigate to activate file, we have to go venv/scripts / and then activate. to run that file. So we have to go venv backslash scripts backslash activate and enter. And that's how we activated the virtual environment. And if you want to deactivate, you have to type in the same thing, but instead of activate, you have to run deactivate. That's how you deactivate. And another reason for using a virtual environment is to replicate how things are done when you work with a virtual machine. I'm replicating that particular, interface in our local PC. That is it. And also, virtual environment is a lot easier to, you know, get rid of instead of installing all the required tools on directly on your local PC. When we install those tools in this virtual environment, you can just dump them all together if you just delete the virtual environment first from your PC. It is that easy. You don't have to uninstall them one after another. You can just delete the virtual environment and everything that belongs to that environment will be taken out. So it is also easier to get rid of the files and tools that you installed in that environment. Okay, that is how we create virtual environment and activate it. And because now we are here in the virtual environment, we can install every tool or everything that we want in our project right here using pip install. Let's say I need pandas and requests. And run. Now, like I said, we are installing these two tools in the environment and not in our actual local PC on our PC. We are installing them in the environment. So if you want to get rid of these tools from your PC, you don't have to uninstall them again manually. You can just take the whole environment down, and all these tools will go with that environment. So that is done. So those two are installed now. Now we have to do one thing. We have to create a file that lists everything that are installed in this environment, and I will tell you why. Okay. In any project that you work on, anything, I don't care which one it is, any project that you work on, you have to create a text file named requirements.txt to list everything, all the tools that we have to install in order to run that project. Whereas in virtual environments or any virtual machines that you use, you have to create this requirement.txt file. So if you want to replicate this project in a different machine, you can use the same versions. Here what I did is I used pip freeze greater than symbol and requirements.txt. What this particular command tells the PC is it creates a text file because it is requirement.txt with the name of this requirements.txt, and that file consists of all the tools with the versions that are installed in that environment. So if you open this requirements.txt, you can actually see all the things that are installed with the versions. So if you want to replicate this particular project that you did in this virtual machine into a different virtual machine, you can use the same versions. And that is how version consistency is more important. If you don't use these versions and switch to a different version or use the latest version, you might end up getting more errors and the whole pipeline might break. So you have to have these versions included. Even if even in all of our projects, I did create a requirement.txt for every one of them, I think mostly. But for a few, I think for a few I didn't included these versions, the exact versions of the tool that we use. But in the real world, in when you work for an enterprise, this should be followed. All those versions should be listed in a file so you can replicate it in any other environment. Okay. So you see, we install Python and we install requests, and their exact versions are also listed here. As much as the as much as creating a requirements.txt is important, it is also important to structure the project. I mean, structuring the project repository. That is our, I mean, that's not our next topic, but in the same topic, that is what we have to know. So project structuring is our topic here. We already created the root folder project Python DE. I mean, yeah, I just created it with a different name. I just used Python DE. That's fine. So we created the the root repository, and we do have venv, and we have to segregate everything accordingly so everyone can understand. Not just you, but anyone who wants to work on the same project that you're working on. You have to structure everything in a systematic way. Here, everything related to the virtual environment is in that folder, which is already created, right? Which is already created, and we also created requirements.txt, which has all the versions and the tools and the softwares that are installed in that virtual environment. But we are missing with data, a folder for data. We need a folder for data, and we need a folder for src, which is the code. So a folder for data, we need a folder for data to store all the data at one place, and we can segregate the data with the types as well. I mean, not the types, the stage of the data is in. We store the raw data in one folder, and we store the transformed data. If you're using a medallion storage architecture, uh, if you don't know, if for the people who don't know about medallion storage architecture is nothing but dividing the data transformation steps into three. So it divides the transformation into bronze, silver, and gold layers. It's basically like if you are transforming a data from raw, which is a whole string, raw data means a whole string. So when you transform the data, we just do that in three layers. We save the raw data first in the bronze layer, which is this one, and then we create another folder where we store the silver layer data, which will be the cleaned data, and that is one layer. That is a second layer of medallion architecture, and then there is a third layer which is gold architecture, where we store the business ready data, not just the clean data, but the data that is ready for the business intelligence, where we aggregate or group uh, a few rows, or I mean, we group a few columns, and we aggregate a few columns and make the data ready, business ready, and we take out all the data that is not necessary. So these business ready data will be stored in the goal layer. So we separate them. Not just a raw here, we can also include if it is a medallion architecture, by the way. If you don't follow that architecture, it is just a few folders, let's say raw, cleaned, and business ready, transformed. You can structure it that way, but this architecture is the most used ones. It goes like bronze, silver, and gold instead of dividing them into raw, cleaned, and business ready data or any other structure. This structure will be more efficient. So for now, I'll just leave it like that. So you can divide the data according to the data state, whether if it is raw or cleaned or business ready. So yeah, one dedicated folder for the data, and there is one dedicated for the code, which is source code. Everything you store in this folder should just be the logic and not the data itself. So for example, I given it as a main.py representing a main.python file, and then we have readme.md. .md file is .md stands for markdown file. We create a readme.md for most of the projects in professional to make it professional, and the readme.md has all the steps that we follow in that particular project to in order to get that end result. So it includes everything. But you might ask me, what's different in creating a separate .md file which is totally new to people, rather than creating an actual Word document or a PDF with all the steps that a person need to follow? What sets .md file apart of these other file formats is, in .md file you can structure the process in the way anyone can understand. So it is more about readability uh, and not about just uh, defining the steps to be followed. I'm going to show you an example of one of my projects, one of our projects that we worked on the channel. Oh, no, not the YouTube. Let me open GitHub and open one of our projects. I'm going to open the banking modern data stack project. So here you see the readme.md file, and we also have requirements.txt file. This is how you format the project files, the repositories. I mean, this is a pretty advanced project, so it has plenty of folders, which one for Docker, one for data generator, consumer. You can, I mean, you have to. It is about you dividing this, structuring your project in the right way. So talking about README, you see this one. This is the whole .md file that I've written. You see the difference between this writing a .md file and writing a Word document. This is a lot different. The UI and the readability is out of the world. So this is the best way to define your project. You know, uh, should I say it? Should I call it report, or it's just a process? Yeah, whatever. So this is the best way. So you will thank yourself if you take a break like 10 years and return back to this project and you forget everything about the project. And if you created this readme.md file, even after 10 years, you can actually know what you have done before 10 years, because you written everything with the visuals, with the steps, everything written in the right way, and the folder structure as well. You see that? So that is how readme.md is so useful to understand the project, even for you or for your teammates that works on the same project. So this is the best way to do. And that's how readme.md works. I mean, these are all not mandatory, but these are mandatory when you work in the real world or real project in a big enterprise. And you have to know, everyone have to know about it. And that's why I included this topic into this masterclass, not just explaining Python and coding in Python. Like I said, I will also explain the best practices in the enterprise, and I will also explain the debugging and error handling everything included in this masterclass. So that is it with the topic here. And these topics are more important than you think they are. I mean, you will thank me when you understand the importance of this topic when you work on a big project. So you have to, I recommend you to learn these extra topics when you work on a project. Okay, let's head to the next topic. And in this topic, we'll know about core syntaxing, and we'll know how to run these .py files in this virtual environment using CLI. But before starting, I explained the skeleton, the project repository skeleton, but I haven't created any of these folders yet. So I'm going to show you how we can create these folders. Let's create them first. Right now we're at the root of the project repository. We have venv and readme.md created already, and sorry, my bad. We created venv slash the folder, and then we also created requirements.txt file, right? Let me open that real quick. Yep, venv and requirements.txt. What we have to create is we have to create data, src, and readme.md to make it an actual project. I mean, we're not creating a project to make the skeleton ready. So to create a project, to create a folder, like I said, we use mkdir. Mkdir space the folder name, which is data. Hit enter. That'll create the folder. Now we change the directory to data because we have to create another folder inside the data folder. So we change the directory to data, and now we create raw here. mkdir raw. No. Sorry. mkdir raw. So that creates a folder named raw inside the folder named data. Now we created the folder that we need in that data folder. Now we have to go back to the project root repository, which is python-de, to create src at the root. Now we have to go one folder back. So to do that, we run cd dot dot. Hit enter, and you go back one folder. Now you're at the root of the repository. Here we create mkdir src folder, and then run cd src. Here you create a file named main.py. Because that's just an example, the main.py, I'm not going to create the file right now. I will create it later. So let's go back again. And here at the root of the repository, we also have to create readme.md file. We know how to create a folder. We can create it using mkdir, but to create a file, we have to use ni. Ni stands for new item, and the item name is did I spell it right? Yep. Enter. That's it. Now we created a file and two more folders in the same repository, which means we have to see this here. Right now the data as raw folder, and src is empty. Now talking about core syntaxing, let's talk about the few things that everyone has to remind I mean, everyone has to remember before committing any error and crashing the whole pipeline. The core syntaxes in Python includes the data types. You have to remember, yes, of course, Python uh, dynamically assigns the data types, which means you don't have to define the data types when you create one. You don't have to define them like any other coding languages like C or C++, C++, Java. In Python, the data type is dynamically assigned to that data, but you have to remember in few cases where we get the data from a JSON file or any other file, we get the whole data in a string format, and when we parse it, we have to assign the appropriate data types to it. We have to convert the string, the actual integer. Let's say, for example, if we import a data that has amount in it, and amount says 100, when we import it from a JSON file or an API, everything is imported as a string format. Even the amount that says 100 is also considered as a string. We all know that, right? But we have to convert that into integer when we import the data, when we parse it. So we also have to remember that. I know these are all fundamentals, and I said fundamentals are prerequisite for this masterclass, but still, there are a few fundamentals that we have to revise before we go further, so we don't make those mistakes. And then we have indentation. Indentation is nothing but the spaces that we give when we open a loop or a condition, when the space when we give before writing the next line. For example, let's say you open an if condition, if say a equals 3, and you go like that. So indentation is a space that you give here. After a condition or after a loop or something like that. So that is a space that you give to define the main part and define the sub part of that particular code block. And here you say print of, it shouldn't be caps, print of indent. So here, this indentation should be uniform throughout the whole code that you write. The mostly used indentation is 4 spaces. So it's basically 4 spaces. I think here I did use 4 spaces. 1, 2, 3, 4. So the mostly used indentation is 4 spaces to segregate them. But you can use any number of spaces, but that number of spaces should be same, consistent throughout the whole code. You have to remember that. If, for example, if you write this if condition in one of the code, and if you create another if condition with, let's say, 3 spaces, that will fail because you used 4 spaces here and 3 spaces in the other condition. That will not, that will raise an error. So you have to be careful with the indentation here. Whatever the spaces you use, you have to use 4 spaces. Even most of the code editors out there, you can just hit tab and that will place by default 4 spaces by default. But it is not a good practice to use tab. Instead, you have to use spaces. You have to click 4 spaces to indent. And that is one of the things you have to remember when we talk about the syntax. Because this core syntaxing, I have to talk about this. And this is not part of uh, the syntax, but this is a best practice. You have to comment for every code block saying what that particular code is doing. For example, let me open one of my codes I write so I can show you what comments I'm talking about. Say consumer. Okay, this is a code. This is a Python code that consumes the data, by the way. Here, for every code block or every code instance that I write a comment on top of it. So these comments are not part of the code and not mandatory, but this is a good practice when you write a lengthy code. If you're writing a 2 or 3 line code, it is not necessary, but if you write hundreds of lines of code, you basically should write these commands on top of every code block. So when you go back to your code and read it yourself, you'll know what you did. Or if someone else is reading your code, they can understand. Here, you see this? You don't have to, you don't have to write these things. These are just for the to make it look good, but you just need this line to explain what you did here. It says load secrets from .env, and then hash Kafka consumer settings. So whatever line you write, if you include hashtag in front of it, that will not be executed by the compiler, by the Python compiler. That line will be ignored, but you need it for the readability. So yeah, that is a best practice to write commands for every code block, so you will understand what you did for that code blocks. You see that? You see that? I wrote those commands for most of the, I think all of the code blocks. So if I go back to my code and see what this part is doing, I can understand what it's doing. So yes, that is not part of the syntax, but that is one of the factors that you have to remember, and that is one of the best practice to follow. I know these are all part of fundamentals, but I still have to make sure everyone still remember that part, so we can go further. And especially these concepts are theoretical, so I have to, talk about those theories. Now, our next thing, now heading into writing a code and executing it. To write a code, like I said, we're not going to use any fancy UIs, but we don't practically use fancy UIs. We don't have to, but it is best practice to use a compiler or any sort of code editor while you write the code. I mean, that is just an editor. You don't run the code, but you write the code in that editor. So if you make any mistakes, you can see it. The editor will show you. And one of the best code editor I use is Visual Studio editor, which pretty much accepts all sort of coding formats, or any it can open any sort of file. And to install it, you can just head to any web browser and search for VS Code editor and click on download Visual Studio Code editor and choose your OS, Windows, Linux, or Mac, whatever it is, and install it. I will also leave the link down below in the description. You can just click on it. You don't have to go to the web browser and search for it. I will give you the direct download link. So let me open that. And again, this is not mandatory too. This is just for the to make it more visually good. So when we write the code, we don't get confused. So this is the home page, and you click on this one right here on the top left. You click on this Explorer button, and here click on Open Folder, and it opens here. Now navigate to your project repository, which is in C drive, users, and username, and the repository that we created just now, which is Python DE. Click on it, select folder. In that folder, here, click on yes, I trust the author. Here, that whole folder will be imported into here. I mean, not imported. It is just visualized here. You can see it here. You can manage it here. Even if you, whatever you do here will be reflected to that main folder. If you delete this folder, it will be deleted in that actual space. Okay. Now let's create a .py file. So to create all these .py logics goes to this folder like we discussed. So click on that folder and click on this new file, or you can do that using CLI to make it more professional. But just to explain it and make it easier for us to type in, I'm going to use VS Code Editor here. Click on that, click on new file. Here create a file name. Let's say what should I say? I'm gonna say data types example, or say data types py. That should do. So I just named it randomly, by the way. I'm going to write a simple code now. I cannot see my keyboard. You see the difference, right? Typing the code in a code editor instead of typing the code in a notebook or any other thing. So if you type the same code in a notebook, notepad, let's say if you want to type in the same code, print of source, you see that, right? When I open a parenthesis, the closed parenthesis will not automatically opens, and the colors between this source and this source is a lot different, right? So it divides these data types and the object types with the colors in the code editor, whereas in notebook you don't get any of those features. It is just like raw typing, raw text. And also I mean, managing the indentation in notebook is way harder than managing it in the code editor. We haven't used any indentation yet, but I'm going to demonstrate that again with a different code. But right now, this is the difference. You see that, right? It's a lot different writing the code in a notepad or any other static thing and writing the code in a code editor. It's a lot different. Source. Okay, I just wrote this code for an example and also to just include as much as data types I can. So I included a string data type, which is this one, source. And like we already discussed, we don't actually define the data types, but when we import the data from an API, we have to uh, switch the data type from a string to an integer or a Boolean data type accordingly when we parse the data. Here we used a string data type and assigned this orders underscore API string to source variable, and then this integer 100, this is an integer data type, so we don't use double quotes, and we assigned it to record count, and then true. This doesn't have double quotes because this is not a string, this is a Boolean. Boolean data types includes only two possible outcomes, and those two are true, or it can either be true or it can be false. So here we said true, so this is a Boolean data type, and we assigned that to this variable is active, and then we printed everything with this static string at the beginning and this dynamic variable at the end. Now we have this code that is under src folder, and to run it we have to head to the CLI. Right now we are at the root of the repository. What we can do is, if it is a Python file, you say python Python, and we have to navigate to the file, which is src slash data types. datatypes.py, and click enter. That's it. That's how we run it. Instead of writing the code in a notebook and executing it right there, we have to do this in real world. We have to create the .py file and then run it in the CLI. We don't have any user interface to write the code. So that's how it works. Now let's have a demonstration for indentation. This is not going to take much longer because that's a fundamental topic to know. So let's see what type of error we can face if the indentation is wrong. So let's create another file here. Say indent.py, and the example should be if we need to use a if condition, right? You know what? I'll just delete this file. Do not save. Delete this new Python file and rename this one to indent. So because we don't need to demonstrate the data types, so I'm going to combine these two examples into one, indent, and then take these things out. Maybe not. I'll still include these things and write a condition, if condition here. If is active, you see that, right? I mean, here, because I'm writing the code in a code editor, we don't have to worry about the indentation spaces here, but when we write them in any other thing like notepad, we have to type in the indentation spaces too. So from here, by default it gave me 4 spaces, I think. Let me make sure. So it gave me this one, so it gave me this space, but if I type 4 spaces, will it be the same? 1 2 3 4. It is the same. So yes, it by default gave you 4 spaces, but you have to make sure how many spaces you used, or you have to stick with this code editor for the whole project, so you don't make any mistakes with that indentation. So it by default took 4 spaces. Like I said, it can be 4 or 3, whatever the spaces you give, but it should be consistent throughout the whole program. By Okay, now I'm going to run this without the indentation space to demonstrate the error that we face. Here, I'm going to copy paste this part. Indent.py. Do you see that, right? So it says indentation error right here. That is how you check the errors. Yeah, we will dive deep into this error handling later, but yeah, I'm going to explain this part. So it says indentation error. Whenever you mess up with your indentation, this error rises, indentation error, and you have to make sure your indentation spaces are matched with the rest of the program. So now let's give those spaces. Okay, now save it and run it again. There you go. So that's how indentation work. Okay, and that's the end of this topic. From this part, I mean, all the topics we talked about till now, this 1 hour, I think it's 1 hour, right? I think it passed 1 hour. And in this 1 hour, what we talked about is basically Python is a backbone. Python doesn't own anything, but still works with everything. When I say everything, most of the part. So yes, and we also talked about data structures and indentation and the foundations of Python. Now let's head to the next topic. So I divided these topics into hours, and I combined like 3 topics into 1 hour, and this part of the topics, these 3 topics are done, and I'm now heading to the next hour, which is our second hour of the class. Okay, we are just done with the Python foundations. Now let's step into data structures in Python. Data structures is one of the most important topic when you're learning Python for data engineering. And these are the 4 data structures I listed here, which are list, tuple, set, dictionary. And these data structures differ in shape and also differ in properties. And this table represents how they differ in properties. And it differs between the syntax, mutability, ordered, duplicates allowed, key characteristics, typical DAUs. Yeah. We'll talk about each of the parameters in deep, one after another, for all the data structures now. Starting with list. List syntax says 2 square brackets, which means list is indicated with 2 square brackets. The list is enclosed with 2 square brackets. That is how you know that particular data structure is a list. And it, for example, it looks like this. Something like this. So because this is enclosed by square brackets, this is a list. That is how a typical list look like. And the next parameter is mutability. Basically, what is mutability? Mutability means, can this thing change in place? So basically, the difference between the mutable objects and the immutable objects is immutable objects can accidentally be modified. I mean, accidentally or wantedly can be modified once it is created, whereas immutable objects cannot be modified once they are created. And they both have their own advantages and disadvantages, but it depends on the situation we use them. We use immutable objects which cannot be changed once they are created when we want our data to be safe and will not be corrupted accidentally in the process. So that is when we use immutable. And mutable, we use mutable data for, I mean, mutable objects, the data structures, when we don't care about the data safety and we want to uh, change the data structure. Here we already talked about orders. Now I mean, this is the typical list. Now let's see how mutability works. Let's say if I created a function definition, if I created a function, all right, and that function has something that appends two more objects to this list at the end, which looks like, so I say orders so a function does this, which adds, which actually, no, not adds, which just joins these two objects at the end of the list. That is what append do. Append is a list method which adds objects at the end of the list. This actually changes the root list that we created. So the already created list can be changed using list methods. And now when you print orders, let's say you say print of orders, this will print by joining these two objects at the end. Because we used a list method and list is mutable, that is what happens. That is what mutability is. You'll understand more about it when we talk about the immutable object, which is tuple. Then you'll understand the difference between the mutable object and the immutable object, all right? And I will try to demonstrate that as well, the mutability. Okay, now we have that. So the first parameter is explained, and the next parameter is ordered. All the objects in the list are ordered accordingly, and they are all assigned with an unique index number starting from 0 to the infinity. It depends on the length of the list. If the length of the list is taken as L, so the range will go from 0 to L minus 1. When I say that, what I mean is, so like I said, this is a list, right? And for the index number for this list goes like this. The first one will get 0. Nah, that's messed up. Yep. 0. The first one will get 0. Second one will get 1, 2, and 4 respectively. Now we have how many objects here? We have 5 objects, and they are all ordered with the index numbers starting from 0 to L minus 1. The length of the orders is 5 and L minus 1 is 4. So the last one will get 4. That's how the list is ordered. I know these are kind of basic concepts for a data engineer, but still we have to make sure everyone is on the same pace because these data structures is a very important topic for Python for data engineers. So I have to make sure everyone is on the same pace. Okay, so that's how lists are ordered. And the next parameter is duplicates allowed. You can have as much as duplicates in one single list. Like here, you can be repeated 2 and 1 multiple times, and that's still fine. So duplicates allowed. And next, key characteristics. It is dynamic in size. Of course it is. We can change the size. So it is dynamic in size. Index-based access. We just talked about it. It has index numbers and we can access the objects using those index numbers. And I think I forgot to tell you how we can access those objects with the index number. To access the objects with the index number, what we can do is we can just say, so let's say if I want to print 3 from this list, okay, we want to print 3 from this list, what we can do is print of orders square bracket, and 3 has a 3 is in the index position of 1. So we address it with the index number like that, and that will print the output as 3. That's how we address it. So index-based access, typical DEUs. We use lists to represent rows, batches, or sequences. Right? I mean, it's basically a list, so we use list for these use cases. That's how list works. Now let's head to tuples. Tuples are very closely identical to lists, but there is one single change. Tuples are represented by parentheses and not square brackets. Like the syntax says, it is represented by parentheses. So a typical tuple look like orders equals 2, 3, 5, 1, 2, like that. But the only difference of a tuple from a list is tuple is immutable. You know what is immutable, right? Once a mutable object is a mutable data structure is a data structure that cannot be changed after it is created, and the immutable ones, no, sorry, I got it wrong. So the mutable ones are the data structures that can be changed even after it is created, but immutable ones are the data structures that cannot be changed once they are created. Like as in this case. So if we do the same here, if we try to do the same, tuples doesn't have any methods that can append objects at the end of the tuple. It doesn't have dot append method in tuple. So we cannot do that. But if we want to add 2 more objects to the tuple, there is a method that we can use, but it doesn't change the root tuple. We have to create a new tuple for that. So to do the same thing, what we can do here is we have to create a new variable. Let's say orders mod and say orders plus 1, 2. And like that, we can add 2 more objects, but not for the root tuple. We cannot change the root tuple, but what we can do is we can use the same tuple. We can basically duplicate it, but by adding these two uh, objects at the end of the tuple and creating a new variable out of it. Now, if we write print of orders, this will print. This will still print the old orders because we cannot change the tuple once it is created. But if we say print of orders underscore mod, this will create the modified version of the tuple. But the base tuple, the actual tuple is not changed. What changed is, I mean, nothing changed, but what we did is we created a new tuple by adding these two extra objects at the end, and we assigned it to a new variable. That is how tuple is functions. And yes, tuple is also ordered, so we can access objects with the index values. So this has, just like the list, they're all ordered with the index values like that. So we can access those objects with those index values just like the list. Duplicates allowed just like the list. And key characteristics: immutable, hashable. Hashable is nothing but we can access objects with the index number. That is nothing but hashable. Safe to share. This is the unique, this is a different key characteristic that tuple has and not the list doesn't have. It is safe to share because the actual root tuple cannot be changed. It is safe to share. Nobody can change the base tuple, whereas list, anyone can change it. We can just append, they can just use list methods to just change the actual list place. Whereas tuple, it has safety, it has the data safety. Now, typical DAUs, fixed records. The records that are fixed and cannot be added more records or reduce those records. The fixed records can be used for that, and it also can be used for configs, so nobody can change it. So those are the two use cases we can use the tuple for. Yes, like these two data structures, the rest of the data structures also have their unique parameters, and they all have their own situations to be used at. Now let's talk about sets. Talking about sets, firstly, the sets are represented with flower brackets. Well, the dictionaries also are represented with flower brackets. We'll talk about it later, the difference between the dictionary and sets. But now, sets are represented with flower brackets, and they have unique methods that can be used, like unions and merge. So they have unique methods that can be used on sets. And sets, let me write a let me show you a basic set format. I messed up. Forgot the numbers that I used before. 5, 1, 2. Okay, that is how a basic, an average set look like. A set is mutable. set can be changed using the set methods. Like I said, set has a lot of methods, and set can be changed in its place using those methods. But set is not ordered, and also set doesn't allow duplicates. I have to talk about these two. So set is not ordered. It doesn't have index numbers like list and tuple. So we cannot access one particular object if we want to retrieve it. So if you want to retrieve 3 from the set, you cannot use index numbers to actually retrieve the object from that set. So it is not ordered. And also duplicates are not allowed in sets, which means here I did wrote it. I did write the set format wrong because it doesn't allow duplicates. So it cannot have duplicates. It cannot have two twos as objects in sets. So I have to write that again. Which means you know what? I don't care about that. Okay. Yes. Sets cannot have duplicate objects in it. And then we have the key characteristics, unordered, like we talked. Like I said before, it is unordered, unique elements only, deduplication, and the typical the use cases or deduplication. How this deduplication works like is, let's say you have a list of objects and you want to uh, filter that list to have to only have to remove duplicates and only have unique objects, instead of writing a big loop to actually filter them out. You can just convert that list into a set, and the set automatically removes those duplicates. That is one of the use case. Let's say, my bad. Let's say you have a list orders equals 2 comma 3 comma 5 comma 1 comma 2. So this list does have a duplicate, and if you convert this list into a set, if you convert it into a set, the duplicate will automatically be removed. But it can be removed, but the downside is it is not ordered, so you cannot access one particular object from the set, and yes, it is mutable. Those are the properties of sets. And that is how deduplication works. I will demonstrate the deduplication later, and the last data structure here is dictionary. Dictionary also represented by the flower brackets, but the difference from set and a dictionary is set only have a set of objects, but a list or a set of objects. Dictionary have key and value pairs. A typical dictionary looks like, let's say, orders. A typical dictionary look like that. It is a key value pair. The first one, the one before, the one ahead of the semicolon is a key, and the one next to the semicolon is the value. And if you want to access a value from that dictionary, you can call it using the key that is on the other side of the semicolon. That's how the dictionaries work. And then, is it ordered? They are ordered. Are duplicates allowed? Not for the keys, but the values can be duplicates. Keys cannot be duplicate because think about it. If the keys are duplicated, when you call a particular key, what it returns multiple values, and that cannot be possible, right? So the keys should be unique, but the values can be duplicates. The values can have duplicates, but the keys should be unique. And then the key characteristics for dictionaries are key value mapping, JSON like. And then typical DUs is storing records, schemas, configurations. So this dictionary is also good for storing the configurations, and they are good for storing the schemas of the data, and then the records. Okay, that is the difference between all the data structures: list, tuple, and list, tuple, set, and dictionary, and their parameters. Now let's go ahead and do a demonstration. For our first demonstration, let's see the mutability of a list. Let's create another file here and say mutability dot py. And by the way, the objects in the list can be of different data types. Like here, it can be one can be integer and the other one can be string. That's still fine. So it can be of multiple or different variety of data types in one single list. Now we create a function and now we save it. What I did here is I created a list with the variable name as num, and the list has 2 integers and 1 string. Here 1 and 3 are integers and 2 is a string. Then I defined 2 functions, and the first function is, wait, here, sorry. Yep. And the first function is number of, which appends the digit 4 at the end of the list, and then assigns num to a, and then return a. So what it does here, it appends 4. So it actually changes the actual state of the list, the root list. And here we defined another function named alpha of, and we said num.append of. This time we used 4, string 4. I mean the alphabetical 4. And then we assign the num to b and we return b. Now let's save it, and now when we run this code, what happens is, for here when we print this particular statement, which actually prints the output that is returned from this function. Here we are appending 4 to this list. So we are actually changing the base list structure. So this will be modified, and then after, when this function runs, it again appends another alphabetical 4 at the end. So it has the number 4 comma the alphabetical 4 to the same list at the end. So when we print these 2 functions, this will print just the number 4 at the end, and then this will print number 4 and the alphabetical 4 as well, because we changed the base. Let me show you practically. So here, let's run it. Now you see that, right? The numerical function, it says, so it has the actual list combined with the number 4, the integer 4 at the end. And because the root, the base list changed, when we run the function again and we append another object to the same list that is already modified, and add this alphabetically spelled 4, the old change that is happened because of this function is still reflected, and then adds another alphabetical 4 at the end. That is the mutability. So to avoid this, and if you don't want to change the actual structure of the main list, what you have to do is, instead of doing this, you can just do this. And same with this one too. Take this out, and do that. Now, when I run the same code again, this time it gives our desired output. That's how mutability works. Right now, because this is just a small program, you might think this is silly, but when we write big programs and when we use append, we might get mistaken the function, and the whole pipeline, the whole output might change, might differ from our desired output. So we have to be careful while using these mutable data structures. You have to know about this concept. Okay, we're done with the mutability demonstration. Now heading to the next one. Now for our next demonstration, I'm going to demonstrate how to filter out records using lists. the list filter dot py. Let's create orders equals square brackets. I don't have to. Okay, now I created a list of dictionaries just to represent a table of data, because dictionaries are very good at representing a record, and a list is very good at representing a sequence. We're going to combine them and say list nested data structure, sort of a nested data structure here. So we do a list of dictionaries, and each dictionary have two key value pairs. One is order ID as key with the order ID, and country as key, and the country name as value. Wait, I'm filtering out IN, not US orders, Indian orders. All right. Okay, this is how I'm filtering now. So I created a list of dictionaries which represents a table with two columns, order ID and country, and have everything listed here. So basically this one represents a table, like I said. So it is something like, let's say, a table like this. No. A table like that. So the first column is, say, order ID, and the second column is country. This one says 1, 2, and here this one says the country ID, like that. So we are representing this table in this format, list of dictionaries. That's how we are using it. And let's take this down. Okay, and then we created another list object here, but right now it is an empty list, nothing in there. We created that to store the filtered output in that list. And I say IN because I want to filter out the Indian orders, because it has 2 Indian orders and 1 US order. Now I'm going to filter out just the Indian orders from this list of dictionaries. Now for orders in orders, so for this loop, it iterates through all these dictionaries in the list. First it takes this dictionary and sends it to the if condition, and in the if condition it takes order of country. I think I forgot to tell you how to address. I did tell you how can we address an object in dictionary, right? We have to address an object in dictionary using the key of that particular value. So if you want to address a country, this value, which is a country ID, from this dictionary, you have to you can address it like this: order square brackets, and then the key, which is this one. The key for this value is country, right? So we address it like that with the square brackets. But this is not a list. We also use square brackets for dictionary as well. Also for the tuple, when we address anything in tuple, we also use square brackets for that as well. And then we make sure the country is equal to India, IN. So that is the comparison operator, which makes sure the country is India, and then that filters out if the country is India, that particular dictionary will be filtered out and appended to the empty list that we created, and then we print the list of dictionaries, the filtered list of dictionaries that has India and the orders from India and not from the US or any other country. So we just filtered out Indian orders from like that. Well, this is just an example how these data structures work. Now let's run that. Python src lists filter .py. Okay, we did got an error. Oh, here. Let's try that again. No, I ran the wrong program. And one more error here, which is this. Should supposed to be orders. Now this should run. Okay. Now the output, in the output we filtered out all the orders. We filtered the orders only from India, and we filtered out the orders that are from US. See that? Only the dictionaries with the country India are filtered out. Okay, we're done with that demonstration as well. Now, let's have a demo of deduplication. We talked about sets. When we talked about sets, we said it has the use case of deduplication of a list of objects. So let's have a look at it. Let's have a demo of it. Let's create another file, another Python file, deduplication.py. I'll try to make it faster. Now first I'm going to create a list of objects, and this list will have a few duplicates, and then we convert this list into a set. So we print that output, that set. So and see if the duplicates are taken out. That's enough. Let me add one more duplicate. That's enough. Okay. Say IDs, because that is appropriate. We have to say IDs because we have multiple IDs in it. Then we convert the list into a set. Print of unique order IDs. Now let's save it and run it. Python deduplication.py again. Okay. Oh, here. I spelled it wrong the second time. Okay. Now let's do that again. There you go. Now the printed set with the flower brackets, so that represents a set. So the printed set doesn't have any duplicates. We did initially put some duplicates in the list, like here. So the 101 is repeated twice and 102 is repeated twice. But the output, after converting that list into a set, doesn't have any duplicates. So it only has 104, 101, 102, 103, just the unique values. That's how deduplication works. That's one of the applications of using sets. I mean, that's not the application of using sets, that is an application of converting a list into a set. Sets have a lot other applications like using union, merge, there are a lot other stuff. I hope you know that because they are the fundamentals, like I said, but these are the few topics we have to know about the mutability and order and the duplications before we step into the actual data and work on it. Okay, we're done with that as well. I think it's time to hop on to the next topic, which is dictionaries. Let's dive deep into the dictionaries now. Talking about dictionaries, dictionaries is the top data structure among these rest of them. But I also explained these other data structures just because you have to have an idea of those as well. When I say dictionary is the most important one among the rest, what I mean is any data that you pull out of an API, you get the data in dictionaries. If you convert a JSON into a dictionary, that is a dictionary. I mean, the data that you get from a JSON is also dictionary, and the configurations on dictionary format, the schemas are also represented as dictionaries. So dictionaries are everywhere, literally. So yes. Now let's have a demonstration of how we can structure a dictionary. Let's head back to the code and code editor and now create another file. Let's say dict demo.py. Now let's create a dictionary. I'm going to say as so we're not going to get the data from API now because here the main concept is about dictionaries, but I'm just going to mock the data structure that we possibly get from an API. So you'll know. So when we pull data out of an API, that might look like this. Most of the data that is represented using an API is a dictionary mostly. So and I'm going to use a dictionary inside a dictionary. So this is a listed data structure, listed dictionary basically. So we're nesting a dictionary into a dictionary that has the customer details, which is ID, okay. Here I'm trying to mock a response from an API. If you request a pull from an API, you might probably end up a data that looks like this. Can be nested data structures with a dictionary inside a dictionary and a list of dictionaries inside a dictionary, like this one. So this is a list of dictionary, and this list of dictionary is inside another dictionary. So that is a nested data structure. So you might end up with the data that is structured in this format. And the data here represents the orders. It has an order ID, which is 101, and the customer has a nested dictionary which indicates the customer ID and that particular customer name, which is Alice. And the next key in the dictionary is items. Items has a list of dictionaries in it, which means items also have SKU, which is A1, and price, which is 100. And there is another dictionary with SKU as B2 and price as 50. And the country is the last key, and the value of that is US. Okay. Now look at this. By looking at this data, does it look systematic or ordered or uniform? No, right? The data looks so ugly. But this is how APIs return us a data if we pull data from APIs. We have to order it and we have to make it uniform. We have to parse it basically, and we also have to assign the data types to it. Here, I think the data types are correct because I wrote it, but when you pull data out of a real API, the data types are also messed up. So you have to parse it and assign the appropriate data types to all those values. Now we have that. Now structure. Let's structure this dictionary of data. So I'm going to structure it with the first column as order ID. Okay. Now I'm creating a new dictionary which is structured orders just to structure that particular data in the right way. And the first key in this dictionary is order ID. And this order ID, the value for this order ID is equal to or is represented by the value of the key order ID in raw API response, which means this value is equals to this in this one. And then we have for the next column, say customer ID. And for the customer ID, at the source, we have a dictionary inside the value, but we only taken customer ID for this particular key. So we refer to raw API response of customers, which is a key. So this, so we refer to this one right now. And then inside that, because that is a nested dictionary, we refer to ID. So in this value, we refer to ID again. So we refer to this one. So this will be the value for customer ID. And the next key will be customer name. The same thing like ID, we refer to for the customer name, we refer to the raw API response, customer's key. So we're going to retrieve that, and from that dictionary, we referred name key, which is this one. And that's the value, and we assigned it to this key in the new dictionary, the structured orders. And for the total amount, we refer to, okay, for the total amount, we use sum of. So we're summing off a few values. And what are those values is item of price for. So we're choosing item of price for item in raw API response. So we open the loop here and we choose an item. So one object for item in raw API response of item which is this list of dictionaries. So we are chosen one item at a time, which means one item means one dictionary at a time. And from that dictionary, we're choosing item of price, which is this. So we're referring with the key price, which means the value 100 and 50. First, the value 100 will return and the value 50 will return. And those two will be summed up, and the total will be assigned to total amount key in our new dictionary. Have country. And for the last key, we're going to refer to raw API response country key, which is this one. And there is just only one, so we don't have to do any of these extra nested dictionaries thing or this summations thing. So we just refer to this key and this value will be written anyway. So that's how we parse the data. After we get the data from an API, which apparently be in a dictionary format, then we parse it into this structured orders format to make it, to segregate them. And then now let's print the output, which is the structured orders. I really think I'm gonna face an error because I'm so bad at spelling things. So let's see. I'll run it. DICT demo.py. Now, unfortunately, the code was correct. There was no error, and I got the output. And the output is a dictionary of key value pairs and not nested dictionary or nested data structure. This is just a regular dictionary with key value pairs with order ID equals 100, 101, customer ID, and customer name. But since we only defined one record here, we only got one record as output. Okay, that's good. Okay, with that, our next demo is also completed. And by the way, all these files, all the .py files I'm writing right now, will be given to you because I'm going to upload these to GitHub, and that GitHub link, the repository link, will be given to you down below in the description. So you can just, copy paste those codes if you want to learn, or you can write parallel to me so you'll get some hands-on experience like I said before. But if you don't want to, you can just copy paste those codes that I will give you in the description. Now, with that, our second hour is also done, which is data structures. We have to move on to next topic, but before moving on to the next topic, by the end of this topic, you have to be prepared. So next time you see a data, you have to question yourself, what shape is this data is in? Is it in a list? Is it a list or a tuple or a set or a dictionary or a nested data structure like a dictionary of dictionaries or list of dictionaries or yeah, those types. You have to question yourself first. And then what else do you know? What else do we discussed? So the data that we get from API might be so messy, we can structure it, we can parse it, and we also saw how we can parse it, like in this code. And those are the outcomes for this hour. And now, yes, let's head to the next topic now. Now, for our next topic, let's talk about file handling. And first, we talk about reading and writing files. If you think data engineering is about creating fancy frameworks, you're wrong. It is Data engineering is mostly about reading files, writing files, moving files, and not breaking when the file is ugly. This is what the flow goes like. We we spend more time importing, I mean, with the inputs and outputs throughout the whole pipeline. We use files to manage how data lands, how data is backed up, and how data is exchanged between the systems. We create the files. We even if we want to exchange the data between two systems, we create a file and then exchange it to the other receiver side of the system. So most of the time, we just create them. We read, we write, we just transfer, we move. That is basically how we data engineer a data. Now let's see how to actually create a .csv file using Python without without pandas. Let's create a .py file in the same source code folder. Name it csvwrite.py. We need to import CSV because I'm going to write a CSV file. I'm going to create a CSV file with the data in it. So we have to import the module CSV here. So the structure of CSV is simple. Well, CSV stands for comma separated values, and the structure of CSV is simple. It just needs to have the headers followed by the records. And that's why we just define a variable with list of lists. And the first list of lists defines the headers, which includes order ID, customer, amount, and country. And the second list, starting from the second list till the end, all of those are records. And these records are assigned to their appropriate columns by the index values by typing into the correct index values. So yeah, the depending on the first list, any value in the next list in that index value will be assigned to this one. Likewise, the second one, which is with the index value 1, will be assigned to customers, and 120.5, which is the amount, will be assigned to amount, and this position will be assigned to country. So they the map the values using the index values of the list. Now, to write those values into a .csv file, we use with OpenOff, and we name the CSV file that needs to be created. And I name it orders.csv, comma, and whatever we type in next, if it is W, that stands for write, and if it is R, that stands for read. So when you write the data into a CSV file, we use W, and if you read the data from the CSV file, we use R there. Right now we are writing the data into this CSV file, so we used W. And then we assign csv.writeOff and F. So with this width, we aliased it as F, and then csv.writeOff F, which will be our writer, will be assigned to this variable named writer, and the writer dot write rows method. By using that method, we are going to write all the rows which we defined before. The list of lists will be written into the CSV file that we are going to create, which is named orders.csv. Now, when we run this program will create a file named orders.csv and writes all the data that we defined in the list of lists, which has the variable name as rows. Now let's save it. And open the CLI and run the code. Python source C. csvwrite.py. Okay, we did got an error. And the error is simple. Here we are supposed to use writer of f, because that's a writer. It should, I just spelled it wrong. I have to use a writer instead of write. Okay, now let's run that again. So that is executed. Now that will create a file named order.csv, and this file is created in the root folder because we executed the code in the root folder here, right? So because we are right now in the CLI, we are in the root folder. So the any program that we execute in the root folder, the output, the returned file, will be saved in the root folder. If we go inside the src, or if we go inside the data, let me delete this orders.csv real quick, and let me show you how it is done. So we go into the data folder. Now we are here inside the data folder, and now run that again. No, sorry, that doesn't work like that, because it cannot access. If I go into that data, it cannot access the actual code. So we cannot do that. We have to go back. But what we can do is, we can either save the file in the root folder or inside the src folder. So right now I'm going to leave it like that. I'm going to run that again, which creates a CSV file in the root folder right here. Let's open it. You see that we just define the comma separated values, the first list of lists, define the headers, followed by the records, the rows. These are the columns, these are the column headers, and rest are the rows which we defined. And that is a .csv file. You can open that in Excel as well, Microsoft Excel. That is how we create a .csv file. So this is a .csv write demonstration. Now let's see how we can read it, how we can read from a .csv file. Because we already have a .csv file, we are going to read from that file that we just created. Like I told you, we're going to use with, but instead of W, we're going to use R to read from the file. Let's do that. Let me close all these tabs. Create a new file. CSV underscore read .py. Of course, we need to import CSV for the CSV operations. And with open orders.csv. R, like I said, R is for read as F, reader equals CSV dot reader of F, print of row. Now what this does is, we imported the package CSV, and we used with open orders.csv. We used R instead of W, like I said, to read from the CSV file. And the CSV file name is orders.csv that we already created as F. And reader equals, just like the writer, we also have to define the reader first. reader, csv.reader of f, and then so it reads the CSV file. After, it just prints print of row. No, wait. Right now it just reads the data, but we have to create a loop first. So it goes through all the list of lists, all the rows one after another, and then print it. So to create a loop, let's use a for loop and say row in reader. So it picks one row from the list and then print of row. So this is correct. So it prints every record in that data. Now let's save it. Go back to CLI and here run it. .py. Now this prints all the rows that we defined in the .csv file. See that? So it also prints the header. But in the real world, when you read these .csv files into your program to actually work on the data, what you actually do is you ignore the first row because those are the headings, the headers. So you just ignore the whole first row and only work on these rows, and then you assign your own headers according to your willing. So you just change them. That's how you work with these things, with these headers in the real world. You just take them down. You don't use them usually, but if you use them, that's fine. And also, you also have to assign the data types. Right now, whatever you got the data, when you read from a .csv file, everything you get will be strings. You see this one? All the lists that you read from the .csv file are all strings, just strings. Well, order ID is actually string, that's fine. Customer is also string, that's fine. But amount should be float, right? Because it has 0.5. So it has to be float data type. But here, that is also integer. So you have to parse it. And you have to enforce the schema. When you read it, it don't automatically get the schema to you. You have to enforce it. Whenever you read data from any of the source files or source APIs or any of that, any data source, you have to enforce the schema onto that data. It don't come into the program with the schema enforced by free schema enforcement. You have to do that by yourself. You have to parse it and then assign the data types to them and then structure it in the right way. And then you can work on it. Well, now we know how to read the data and write the data into a .csv file. But there is also one thing we have to know. Another important thing, which is writing to a .txt file. We can write and read from a lot of files, a lot of types of files, but the .csv file is to write and read the data, but the txt file is mostly used to write or store the configurations, or let's say the logs that the program might produce. So we store those logs in a text file. Now let's see how we can actually write a program to write .txt file. For that, let me minimize this. Create a new file. I'm gonna name it txt. So I'm going to name it txt write.py, and in that we do with sample.txt. So this is supposed to be right. Just like that. Just like we did for the .csv file, to write into a txt file, text file, we do the same thing. We use there are a lot of methods to write and read from files, but this is one of them. That's it. We use with open and the text file name, which is sample.txt, and the method we are going to use here is writing into the txt file. So that's w, and as f dot write of pipeline started. We are going to write a static string into the text file, and that is pipeline started. And this symbol, you might as well know about that already, but I'm going to tell you that is uh, that represents a new line. So pipeline started will be in the first line, and pipeline finished will be in a new line right underneath pipeline started. So that's why we used here front slash n, that defines a new line there. So everything after that will be started from the new line. Now let's save that. Head to CLI and run that as well. Python src txt write.py. There you go. That created a sample.txt file. Like I said, pipeline started will be in the first line, and pipeline finished will be underneath it in the next line, because we defined the new line here. And that's how we write a .txt file. Now, I talked about this topic about creating a CSV file and writing a CSV file and reading a CSV file because, well, in most of my projects, the CSV file that I used, I never got those CSV files from any websites like Kaggle or anything. I create my own CSV files instead of depending on the sources, the free sources. Well, I did depend on free sources while when I get the data from an API, but if I'm I'm using a CSV file, I created my own CSV file by writing this code. That doesn't mean you have to write the whole data that like this that we're going to use to create the CSV file. You don't have to write that data. You can just ask ChatGPT or any other AI model to write the code for you, and you can customize the code, customize the file according to your needs, and that's the beauty. If you want to include a few errors in that data, you can do that too. And the code uh, doesn't look like this at all. You don't just write all the records like this when you ask ChatGPT or any AI model. It just gives a list of so let's say for this column, let's say order ID, it just gives a list of order IDs, and it picks, no, not for the order ID. For order ID, it gives a random int or something like that. And for customers, it gives a list of customer names and picks one customer name from that list randomly for every row. So that's how the code, it writes the code. Instead of writing the raw records by itself, it uses that. So when we create like multiple, I mean, huge data, I mean, not huge data, medium data, like 100,000 or 50,000, you don't write the whole data like this. It is so not efficient. It uses that way. So it creates lists and create the records according to our preference. We can customize it however we want, and it writes those data into .csv file. You can do the same with .json file or any other file format type. You can do the same thing. You can create the file, or you can read the file, you can write the file, any type of file it is. Okay, we're done with that. Now let's head to the next topic. Now we know how to create a .csv file for the data, but there is another thing. The new type of file, I mean, not the latest one, but which is more flexible than CSV file, that is JSON file. Now let's talk about JSON files. CSV files are good to store data, but they are old. They're not new. But JSON files are new. And the reason why I'm saying that is, like, we already talked about this. Dictionaries are the best way to work with the data than any other data structures, right? And the best way to store dictionaries is in JSON format. We cannot store dictionaries in CSV, right? We cannot store dictionaries in .csv file. The best way to store a dictionary is a, by the way, dictionary is a Python data structure. So to store this dictionary, the best way to store it is by a JSON file. JSON is so flexible, it can store anything you give it. It doesn't care about the size of the file, I mean, or whatever you give it, it just stores it. So, so JSON is best to store a dictionary. I mean, it doesn't have a schema, it doesn't need to have a schema. Two records that are stored in JSON can be completely different. Unlike the other file formats, this is more flexible, and that's why uh, we use JSON to mostly store the dictionaries. If you uh, watch our previous projects, I do the same. I work with the dictionaries in the code in the Python, and then I just dump these. I mean, I just convert these dictionaries into JSON files when I'm transferring or storing it somewhere. And so, yeah, that's how we use it. Now, let's see how we generate a JSON file. Let's create a .py file again. JSON. Write.py. And now we are going to store a dictionary of data. This is the data. This is the same data that we used last time when we talked about dictionaries, nested data structures. These are the same data that we used, but I'm just going to use one column here, just to not waste our time. Okay, so this is a nested data structure too. Now we are going to store this in a JSON file. It is so hard to store these type of data in any other file format, but JSON takes it like a champ. So let's store it with open. Now we used with like the other two methods. I mean, like the other two file formats, we use with here as well. With open, and we name our file orders.json, and we define the method we are using. We are writing, so we say w as f. We use json.dump, and there is json.load. So there is json.dump and json.load. Json.dump is used to convert a dictionary into a JSON, and json.load is used to convert a JSON back into dictionary. When we import a dictionary when we store or import or move a dictionary to another system, or to the receiver, and at the receiver side, you only need to do one step. You just need to use json.load off, and your dictionary is back working on that program. That is the beauty of using JSON with dictionaries. So when you use json.dump off, it just dumps the whole dictionary into a JSON file, and the dictionary is data, and f, which is what we defined, and then indent equals 2. We're defining the indentation as 2. We already talked about indentation, right? Indentation is the space that we create, like this one. I mean, like this one. That is not right. So this is appropriate, like this one. So we define the indentation as 2. So we get 2 spaces for the indentation in the JSON file. And that's the difference. I mean, when I say you can save everything in JSON file, it doesn't care. I mean, it's the same as it is also same with the text files too, right? You can save anything in a text file, but the difference is this: if you dump a dictionary into a JSON file, and if you load it back in another program, or another program, it retains its state. You can get this format of dictionary back again, but if it is a text, you'll get a string and you have to convert it again. And that's the difference between using JSON for dictionary and any other file format. I hope you get that. Now let's save it and go back to CLI and run this. JSON write.py, and just like that, orders.json will be created. Now let's open that, orders.json, and there we have it. So we formatted this, by the way, and the JSON knows where the dictionary starts, where the list, and where the dictionary ends, everything. So it formats like this. with the indentation that we defined as 2, which means 2 spaces. You can see here. If you can't actually see it, I'm gonna zoom it to make it bigger. I'm trying to zoom it. View. Oh, I forgot how to zoom. Whatever. Okay, you see that? Just to make it clear, I'm going to backspace 1. Okay, 2 spaces. See that, right? So the indentation we defined as 2. So the indentation will be 2 spaces here for everything. And that's how it formatted that. Now we know how to write a JSON file. Let's see how to read a JSON file. Let's create an other file for reading. Okay, other.py file, and name it json.read. Now json underscore read dot py. Import JSON. You have to import the JSON package because we are working with JSON. We do the same thing with open of, and the name of the JSON file orders.json, and the action that we're taking here, which is read. So that is defined as or, and after as f. Now data equals json dot we already talked about it. We use JSON dumps to convert a dictionary into a JSON. To dump a dictionary into a JSON. And we use json.loadsoft to load a JSON back into dictionary. So we use JSON load of f. It is that simple. For order in data, for order in data of orders, I'm gonna close all these files. I forgot I only saved one order. Okay, now print of order. Save. Now let's see if this JSON file will load the data back into a dictionary. Say Python src JSON read.py. There you go. See, that is not a string. This is an actual dictionary. We converted a dictionary into a file format, which is JSON, and then converted it back into a dictionary again. That is why it is so favorable to dictionaries to save dictionary in a file format. This is modern because this is a more efficient way to store dictionaries, but storing data, not the dictionaries, storing data, there are a lot of other modern technologies out there like Parquet format, which takes less space comparatively, and there is Avron, Avro. Yeah, there are a lot of file formats to save the data, which takes less space respectively, and also saves the logs with them. but JSON is the best for saving dictionaries and retrieving back. I mean, saving dictionaries in file format and retrieving them back into dictionaries. Okay, that is done. And to make sure it actually converted that back into a dictionary and not a string, let me show you. Let me just flatten the whole file, because right now it is so clumsy. The data is not structured in the right way. It has nested data structures. It has list of dictionaries and a lot going on. So we can just, let me just flatten it, flatten the dictionary, and that will prove what we just did. I'm going to create a new list, an empty list. For order in data, which is our dictionary right now, of orders, and a colon, started a loop, and okay, now in the dictionary we took orders. First we called the key orders, so we call this, that means we call this whole thing. This whole thing is the value of this key, so we call this whole thing, and up to this, I mean yeah, up to this, so we call this whole thing. And from this one, should be items, and from this one, items in orders. So we called this particular list of dictionary and then now, yeah. So we call this thing from that, and there item. So we picked one item first. So we pick from items. We pick this one first, right? Yeah, yeah. We picked that one first, and then flattened it. For order ID, we picked order of ID. We picked order of ID first and assigned it to order ID, and we appended this whole data into to the list, the empty list rows. And the second column is SKU, and we got that from items of SKU, which is this one. This items key items of SKU, which is this one. And then we got the quantity from items of quantity, which is this one. So we just flattened them, and we only picked the data that we need, and we ignored the rest of the data that we don't need. That is how we deal with the data in real world. The API, when we get the data from API, it has a lot of data that we don't need, and it is so clumsy, just like this. It is even more clumsier than this. This is just an example, but getting data from an API is more clumsy and has a lot of data that we don't need. We just ignore the data that we don't need, only pick the data that we need, and then flatten the file so anyone can understand, like this, just 3 columns, just with the columns that we need. And then save it. That's how we deal with the data that we get from an external source. And we have that. Now let's run it. Go to CLI, Python, src/json underscore read.py. Okay, I did spell something wrong, I guess, for items in orders. Okay, right here. So is it supposed to be orders oh, it's supposed to be order, not orders. Okay. Now let's run that again. There you go. Everything worked fine. So yeah, the data returned to its past state even after we converted into JSON format and saved it, and then loaded back into the Python data structure, which is dictionary. I mean, list a nested data structure, which includes dictionaries and lists. So it didn't change the state of the data that is saved. It just converted it back into the dictionaries. And we worked with the data, and then we flattened the data from this clumsy data into these two dictionaries, which is ordered in the right way, the list of dictionaries. Okay, we're done with that. Now we're also done with the JSON read and writes. Let's talk about OS and file path handling. Think if you want to import or export from a path on your PC into your code, right? If you're writing that path statically, which doesn't change, even the code runs in a different system, the code obviously fails. When I say that, what I mean is, for example, if I write a code which imports a file from my local PC, and the file is at this path, C drive, users, and my username, and this project root. That file will be imported if the program runs on my PC. But imagine if the same code with the same path is run in a different PC. Will that work? That will not, because the path changes in that other PC. If I use the same path that I used on my PC on another PC, it doesn't work, because their users might have a different username or a different, the path itself. So we cannot just hard code those paths when we work on an enterprise grade projects. We instead have to use dynamic paths, and in this topic we're going to talk about those paths. defining the paths dynamically. Let me close this. And of course, let me demonstrate that to you as well. Let's create another .py file again. .py file, and let's say os demo.py. Import os, and then now let's run this. So what I did here is I imported the OS package. Now with that, you can use the methods get cwd, which stands for current working directory. So you can get the directory that you are running this code at. So that prints that, and then os.list dir of prints the list of directories in that list. It prints the list of items that are present in that directory. Now let me demonstrate it. Now let's run the code. Say python src slash os demo.py, and here, should I zoom it? And here it prints the current working directory, which is this one, right? So it prints that current working directory and the list of items that are present in the directory, which are these. You can see here, these are the items that are present in that directory. And the reason that we use these tools, these methods is, like I said, let's say you want to import a file, okay, a file that you created, let's say the orders.csv file, into the program. If you don't think about the other PCs and only think about your system, you'll just write the whole path, right? Like C colon users colon J. So you just write this. You just write this path and say slash orders.csv. You'll just do that. But it will run on your PC, fine. But if you want to run the same code in a different environment or different PC, will that actually work? That won't, right? Because even if he runs in the same exact folder name, the Python repository, the root repository name, and he has the file at the exact same location, but still the username will still change, right? So instead of just defining this path statically, what if we define it like this? Use this command here. What about that now? os.getCwd will return the current working directory. No? Yes. So it returns this one, right? So basically, it returns this file path, and that's the same thing. But on top of that, what it offers you is If you still copy paste this in a different environment or different PC, that will still dynamically change the file searching path and still get the file no matter what and no matter how it is stored. No matter where you run the program. And that's how we use OS. But using OS is kind of old, and there is a modern way to do this. Let me also show you that, also demonstrate that. Create another .py file, of course, and say so that method is path library. Instead of using OS, we use path library here. And if you want to get the base path, just like we did in the OS, we do this: double underscore file and double underscore again dot resolve of dot parent dot parent data path equals base path slash data slash and print of data path. Instead of using OS, this is the modern way to get the file paths, and you can define the file paths dynamically according to the environment or the piece or the system that you run this program on. And this modern way has more features that you can access than the OS. So that's why this is modern and mostly used right now. And now let's save it and run it. So it literally says, I named my .py file path library, so consider renaming the file since it has the same name as the standard library module named path library and prevents importing the standard library module. And that's why you have to be uh, cautious when you name your .py files. If you name your files same like the libraries that you import with the same name as the libraries you import, you might face this error. Well, I myself forgot and named it that way, so now I'm going to change it. Pathlib, say path demo. That should do. Pathdemo.py. Now let's run that again. Python src. There you go. Wait. I forgot to change the name. I spelled the name as pathlib again. I just renamed it. I forgot. Python src slash path demo.py, path demo.py, enter. You can see that, right? So it changes accordingly. I never defined this static path. I used path library to import path and then dynamically got the root path where the program is running, the base path. And then I added these two. So it straight away goes to data slash raw and search for the files inside the folder. That's how we can dynamically define the path instead of defining a static path which will break if the environment or the PC where the program is running changes. That is something you have to know about when you work in a production grade project. And now that's the end of this hour. And in this hour, by the end of this hour, we know how to generate files, read messy data, and flatten the file. The flatten the data. I already demonstrated that. And then we know how to handle real world JSON files and how to avoid path related bugs or disasters. Now, let's head to the next hour topic. All right, our next topic is functions, modules, and packages. Let's talk about the functions first. Let's say you're writing a Python code for a pipeline. If your Python code for a pipeline looks like a lengthier script with a single used Python lines, you're doing it wrong. Well, your Python code may work, and if it does work, it is not efficient enough. It is not about writing the program. It is about predicting the reusable programs, the reusable code lines. That is where function comes into picture. You, instead of writing the same code lines again and again, repeating them again in your program, in this you can actually define a function. We already used function before in these demonstrations. I think I haven't explained about functions yet. So yes, uh, we define a function, and in that function we define the programming lines that function executes. And whenever those programming lines, whenever that task that the function defines needs to be executed anywhere else in the program or outside the program, we just need to call that function and pass the parameters if it takes any, or we can just run it directly wherever we want in the code. So we just write it once and reuse it. So that's make the Python code more efficient instead of writing the lengthy code where you're not supposed to write. Where you can use these reusable codes and still decide to write them anyway again and again. That is that doesn't make sense and makes it more hard for you to look back because the length of the code increases. Talking about the function, let's talk about the flow of the function, how these functions work. Let's go back to the PPT and let me create one more slide. I'm going to create a duplicate for this and pull it, drag it underneath this slide. Say function flow. We don't need all these blocks. We just need 3. So we have this. That's it. This is how the flow of the function goes. We define a function, and whenever we want to execute the tasks that that particular function do, we just call that function. We input the data if it asks any, like the parameters we pass to the function, and get the output from the function, which will be the task output that the function does. It is that simple. And yeah, and there are a few things or principles that you have to remember when you use a function, when you create or define a function. Firstly, it is about idempotency. Idempotency means no matter how many times you run the function, it should generate the same output. It should return the same output no matter how many times you run the function. Let's say uh, you create, let's say you create a function that adds plus 2, yeah, that adds two variables together and produces the output, right? So whenever you input the data, input the data for the two variables, the function outputs the data, right? But if you run the function twice, again and again, no matter how many times you run, unless the input is the same, the output is also should be the same. Output should not change no matter how many times you run the function. You might think, well, how would that change? There is no way it changes, right? But no, it will. It there is a chance the output of a function change. I'm going to demonstrate both the types, the right way to write the function and the wrong way. So you will know the difference and how the output may change if we retry. And this idempotency is so important because, you know, let's say when you create a DAG or create a whole workflow for Apache Airflow, so, right, you create a whole DAG file with a few tasks in it and run that in Airflow. What Airflow does, Airflow runs a task, but if the task fails, it retries, right? So what it should do is, even if it retries or even it reruns the same task, it should still produce the same output for the same input. Output should not change. That is what idempotency means. Every function should pass idempotency. That's how we create a function. We have to make sure that that is approved. And let's head to the demonstration. And like I said, I'm going to demonstrate the idempotent one first and then the non-idempotent friendly one. Okay, let me get to that. Got it. Let's head back to the VS Coder and create a new python.py file. idempotent.py. Now let's define a function. To define a function, we start with def. When we call a function, we just call with the function name and a parenthesis. And if there is any parameters passed into that, we define the parameters inside the parenthesis. So now for defining, we use def for the definition. Oh, def doesn't stand for uh, define, by the way. It stands for definition. So we are both are same, right? Yeah. Yeah, def, we are defining the function now. Def transform orders of raw orders and a semicolon. And here, from now, whatever the steps we write here will be part of the function definition. Now, whenever we call the function, all the steps inside this definition will be executed. And say transform equals list for order in. So in the function definition, we're defining this step first. We're creating an empty list named transformed. And then we open a loop, a for loop, where we pick order in raw orders. What I'm planning to do here is I'm planning to create a function that transforms the data that it gets, the raw data. And raw data will be a parameter that is passed into this function. And from that raw data, it selects one object from that particular list at a time and sends it to transform.append of, and then order of order ID. I haven't think about the data I'm going to use here, but I'm just going for it. I will create the data next. Amount, float, order of amount. Let's let that be amount too. Country. Dot, say upper of, then return transformed. What I'm trying to do here is from the raw data, raw orders that I'm getting, I'm going to select one object from the list, and from that one object I'm going to pull out the order ID and assign it to order ID in this new list that we're going to create. New list of dictionaries, to be clear. So in that dictionary, for this key, I'm going to assign the value of order ID from that raw orders. And the next value will be amount, and the amount will be orders amount will be taken out of orders of amount from the raw orders data, which we haven't defined yet. I am going to define it. And then the amount, because that will be in string format, we are going to switch it. We are going to convert it into float, not integer, float, because amount will have the point digits, right? So we convert it into floats. And for country, and for the key country, I'm going to choose orders of country, and I make sure I make the alphabets, I convert them into uppercase, all the lowercase to uppercase. So I make sure everything has uppercase, the country name. That's the transformation, and it returns the transformed list of dictionaries. So I'm going to flatten the raw orders data. Oh, now we have that. That's it. Right now we're just defining the function. If you run this, nothing happens because it's just a function definition. It doesn't have the inputs yet. I told you, right? This is how the flow goes. So right now we just defined this part, just the functions part. Now we need to give the input data to this function, and then we get the output from the function. And here in our case, in this function, transformed will be the output. The input will be given as a parameter in this particular spot, raw orders. So whenever we want to call this function anywhere in the program, the only thing we need to do is say transformed orders of, and pass the data set, or pass the data structure that you're going to send it. Just say raw like that, and this will get the output, and assign the output to some variable, any variable. Let's say transformed, and like that, the output from that function definition will be assigned to transformed. Assigned to this variable. That's how our function definition work. Now let's give it a sample data and see how the function works. Take that out and let's create the sample orders. Right now I'm creating everything, and I'm just inserting the bad data as well. Like here, I'm assigning 100 as a string to this key. So that can be later converted into float. So I'm going to do that, and country. And also for the country, I will just say US in lowercase. Later it will be converted into uppercase at this transformation. So I'm just wantedly ingesting some errors into this. I mean, they're not actually errors. ingesting some bad format into it. And one more dictionary, one more record, just to make it clear. Say 200. Say India. Okay, now I created a list of dictionaries, a list of 2 dictionaries, which basically represent a table of 2 records. And then I'm going to pass this data into that function and see the output. Now say transform, like I said, how we call the function. We just call the function name, which is transform orders, and in between the parentheses is where we pass the parameters. And in this case, sample orders. We'll just pass this as a parameter in the parentheses. So when you pass this whole list of dictionaries or any object this variable belongs to will be passed into this function. And then this is how you understand the function definition, all right? Here you send sample orders, but sample orders changes, I mean, it don't change, but think just to make you think like a compiler. So this sample orders just switches to raw orders. When we pass it as a parameter like that, so it changes to raw orders. It changes its variable name to raw orders. Now, wherever the raw orders is present here, it is nothing but sample orders being there. Okay. Now, what happens if I run this? So when I run this, we are calling the function that we defined already, and we're passing sample orders as a parameter into the function. Like I said, it changes its name to raw orders inside the function, just inside the function. And then the first step will be executed. It creates an empty list named transformed, and then it opens a loop, a for loop, and picks one object in raw orders, which is nothing but sample orders data, which is this. So it picks one object. So it picks this one first for the first loop because it's a for loop. So it picks this one as order, and then passes it into a loop. And here transform.append of, we already talked about append. Append is a list function, so it just combines whatever on the right side to the list. That's how it works. So we append it dot append of, and we create a dictionary inside it, and inside the dictionary we pick order of order ID. What is order? This part, this particular object from that list is order. So we pick order of order ID, which is order ID. So it picks one first and assigns it to order ID. And then it picks amount from the first dictionary, which is this one. And that is 100. Well, for our eyes, we can read it as 100, but for the compiler, it is a string. So this 100 will later be converted into float here. So that becomes, instead of being 100 in double quotes, this converts to something like 100.0 because that's float. It converts to this. So now that is float. That is eligible for arithmetic operations with any integer or float. Now that is no longer string after that. And then goes to order of country, which is this, which for the first loop, it'll be US, and dot upper of is a method that we can use on a string that makes that particular string convert that particular string to have all upper cases. Now this US with lowercase converts to uppercase like this, with the double quotes, of course, because that's a string, so it converts to that. And the same thing, and yes, that is the first record, the first dictionary in the list, and then it loops back because there is one more objects to be picked from the list, from the raw orders list, which is basically sample orders because we passed as a parameter. So for the second loop, it picks this dictionary and does the same task that is done for the first object that is transformed, and the whole, I mean, both the transformed records will be appended to transformed list and then returned, right? Now when I run this, I may not get any output because I'm running it, the function executes right, but I cannot see it. So let me print the output. Print transform orders of sample orders. Now I can actually see the returned transformed list printed. Let's head to CLI and run this program. Python src idempotent.py. Okay, there is an error, which is a name error. And where is it? So it is at line transformed. Oh, okay. I spelled it wrong here. Supposed to be transformed. Here too. It's supposed to be transformed, and I think that's it, right? Transformed. Yep, I think that should do. Now let's run that again. No, that's not the error. What is it? I still didn't see that. So I did spelled it wrong again here. It's transformed. Okay. Yep, now they match. Now let's run that again. Okay, there you go. Now that executed. Here we define the function. So no matter how many times you want to use that method, you can just call that function with this single line and not write this whole code block again and again in your code. You can just call that function whenever you want to run those tasks on any sort of data. And that is why reusability is a main factor to consider when it comes to performance. and that reduces the length of the script that you write. See, so I just called the function here, right? I just called it and I gave it a parameter with the data and it returned the result perfectly. The data types of amount is converted and the country is also converted to uppercase. If you take a good look at this, let me zoom it. Okay. Yep. So this is not a string. The amount is converted into a float and the name of the country is converted to uppercase. Okay, now this is the idempotent friendly data function definition. Now let's see what non-idempotent function definition looks like. But before going further, I also have to show you one more thing. So if I run this function twice, because I have to prove this thing is idempotent friendly, right? So if I run this again, so I copy this print statement and call the function twice, one more time. Okay, now I'm basically running the same function twice and let's see the output now. It's the same. The output doesn't change, right? So that is why it is idempotent friendly. Now we see the non-idempotent version. For that, let me create another file, of course, and name it non-idempotent.py. Here, we just change just one line from this code, and we'll see what happens. Okay, just going to copy this and paste it here. But just by changing this line alone, cut it from here, and then define it before, define it outside the function. So define that list outside the function. Now if I save this and run it, which means should be taken out, say non-idempotent, non hyphen, so non-idempotent.py. Okay, now let's run that. Here, for the first print statement, which will be our first function execution, well, we got the right output, which is this one. We got the output. The order ID equals 1, amount equals 100. 100 is integer, country is capitalized, I mean, turned into upper cases, and the same with the order 2. So this print statement works fine. But when we call the function again for the second time, that doesn't produce the same output. You see that? This is the output. Let me zoom it in so you can see. So this is the second execution output and this is the first execution output. So it just prints a list of 2 dictionaries. But the second function definition prints a list of 4 dictionaries. What basically happened here is we define the list outside the function, right? So it only defines as an empty list once in the whole program. And whenever you call this function again, it won't initialize to an empty list again. Whereas in idempotent, we defined this empty list inside the function. So whenever you call this function, this empty list will be initialized as an empty list again. All right. I told you, right, how the list.append works. Remember that, the immutability, that's the concept happening here. So whenever I run this, whatever the list has will be wiped off, and we make an empty list assigned to transformed. But whereas here, we only do that once, and that is outside the function and not inside the function. So at first, it works fine. But from the second time, it just adds up. It just not add up. It just combines the outputs next to the first output. So if you run this again, the same code again, this will change again. Let me show you with an example. So if I copy paste this and run the same code again, the same function again. No. Oh, that is because if I run the whole program again, that will initialize. But I have to run the same function again, not the program. So I'm going to copy paste the print again for the third time. And now we can predict the output, right? That will produce a list of 6 dictionaries now at the end. You see that, right? So this is the first execution. The first function call, and this is the output returned for the second function call, which has list of 4 dictionaries, and the 2 dictionaries are repeated again and again. And this is the third execution, which has a list of 6 dictionaries. So every time you run that function, the output is different, and that makes it non-idempotent. I think you got the difference here, right? We just changed the initialization being to be outside the function, so it don't run. It only run once when the program is executed, but not. It don't run every time the function is executed. So it just appends to the already stored data in the list. It just appends the new data to it. So you have to make sure when you create a function, no matter how many times you run the function, the output should be the same. It should not change. And that is one of the things you have to remember when you define a function. Okay, we're done with that. Now, next topic is modules and packages. Talking about the modules and packages, the codes in real world are not just one files. We know we can define a function and reuse it anytime we want to do the tasks that are defined in the function. We just learned it, yes? But there is something else you have to learn. When you code in the real world, you don't just code in using one single file. What we actually do is we think about the reusable task that we use in different codes, not just one single program, but in different files. So we find those repeatable tasks that we will or we can possibly be using in different Python files. And what we do is we create utilities for it can be for data transformation or file helpers or data utilities, and we save all those utilities in one folder so we can access them in any different Python file. When I say that, what I mean is, let's say I defined this function here, yes? But what if I say, you don't have to define this function in this program, but in another program, and then import that function into this program and just write this one liner inside here, and it still works. And that reduces this size to this. So I mean, it only adds one more line where it says import and something blah blah blah. So it just shrinks the code and makes it, I mean, segregates these functions in different files. It might be a slightly confusing, but I'm going to explain how that works right now. Let's open. Let's create a folder here. You know what? I just forgot to use CLI to create files and folders at this point. Uh, yeah, I'm going to use CLI for now. Okay. And yes. mkdir. I'm going to create a folder for utils, which represents the utilities that anyone can use in any other program other than the same exact one. So we define the functions in programs in Python and save them as utils, so we can import the functions from those utils into any program that we write and use them with the one liner. So for that, I'm going to create a folder named utils src utils mkdir. Okay, that created the utils folder, and now we also have to create a file inside it, which will be done using ni. We already talked about it. New item src utils, and then say transform.py. That should create a .py Python file inside utils. Let's open that and define a function that can get an input and generate an output, which is idempotent. To do that, you know what? Let's just use the transform orders definition again, because why not? It's just a demonstration. We're not going to convert or transform anything. Returns transformed. Okay, now save this as a util. Now, this is inside the utils folder as transformed, as a transform orders function. Now I'm going to create a .py file in src, in the source code in here, and name it, what should I name it? Utils demo. Yeah, that should be perfect. Utils demo.py. And here I'm going to write, define the data first. I'll give the data. Instead of writing the data, we already wrote the data here. I'm going to copy the same data, because why not? Why can't I do that, right? I can do that, so I'm just going to copy that so I don't waste your time here. So now I got the data. What I can do here is get the result, say result as a variable, result from transform orders of data and then print the result. Okay. Well, this will not work. We are calling the function transform orders and we are passing the parameter which is our data, but this is defined in the utils in a different program, in a different Python file. So how we can import it is we have to use from utils dot transform. This file name can be anything, but utils is the mostly used folder name for this because it does make sense, right? Right, the utils. I mean, the utilities that we need will be stored in the utils folder. So utils is a perfect name for the folder. So it is used to store the utils. Utils dot transform dot py. So we say transform. We don't say py here. We say utils from utils folder import transform and from utils folder from Python file. Now import the function that we defined inside the transform.py, which is this one. So import that, copy that, and import transform orders into this Python file. Now we imported that function, a function that is defined in a totally different Python file that is saved somewhere in a folder named utils, and using that function to execute here. You see the size difference here. You see uh, these two programs are basically doing the same. You see how long it is? This is 20 lines. uh, if you take out the spaces, the extra spaces that I gave for the readability, it is still like 15 lines. But whereas this one, if I take these two lines, it basically is like 7 lines. So we came all the way from 15 lines to 7 lines because we defined the function in a separate .py file and saved it in utils. So we can reuse this function definition in multiple files in multiple .py files. That is the beauty of using the modules and packages. You create your own module and you can use it anytime in any Python file you want. That makes the code shorter. You see how short it is? That makes the code shorter and less complex to read. Me seeing this is so easy to read, right? I just define the data. I just call the function transform orders. And the transform orders is imported from utils transform import transform orders. And then I go to utils and open transform.py and see what's the Python function that is defined here. It is that simple. Now let's run this. Open CLI here, run Python src slash utils underscore demo. Utils underscore demo dot py. Boom. That's it. We got the output. We got the same output that we got for this lengthy code with just this like 6 lines of code. It is that simple. You see how clumsy this is and how free this one is. So that's how we use it. I mean, this is not too clumsy yet, but let's say in real pipeline projects, this might be 100 or hundreds of lines of code, right? And then that will be clumsy. Instead of just writing everything, defining the function and writing or scripting everything in the same Python file, we using utils and saving them in a different folder or different as a separate file makes it a lot better to read and navigate to it. And it also helps us understand the logic more easier, a lot easier. I mean, imagine with just this 50 lines code converted, I mean, switched to a 7-line code. Imagine a 200-line code. It can be written in like 150 or at least 120 lines, right? So yeah, that is how basically these things work. And yeah, our next topic is main guards and entry point. Yeah, main guards and entry point. Main guards is one of the misunderstood topic by most of the people. You already might have seen something like this before. Wait a minute. No. Okay. You probably already would have seen something like this, where a function that has an if condition and for the half of the function, and the if condition says something like that, and then uh, there's something underneath the if condition. So you might already saw this line. This line is called main guard. So the main purpose of this line is basically, uh, like the name says, it guards. It is the main guard. When we define a function, okay, let's say like the transform orders we defined in transform.py utils. So when we define a function in a .py file, and if we only want half of that function can should be to be executed when it is imported into another file like here. So if you want only half of the function to be executed when it is called or imported into a different Python file, and you want to protect the other half not to get executed when it is imported to another file, and but it should be executed, it should be run when it is executed in that in the same file basically. I don't know how to explain it. Let's take an example like this here. We have transform.py. You know what is transform.py, right? So we have transform.py. This is where we defined our function transform orders. Yes, and we have utils underscore demo dot py, and this is where we imported the function from transport.py and executed inside this code. So if the function that you defined in the transform.py, if you don't want to run the whole function when it is imported into utils.demo, you can use if condition for that particular part and say and define with this logic, and this logic stops to execute that part when the function is imported into another .py file or Python file, but the rest that is outside this if condition will execute, but anything that is inside this if condition will not execute. This condition makes sure that function is getting executed in the main code, in the main.py file, and not imported into a different foreign .py file. That is how this main God works. I hope you understand, but if you don't you worry. I'm going to demonstrate right now so you will understand. And by the way, I forgot to mention one thing. Here, when we created a folder named utils and we saved the utilities in this folder, well, the latest folder is capable to actually find these files or import these files from this folder, just from a regular folder. But if you ever happen to work with the old Python, if you ever get to work with the old Python, in the Python, the older versions of Python requires to have one more file under the utils that says double score init double score dot py. Is that right? Let me see. Yeah. So this file should be this is this should be this will be an empty file, but this file should be created in the utils folder. Only then this folder and this anything in this folder can be imported into another Python file, or else it will not be considered to be imported in the older version. But the latest version, the latest versions, a few of the versions doesn't need that. That is not mandatory. But if you are using the older version of Python, that is mandatory. I forgot to mention that part. But for now, we don't need it because we are using the latest Python version. I'm going to delete it. Okay, now heading to the demonstration for the main guard. Okay, now let's create now let's create another file in the utils, inside utils. Create one and say what should I call it? Main guard. I'm gonna call it guard util. I think that's fine. So I'm gonna call it guard util, and here I'm going to define a small function first. Print of, let's say, starting pipeline. Say dot dot dot. Now define a function. Say run of and print of running pipeline logic. Okay, we defined that as a util now. I haven't included the line that we talked about, the which was that the name equals main. We haven't included that if condition yet, but first we'll try with this and then I will show the difference between those two. So we have this, and then I create another Python file in the source code and say god demo.py. And here I'm going to import from utils dot god util import run and say run off, save it. Okay. Now if I run this program, slash god demo.py. Now it did run that function, right? And what the function do? Now it prints everything. It prints starting pipeline, it prints running pipeline logic, and it runs once here, and also I call it again, so it runs twice. So it prints running pipeline logic twice, right? But what if I change this a little bit and say if underscore underscore name and double underscore again equals parenthesis double underscore main double underscore, and inside this if condition, if I say this print statement here, right, and also the run, okay, now what do you think will happen? If I run this, if I run this file directly, it will print both of them. It will print starting pipeline and running pipeline logic. But if I import this function, import this file into another .py file, it will not print. So to practically demonstrate it, let's run it. Oh, my bad. Now let's run that again. Copy this, paste it, run it. Oh, it did. Oh, okay. It only runs once because we call the function. It only run one time here because we called it in here. So this function is running, not this one. Yes, but if we run this .py file, it prints twice. It don't print twice. It don't print twice. It prints starting pipeline and running pipeline logic, both of them, and that's how it works. So if I run that godutil.py file itself by itself, you see that it prints Oh, yeah, well, I spelled it wrong, but yeah, it prints starting pipeline, running pipeline logic, both of them. But when it is called into another .py file, this returns false, and this, because of this if condition, these two will not be executed. And that's how it works. I think you got the logic here, right? If you want to hide anything from, I mean, not hide anything, if you want to prevent something to run in another .py file when it is getting imported, you say if name equals main and print uh, and inside the and put everything inside that if condition, and that will not run in the when you import it into another file. That's how you prevent that. I mean, when you import this function and run it, you only want to run this particular function. You don't want to run anything outside it. You don't want this stuff to be run on your uh, Python file, right? So that is why we put everything under this if condition. So it only runs when this Python file itself run on its main and not getting imported into another .py file. That's how it works. Now when you import it, it only prints this, it only runs this function and not everything else. That's how you prevent it. And that's it. That's with that we are done with the main guard as well. And to wrap this hour up, in this hour we talked about what? We talked about functions, modules, and packages, right? We talked about the we talked about isolating the logic, reusing the same code again and again, and then we also used protect execution, which is the main guard. So we are pretty much done with that. Okay, now let's head to the next part of the hour. I mean, not the next part of the hour. Let's head to the next hour with a new topic. Now, our next hour topic is pandas, and the subtopic is pandas internals. Well, pandas is a data wrangling tool. It is basically used for transforming data, uh, understanding data. It's basically used to play with the data. But pandas does have few limitations. So, and so for that, we have to know about the pandas internals first. Pandas is a single machine in-memory tool. What that means is pandas can only run on one single machine. It cannot divide or distribute tasks to multiple machines and get the multiple processing to make the task run faster. We cannot do that with pandas. Pandas can only work on one single machine. So that is in-memory uh, tool, which means if your data doesn't fit in the memory in the memory in the PC or in the machine that you're working on, it cannot exceed or extend the memory. If it doesn't fit, it just crashes or it just stops. And that is why these tools are there. Well, the pandas can do everything with the data. The technical part, it can do everything with the data that PySpark or SQL does, but the limitations of pandas are a lot. Pandas is will not it cannot be used for big data. It only used for a small certain amount of data. To know more about pandas, we also have to compare pandas with Spark and SQL, where Pandas runs in only one machine, Spark runs in distributed clusters, like we talked before. And SQL as well. You know what? Let's just create a table and compare them accordingly. So it'll be more clear than me vocally explaining it. So to create that, I'm gonna draw a table and divide it into, I mean, I don't know how to draw a line with this. I mean, I can draw a line, but I'm not sure how. But so I just, compress that box thing into a line. So I created this table, and now let's name it with the headers. First one is Pandas. The next one be Spark, and the next one be SQL. Now first let's talk about Pandas. Pandas, like I said, it works on single node. It cannot extend to multiple nodes. It only works on single machine. So let's say single node, and then it is in memory too. We also talked about that. So we say in memory. And lastly, it is only useful for small to medium datas. Small or medium datas. Okay, should do. So it is single node, it is in memory, it works in memory, and it is only useful for small to medium uh, sized data. Now talking about Spark, it is distributed. So if a task, a job, if uh, I mean Spark runs on jobs, right? If there are multiple jobs, these multiple jobs are given to multiple clusters according to the load, and these jobs will be executed parallelly uh, throughout those clusters. So it is not just one single machine working, it is extended to multiple machines. So it can scale horizontally, whereas pandas cannot scale. Then we have cluster memory. Pandas works on in-memory, but Spark works on cluster memory. So memory also can be, memory can be extended according to the clusters. And then Spark can be used to work on large sized data sets. Now talking about SQL. SQL is engine based. So initially SQL used to only SQL is used only to query the data that is already created initially, but as the time changed, now SQL combined with these modern tools like Snowflake and DBT, SQL can actually scale horizontally and have these parallel nodes working together at the same time, which makes it faster. As push down This can be SQL can work with the large to a very large data sets. So SQL can work on large or very large data sets. So this is the difference between all these three tools. Pandas, single node, single computer, single memory in memory that is present in one single computer. So it cannot be scaled in the clusters nor in the memory. So it cannot scale, it has no room to scale except for the local PC. So that is why it can only be worked on the small to medium sized data. Whereas Spark, it depends on the tasks and the jobs that we execute. It scales to multiple clusters, to distributed clusters according to the load. And the memory is also cluster memory. We can extend it. We can scale it too, scale the memory too. And that's why Spark can be used to deal with the large data sets. Now there is SQL. SQL alone is just used to query the already ready data, but SQL combined with these modern tools, like I said, Snowflake or dbt. So, and that's why it says engine based. So you see engine based. And let's take an example. If SQL combined with Snowflake, Snowflake does allow multi-clustering, just like Spark. It it does allow multi-clustering. It can open multiple clusters according to the task that we are assigned to that SQL, and we can use SQL for transformation too, with combination of SQL, a Snowflake, or dbt. Dbt also can be used for data transformation. That is how SQL differs. SQL by itself cannot do, but according to the engine that is being used for with SQL, that can scale horizontally too. And then we have memory push down, and then we have and this SQL can we can work with large two very large data sets. I think now you got it. Let me just wipe this out. I might just create a table in a PPT, right? Oh, I just remember I already have a table here created in the PPT which shows Pandas versus Spark versus SQL, but still I did created it again with on the screen. But whatever. So yes, this is already created, the table. You can find it in the PPT that I'm going to give you guys. Okay, heading back. Well, yes, because of its limitations, Pandas cannot be actually worked on the real pipelines, but data engineers still needs to learn Pandas because, well, Pandas is not that useful for data engineers, but that is useful for data analysts or data scientists, you might think. But still, data engineers also need to know Pandas because think about it. When you work in a real company, you don't directly implement the transformations to the actual data, to the actual big data right away, right? You don't directly go dump that logic using Spark or SQL on the main data. First, you have to validate the logic. You have to work on a small chunk of that big data, and then you have to make sure that works, and then implement that on the real data, on the real system. You got it, right? I mean, this is how it works. When you work on the data. You don't work on the actual data, the big data that comes in every day. You take a chunk of that, the data set, and you work with that chunk of the data set using pandas to understand the data and make sure the transformations that you are going to implement, it is like testing, maybe. You can call it testing too. So you implement those transformations on the data and you see the errors. You find the errors, you find the lacking flaws in the data, and then write the process or the logics that you're going to implement on the data to make it perfect or the data ready. And then that is the only time you reflect these uh, transformations into an actual large scale machine which uses Spark. That makes sense, no? I mean, who would make you work right away on the main system using Spark with multiple clusters? That makes no sense. You cannot just implement any transformations directly on the data, on the big data right away. You have to test it out with a small chunk of data using pandas. That is how it works. You don't right away go to Spark and open multiple clusters and do the data transformation that you are not sure what you're doing there. That doesn't make sense. That makes that might make the pipeline break that is already running, or it might raise the expense for the company because Spark opens multiple clusters, and if the transformation doesn't make any sense, or the code that you write doesn't make any sense, the logic, all that cluster, all the computational power is just going it is just waste. So before working on the main system, uh, the infra, you work on the chunk of the data, that particular small chunk of the data with pandas and understand it, uh, write down the flows and do the possible logics that you can do to transform the data and make it ready. Then you reflect it on the big system. And that is the main reason of you being sure of using pandas, even if it is not going to help you with the main system, but when you work with the chunk of the data, the the data that is similar but smaller than the actual system, actual, the infra data, I mean the actual infrastructure data. Okay, that is it with that. Now our next topic is data cleaning and transformation. This is where we talk about cleaning the data, cleaning small to medium data sets before we handle it to the real system. Okay, let's head back to the code editor here. Go to our source code and create a new file. Create a new Python file. Now, now we import pandas, but we import pandas as PD. We are basically aliasing it with just PD. Instead of using pandas every time, we can just use PD when we alias it. That's why we did that. This is not mandatory, but this is the best practice and makes it easier for us to call any method from the pandas um, every time. So you don't have to write the whole name pandas. You can just say PD dot uh, whatever it is. And we can import NumPy. By the way, NumPy is numerical Python. It makes numerical operations much more easier than we doing it with the logics. But I don't think I'm going to include that. So let's take that out. Say df equals, by the way, working with pandas, we work with the data by converting the data into data frames. We're not going to use dictionaries or any sort of data structures. When we work with the data, we convert the data into data frames. Data frames is nothing but a two-dimensional table. Just like the two-dimensional table, it works like a two-dimensional table. df equals pd. Um, 1, 2, 3, 4, 5. Six, 7, 8. Okay. Okay. Okay, now here we're creating a pandas data frame from this data. And this is our first column, which is order ID. And the values for this column is uh, begins from 1 to 11. So which will be 10 rows starting from 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 rows. And then the second column will be amount. And we knowingly inserting some errors in this. We're inserting some, not errors, null values in this, and to just to show you how we can clean the data later. Well, this is valid 100. This is a null data. There's nothing in that field. So I'm going to show you how to deal with these stuff and how to do the data wrangling with pandas. Yes, this is the list of the values that that column going to have, and then we have country column with countries listed. Right now I only use 2 countries, so that's fine. Now with that code block, we actually created a pandas data frame and assigned that pandas data frame to df. Like I said, a data frame is nothing but a pandas data frame is nothing but a table with columns and records in it. Any data that we wrangle using pandas, we convert the data into data frame because that is more convenient to work with. And now I'm going to convert this data into a .csv file. Before, remember when we talked about the topic handling files, where we created the CSV file and where we saw how to write write a CSV file and how to read it. And this is one of the one of the ways to write a CSV file using pandas. Now I'm going to demonstrate that. df dot to CSV. I'm trying to avoid talking while I'm typing because when I talk while I type, my mic doesn't, the noise cancellation on my mic doesn't work because both the noise are coming into it and it is listening to both of the sounds, my voice and the keyboard sounds simultaneously, and it is hard for the mic to uh, cut off the noise, do the noise suppression. So I'm trying to not talk while I type. Well, I explain after I type, well, after I stop typing. So that makes my voice more clear. Now, this file here, like we already talked before. So this, here we created a data frame. Now we are creating a .csv from that data frame. So it converts into a .csv file, which is a comma separated values, by using this method, df.toCSV. Here df is the variable name that we assigned for the data frame, and we use .toCSV method, which is the pandas method, pandas data frame method that we can use, and we converted it into a CSV file with the name dirty_orders.csv. And comma, this is one of the parameter we defined, and we use this parameter to make sure the index values will not be converted into an extra column in the CSV file. When we create a data frame, it also gets with an extra column that is index, and those are auto generated when you create a data frame. And when you convert it into a .csv file, or when you ingest the data frame into a .csv file, so you have to make sure you don't convert the index values into another extra column. I mean, it's up to you. If you don't want it, you have to make sure you define index equals false, so it ignores the index values and takes just the values that you want and creates a CSV file for you. Now save this. and let's run it. Open the CLI and slash pandas underscore generate.py. That took a few seconds, and it did create the .csv file. You see that? And it has 10 rows starting from 1 to 10 as order ID and amount, country, and everything. So, and also wherever the locations that we defined the data as none, there's nothing here inserted into the .csv file, which indicates the empty uh, fields. We will deal with the empty fields when we do the data transformation, when we work with the data. Now, I created the file here, right in the root folder, but I don't want to create it in the root folder because we created a folder named data to store the data files, right? I forgot to actually explain that and actually create these files inside the data folder. But now let's delete this and slightly modify the file creation so it creates the file inside the folder, inside the data raw folder. To do that, say data raw slash dirty orders.csv. Now save it. Now let's try running it again and see if it creates the .csv inside that folder. It did. There you go. Now it is not here. No, it is not in it is not created in the root folder. It is created in the data, the place where it's supposed it belongs to. And we saved it under the raw folder because that is just a raw CSV folder. We'll create another .csv and we save that .csv in a different folder and name it, let's say, cleaned. Instead of raw, we say clean data, and we save that in that folder because that makes it more appropriate. Okay, now we have that. Moving on. Now let's see how to we saw how to write the data into a .csv file. Now we see how to read the data from a .csv file using Pandas. Now let's save that and create a new file. And we're going to do the cleaning also in the same file. So we name it pandas underscore clean dot py. And first, of course, we have to import pandas and alias it with pd. Mostly everyone who uses pandas does this. They alias it with pd because that makes it more easier to refer to it and use it pretty often. Okay, we do that and then df equals pd dot read underscore csv of So this is the method that we use to read a .csv file. Just like the the method that we use to write into a .csv file, which is toCSV, here we use read CSV to read a .csv file. Now we copy paste this path so we can read it from that path. We can read the .csv file from the path. Then let's print the data frame first and see if the CSV actually converted into a data frame or not. Before we did the same with the JSON, right? JSON to dictionary and we converted a dictionary to JSON and converted the JSON back to the dictionary, and that doesn't need you to the conversion doesn't give you the string, it actually converts it into the data structure. The same applies here as well. We converted a data frame into a .csv file. When we convert back convert this .csv file back to the data frame, the everything, the file types and everything stays the same. It will not convert back to into a string or something like that. It converts back with the actual structure of the data frame uh, that exists before. To prove it, we're going to print that data frame that we just read from the .csv file that we created. Now let's open the terminal again and run this Python src slash is pandas underscore clean.py and run it. There you go. And in the data frame, in the actual data frame, when you print it, this is what you see for the null fields. For all the null values, this is how it is represented. NaN. Yes. I also talked about the index values, right? Every data frame has index values, and these are the index values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it starts from, just like the list, it starts from the index value, starts from the 0 to n minus 1. This is how data frame is structured. It is exactly structured as a table, and that is why it is a lot easier to uh, use pandas to work with the data, because the data is structured as a table, and we can do functions that we can do functions with pandas on the data the exact way that we use that we do functions on SQL, the tables using SQL, and the Spark as well, the same thing. So yeah, this is how it is saved. This is how a data frame looks like. Now we have that. Now let's head to the next one. We already wantedly ingested a few null values in our data, right? Now to fix any null values, no matter, you don't have to remember where those null values are. There is one method that you can use that instantly fixes all these null values. There is fill_na, or there is a lot of other methods where which in pandas to actually deal with these null values. One of that is fill_na. Fill_na stands for filling the null values with the desired value that we define. To do that, we say df of amount equals df of amount dot fill na of 0. Now the output actually says we inserted the null values in the amount and we want to fix that. I mean, here to make it to make these transformations, to explain these transformations, I inserted these null values, but in real world these null values are created by default. You don't insert them, uh, just to make it clear. Okay, so to deal with all the null values in that column, we use this method. We say df of amount, referring to that amount column in the data frame, and say equals to df of amount dot fillna of 0. What this does is fill every null value in this particular specified column and replace all the null values with 0. It is a lot better to have any other value instead of a null value. And we don't supposedly fill the null values with 0 every time, but it depends on how what data and how you want your data to be ready. We can replace those. There are a lot of methods. We can replace those null values with the average, with the mean of all the rest of the values of that column. We can do that as well, or we can take the lowest value of that column, or we can take the max value of that column and replace the null values with that as well. There are a lot of different ways. Now we are using fillna. We're filling all the null values with zeros. And now let me print that after I do that. Okay, let's go back here and run it. Run the Python code now. See that, right? This is the first data frame which has null values in amount column, and this is the second data frame after dealing with the null values and replacing all the null values with zeros. See, like I said, having zeros is a lot better than having null values, because imagine if you want to do any arithmetic operations with that amount. Let's say you want to take the total sum of the whole amount. Having null values will definitely cause a problem, and you don't want to deal with that. And that is why we replace the null values with some sort of values. So the output will not get disturbed. Now that is done. And if there is any bad data, like uh, the data types, let's say if there are any strings in the amount, you don't want them, right? Amount should be integer. To change that data types of that particular column's data, using Pandas data frame, you can do this. And writing this makes sure everything in that particular column is of integer data type. It makes sure every particular field in that column is integer. If it is integer, it leaves it as integer. If it is not, it converts that into an integer. And then let's see how to uppercase all the country names. Are those already? Yeah, they are already in uppercase, but we're going to run that anyway. I'm going to show you how we can change the cases of strings. So for data frame, to change the cases of the fields, the data that is in that column, we do it like this. Say country equals df of country dot str dot upper of. So we convert everything in that column to uppercase. If you want to convert it into lowercase, we just replace upper with lower. Let me do that. Because we already have everything in uppercase, I'm gonna use lower here instead, just to show you the syntax works, and run it again. We don't need to print this again. But now run it. See that? Everything converted into lowercase. Now let's convert it back into uppercase. There you go. That's how we convert the cases for the strings. And the final topic we are going to talk about in Pandas is group by and group by aggregations and window logics. This is where Pandas implement the topics that are from SQL. These group by and aggregations are basically the SQL topics, where it groups the columns and aggregates the rest of the values. These are all the SQL stuff, and this is where Pandas can also Pandas can also do these SQL stuff using Pandas. I mean, with Pandas data frames. Like I said, Pandas data frames are basically like tables, right? So you can do whatever SQL does. I mean, what SQL does with these group by and aggregation with the SQL tables. I mean, the actual tables with these data frames which act like tables. So we can do the same with the Pandas as well. Now let's have an example of group by aggregation. Say country underscore summary equals a parenthesis open. Say df our data frame dot group by. We are grouping using country. So we are grouping all the countries in that data frame, which is so-called a table. So we're grouping all the countries in that. And then dot agg, which stands for aggregation, and a parenthesis open. Total orders equals parenthesis open, order ID, comma, count. So we're aggregating this column using count, and I'm going to explain what we're doing here actually, but I'm just going to read out what I'm actually writing here. Total amount equals amount sum. Then at the end, print of country underscore summary. Okay. This is something most important for you to understand. This is uh, if you already know, if you already ever worked with SQL, you probably would already know about these group by and aggregations. If you haven't worked on SQL at all, I already did a video on SQL for data engineering, but that is not a masterclass. That is a speed run where I just touch all the topics at once. So you can just watch that video. So you'll have, by the end of the video, you'll have an idea of all the topics that are present in SQL for data engineering. You'll be more familiar with that. So if you are interested, go check that video out. Yes, here from the the data frame that we have, which is this one. So from the data frame we have, so first we group by the country. All right, so we group by the country here. We group by this column, country. And when we group by a particular column, it just how to explain it? Instead of me explaining it vocally, I think it's better to draw a table and show you how it works. So let's do that. Let's say I need a whiteboard. Let me just compress this. Okay, now we have space here. Okay. So this is the data frame we have. Let me make it smaller than that. Okay, that's great. And for the columns, this is the header. This is that. And that's it, right? We have 3 columns. And the first one is what? Order ID, right? Oh, that's too big. I'm going to say ID. The first column is ID. The second column is amount. And the third column is country. Right? And we have the values here. Starts from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And for the amount, I can't open that table again. Not sure what we have for the amount. Let's just type in a few random amounts. I'm going to type in 100, 330, that's fine, 400, 200, 100. So we have these, okay? And then for countries, here, and so on. Okay, and for countries, we have US, India, India, US, US. Okay, now when we group by country, this table, everything in this table will be grouped by country. First, because it is grouped by country, instead of having 10 records, because we are grouping by country, this compresses to only 2 records, which includes which just includes India as one field and US as the second field. So this will be compressed because we are grouping, and it depends on how many unique countries we have in that column. That whole table, that whole column will be compressed to those, uh, what to say, those rows. Here we only have 2 different varieties of countries, so this column will be compressed into 2 countries. And if you want to add more columns to the output, sorry. So if you want to add more columns to the output instead of just one column, when you group it, the rest of the columns we want to add, let's say you also want to add ID and also amount. Only if you want to add these 2 columns in the new table that you're creating here. If you want to add those, you have to make sure you either include these column in aggregation, these 2 columns in aggregation, or group by. It should be at least in one of these 2. If it is in group by, this output changes, and it groups by these 2 columns with the country and with the ID. Or if you aggregate, what basically the basic concept of aggregation is combining multiple values into one single output. That is what the basic concept of aggregation. So it should be either aggregator or it should be grouped. Here we used aggregation for both of these 2 columns. So what that actually does is, firstly, the aggregation we used for order ID is count, right? So what that does is it counts all the IDs, all the IDs for that particular country. For the first column, it is India, so it counts all the IDs for that country. If it is like 6 uh, IDs, so if 6 IDs have India as its country, this ID produces this ID will be aggregated to 6 here, and the rest of the 4 to US. That's how we aggregate. So aggregation is nothing but combining multiple values into one single output. And the same with amount, but instead of using count here for the amount, well, we used count for order ID because that makes sense. Because summing up the order IDs doesn't make sense, right? We counting those IDs does make sense to make how many transactions that country does. So we used count for the order ID, but we use sum for the amount. That makes sense, right? We are summing the amount because, let's say, the use case is about how much that country uh, ordered. Let's say how much uh, the people from that country ordered, and we say sum of the total amount for that country. And when we do that, it sum everything in the amount that belongs to that particular country. It can be US or India, and assign it to that respective field. If it is amount in India, it just sums up all the amount, like as in here, it sums up 30, 400, and the rest of these, and gives the final value. Maybe that'll be like 2000, and then here it might be 1600 or something. So that is how it works. when we group by something, any other column that you want to include in that table, the final table, you have to include that column either in group by or in the aggregation. Those are the only two ways that you can possibly have that column in the final table. And here we aggregated the rest of the two columns, ID and amount, with different aggregation factors, one with the count and the other one with the sum. I hope you got the concept here. I tried my best to explain it, but yes, this is an SQL concept. When you most probably will hear about this topic when you work on the tables using SQL, but here in Pandas, we are also using tables here, right? So we use that here as well because Pandas data frame are basically tables. So this topic will also, what to say, uh, belongs to this. Belongs? No, not belongs is not the right word, but yeah, this topic will also work with this Pandas data frames. Now, what will be the output of this? With the explanation that I've done, what would be the possible output for this? So we are grouping by country, right? So the country will only have two fields. One is US and the other one is India. And for the aggregation part, we count the orders for that respective country. And the orders for US, so this is US, we're going to count that 1, 2, and 3, and 4, and 5. So 5, the order IDs, we count the order IDs, and there are 5 order IDs that belongs to US. So the rest of the other 5 will be for India. Now, for the amount we are summing up, so we are counting, we are summing the total amount. So when we sum the amount for US, so let's do that. 100 plus 250, that's 350, and 350 plus 180. Oh, I'm so bad at maths. 350 plus 180, 450, for 500, 530, 530, and then 400, 530 plus 400, 930, and then 1110, right? 1110 will be the answer for US, and for India, 0 plus 300, 300 plus 0, 300 plus 90, 390, 0, 390. So 390 will be the India's aggregated value. Now let's run this program again and see we get the expected output here. There it is. 390 for India, 1140. Did I say 1140 or 1110? Whatever it is. So that is how. Okay, and the count 5 for both of them. And this huge massive table, from this huge massive table, we aggregated and make the data business ready by aggregating it and converting it into this two-columned table. And that is about the aggregation. Now let's go to the next topic, which is a window-like summation. Let me write the line, the program line for that as well. df of running total. Yeah, so the window-like logic, for window-like summations, we're going to use cumulative sum. It is nothing but running total. You'll know about it when we get the output. So we say df amount dot CumSum of print of df. Now what we're doing here is we're actually creating a new column in the existing data frame, which is df, and the new column name is running total, and we're using a window-like logic here, a window summation, which is CumSum. CumSum stands for cumulative summation, so it sums up the amount for every record and assigns it as a running total as for the next in the next column. I think you get it right. So what it basically does is, for this amount, it just, let me do that. Okay, so it just sums up these two first, the first one and the second one, and writes the total right next to the second one as 100 here. And the first one will also be 100. But when it does these two summations, when the 100 will be added to 250, here the running total will be 300. And then these 300 will be then added to the other 300, and the the running sum will be 600, the running total. That's how the cumulative summation works. Okay, we know about that. Now let's see by running it. Copy the same command and run that Python file. You see that, right? 100 plus 0, 100. 100 plus 250 is 350. 350 plus 300 is 650. 650 plus 0, 650. And then 650 plus 180 is 830. So 650 plus 830, 180 is 830, and 830 plus 90 is 920, and 920 plus 400, 1320, 1320 plus 0, 1320 again, 1320 plus 210 is 1530. There are a lot of methods that you can use in Pandas when we wrangle with the data, but these are the few uh, important ones and different varieties of methods that we can use on the data frame that I just uh, presented you. But there are a lot of other different methods you have to learn about pandas. But unfortunately, I cannot explain every single one of them. Nobody can. It comes with the practice. As much as it comes with the practice, you have to work on pandas more to just get the hands-on experience and you know to adapt to it, to adapt to the methods that you basically use. Yes, we do these kind of stuff to understand the data and do these logics, so we can replicate these logics in the big data when we actually work in the real infrastructure using uh, Spark or SQL with other engines like Snowflake and dbt. We can just replicate these methods to the actual big data. We just test it here first. All these are, and we have this window logic as well. And all these are about data transformations. We do on a small chunk of the real data, and then we replicate that on to the actual data on the actual system. So that cuts off the risk of losing or of breaking the pipeline and costing us less and make it more effective. And yes, with that, this hour is completed. And in this hour, we learned about Python pandas, right? So we just learned about pandas methods, and that includes creating a .csv file, reading a .csv file, and a few of the data transformation methods. With that, this hour is officially ended, and now let's head to the next hour's topic. For the next hour topic, we're going to talk about error handling, logging, and debugging. We're basically going to know how to prevent failures and how to control failures and how to recover from the failure without breaking the pipeline. Now let's talk about the exceptions handling. Um, Exceptions are basically the exceptions that are viable to break a pipeline or a code. They're basically of a few types of there are a few types of exceptions. The most arised exceptions, which includes missing files, bad data types, schema changes, partial data changes, external system failures. So all these can be exceptions, or the most triggered exceptions. The good thing is you can handle those exceptions when there is a chance of them to arise before you run the code. So when that exception arises, you can just handle it at the runtime at the runtime itself and prevent it to break the pipeline or the code. There are a few scenarios where you can do that, where you can just handle it and prevent it to break the code, and there are few other situations where you should not supposed to handle the exception and let that break your code and trigger the error. We'll talk about both the situations now. Now we'll talk about the flow of the exception handling first. So I'm gonna duplicate this slide and exception flow. We try something first, and if that doesn't work, if that does work, let's say if that is successful, we continue. What should I do? Let me just so if it is successful, the execution is successful, we continue. But if that raises an exception, if that raises an exception, we handle the error, and then finally, at the end, finally, don't need this. We do the cleanup. Okay, so we execute something, we try to execute something. If that is successful, we just continue with the flow, we don't go to accept. But if that tries an exception, and then only then we will handle the error. I mean, it based on situation. We will handle a few errors. For the other few errors, we let that crash because that is not appropriate to handle that error at the runtime. So if that exception is handleable, is that even a word, handleable? Okay, if that exception can be handled, we handle the error at the runtime when the exception rises, and then finally we clean up. This is how the exception flow goes. Now let's see an example with a demonstration. Let's go ahead and create another .py file. Now, I am wantedly raising an error here. First we're going to try with open of missing file.csv as a read. We define as read as f. But here's the catch. We don't have this file at all in the directory, so the Python cannot find it. So we are willingly raising an exception here. So when it tries it, it raises an exception. Now, if the exception is raised, we can handle it using except file not found error. Then we print finally cleanup complete. We can do that. What this does is when it tries this statement, and of course it raises the exception because it cannot find the file named missing underscore file.csv. When that raises, it goes to the exception uh, handling process, because we are handling the exception here. We predicted the exception except file not found error. That is error that's gonna trigger. So we said except file not found error. If that's the exception, print file not found, pipeline cannot proceed. This is just an example, but in real world, how we handle this sort of errors is we either find for missing file.csv. If that raises an error, instead in the exception we find for a different named file. Maybe the naming convention might be different, right? Maybe the missing file is an uppercase, missing file.csv. That file name is an uppercase. So what we do is we might do this. It is about prediction of the possibilities of outcomes that may happen here. If there are multiple possible outcomes, if like this, if the CSV file name might be lowercase like that, or there is also a chance where the missing file.csv can be in uppercase, we can use this. We first try to find it with the lowercase alphabets, and if that raises an exception in the except, we again try to find the other file and say uppercase missing file.csv. That is how it works. So the main concept here is, if there are multiple possibilities and you don't want the pipeline to be you don't want your code to break the pipeline, you can handle the exception at the runtime. You try that. If that raises an exception, try this, and you will define the exception that might get raised too. And you might think, how can we actually know it raises this exact exception? If that's the question, I'm going to show you how we can know about the exception that can be raised. Okay, now I'm going to save this and run this code in Python. All right, you see that, right? So here it triggered an error, and in that error it also shows the exception right here. What it says, file not found error. So that's the exact error. That is the exact exception you're handling here. So what you do is you just copy that exception and use try and except method to handle the exception, and you do this. In the except, you exactly mention that exception with, and by the way, this is case sensitive. You have to remember, you have to just copy paste that exception with the capital, with the uppercase F and uppercase N, uppercase F, uppercase E. So you have to exactly copy paste that exception, and you're saying Python. So you try that particular statement or program. If that raises this exception, do this, try this. And then after you try that, finally do this. Here we just use print, but in real world we do operations in here like this. You know what? Let's create just an empty .csv file just to make this, just to demonstrate this actually works. In the same source, I'm going to create one more file named missing file.csv. Oh, the .csv should be lowercase. Okay. Now, when I run this, the small code block, when I try to run this, this will still raise the same exception. Right? It still cannot find the file. So it raises file not found error. Now, when I handle that exception, and in that I define open missing file in uppercase .csv and read it. Now if I run this, uh, what is it? Oh, it still cannot find the file because I created the file in src folder, but we're running the program in the root of our project repository, which is python hyphen de. So we have to actually create this .csv not under the src folder, but under the main root repository. So let's create the file here in the root. No, not here. In the root. Okay. New file. Missing file .csv. Okay. Perfect. Now let's run that again. Run our program again. Where it is? Where is it? Now run it. You see that, right? So now it doesn't break and it won't trigger the error. We handle the exception in the runtime itself. So now it did read the file because it can find the file. So it did read the file. So and it didn't trigger any error. That's how we handle the errors, the exceptions at the runtime. And now let's do another demonstration. One more example. Let's create another .py file and say exception. Say this time data type. So I'm going to demonstrate a data type exception. Here, this is the file not found error exception, right? Now we deal with the data type exception. Let's say amount equals 100 and total equals amount plus 50. If I run this, this obviously raises the data type mismatch error because you see that, right? I defined the variable amount with a string. This is not an integer. For us, because we are a human, we can see that's an integer, but it is a string, right? The data type of this, because it is enclosed by double quotes. So this is a string. This is considered as a string by the machine. So when I try to add amount plus with the integer 50, this will raise a data type mismatch error. Now let's try that. Now exception type .py. Type error, of course, because the type mismatch, it says the type error cannot concatenate string with not int to string. And to handle this exception, what we can do is we can use the same method that we used. We say try. So first try this. Right now we are doing everything, but in real world we don't know what kind of data we'll get. Maybe the amount variable here, we might get this data from an external source, and we don't know if the external source send us a perfectly assigned data typed data or a string. a string data for everything. We don't know if the amount, the value of the amount that's sent by the external data source will be a string format like this or will be an actual integer format. So we're not sure. If we are not sure about that in the real world, we cannot risk it to break the pipeline. We handle it even before that. So there is a possibility that that data source can uh, send a string instead of an integer or a float. So to handle it, we use this. We say try and then accept, and the error we got, which is type error, we're going to copy paste it in the semicolon. And how can we actually handle this error? We to make sure the type of that incoming data should be to be integer for amount, we can actually convert that data into an integer just by saying amount equals int of 100, and then do the same operation again after we convert that data type from string to integer. And now if we say amount plus 50, this should not raise an error and break the pipeline, because this will run even if it is an even if the incoming data is in string format or it is in integer format, anything will work. You get it, right? I mean, I'm going to show you an example, okay? So let's say you're getting a data from an external source. Unlike this, there will be a variable that holds an external source data like this: amount equals amount or price, a variable, and this price holds the data that you don't even know what that can be. And this can change. This can be the incoming data can be a string formatted, a string formatted integer or an actual integer. We're not sure. So to make that, uh, to handle that, we can use this method. We can just convert that data type. First, we try to do it in the normal way. If that raises the type error, then we do this. We convert that into an integer, and then we do the arithmetic operation with it. That's how it works. But for now, for this example, I'm going to use 100 enclosed by double quotes, which is a string. Now we can use finally at the end, or we can leave it as it is. That's still fine. That will still work. We can do this as well. Now when I run this same code that I executed, the same code file that I executed previously, if I run that again, that will not raise an exception this time. And I also have to say print total. Now this will actually print the total at the end. So let me copy paste it, run it. There you go, 150. So that is how we handle these exceptions. I just shown you two type of exceptions that we may face when we work with the data. One is this one, where where the data that we get is from an external data source and you're not sure what type of data you will get. You have to expect, but if you predict, that can be a string formatted integer like this. This is an integer, but it is formatted in string like this. You can convert it into integer by the exception, so you can handle it. And here we have the file exception. If you're not sure if the file name will be this, or there is another possibility to have another one, a different file name, you can handle it using this way. So this is how exception handling works. You can prevent an error to break the code, to break the pipeline, if you predict the possible incomes, I mean the possibilities, so you can handle that prior to breaking the pipeline. And there are a few other situations where you cannot use it, like uh, there are a few situations I cannot. I mean, I'm trying to find an example, but I cannot. But there are a few situations where you should not uh, handle the exception, but you have to let it crash, and then you do the transformations. I mean, you fix it manually. Yeah, that is it with the exception handling. Now let's head to the next topic. Now let's talk about logging. Logging is the way we track our programs or the code's progress, and that makes these logs makes debugging a lot easier, because we can see where exactly the program crashed, if it is crashed, and yeah, that's how they works. Now logging basically have two types: a developer level logging, where we use print statements in the in few of the intervals. So we'll know, uh, let's say if I use print here after this block, I will know this block is this whole block, I mean everything on top of this is executed, right? If it prints file not found, pipeline cannot be processed, so this full block is executed. But if this is not printed, we can know there's something wrong between this print statement and this print statement. That is why the second print statement did not get printed. But this is just an example, by the way. Not I don't mean in the context of this program, but yeah, let me show you an example real quick. So I'm going to show you one of my project codes that I used. Let's say this one. So this is a Kafka Python code. Kafka, is it Kafka? Yeah. This is a Python code, all right? Here, if you see that, if you take a look at these code blocks, I wrote these print statements in a few intervals, after a few intervals, to make sure, I mean, to make them work as logs. You know, there is one print statement here, and there is another here, like that. If that is a big code, we have more print statements in the middle. So I mainly use them to make sure everything on top of that, I mean, to make sure where, if this program caused an error, I will make sure where the error is caused. When I say that, what I mean is, so let's assume when I run this program, this thing gets printed. Okay, this thing gets printed, but this print statement will not print. Then we will know, because this is printed, everything on top of this is executed. But because this is not printed, we can say there is something wrong in between this print statement and this print statement. So there is something wrong with this code block. But if both of these gets printed, but still we got an error, we can make sure there's something wrong with this block of code and nothing wrong with the top. So that is how these logs actually work. And we can configure these print logs according to our I mean, however we want, basically. So what I did here is, instead of using a static print string, I used f strings. I'm going to talk about f strings later, but now I used f strings to print this uh, statement. Yeah, print this. Yeah, we'll talk about f strings later, but yes, that is how these prints can be used as logs. And there is another way which is more professional and the production grade way, which people use them in real projects. For developer, when the code is at developer side, prints will do. But when the code is running at the production level, the final code should depend on the logging instead of just printing these statement. So I'm gonna show an example for the actual logging, so we'll know how that works, and we can see the difference between print and the loggings. Before actually demonstrating the logging, we have to know about the log levels first. There are levels of logs which which uh, divides these logs, which partition these logs into layers. And let me create a slide for the log layers, so you'll be clear about that. Let me duplicate the slide and say log levels. A text box. The first one is debug level. So these are the deep log levels, and these log levels, the priority of these log levels. Should I say priority? Uh, yeah, let's say priority. So the priority of these log levels increases while we go down. So it increases this way. Okay, so as we go down to the levels, the priority to show these logs increases. So everyone, the one with uh, the one even with the lowest priority, the lowest log level can see critical errors, critical logs. not errors, critical logs. And then as this goes up, only the, no, I think I messed up. Uh, well, forget about the priority. I'll tell you how this log level works, okay? Now first let me write a Python code to demonstrate it. So let's create a new .py file and name it. Now let's write import. So we import the package for logging. Now we first do the configuration for the logging. Before we step into actual the code, we have to configure the logging. And configuration, in configuration we're going to include level, say logging.info should be uppercase, and the format of the logs. So this is the format. The format goes like for every log. So the format goes like the actual time that the log is raised, and then the log is created, basically not raised. So the time when the log is created, and the level the log is placed at, and the message, the actual log message at the end. So they are separated by hyphens. That is one of the major difference between printing uh, using print for logging and actually using logging for logging. So these logs can actually say when this log is created and also the level of the log. We can control the visibility of the logs with the levels. That is the main reason we have levels in logging. We can control the visibility according to the log level. According to these log levels, we can control the visibility of the logs at the end. I mean, I'm not sure how to actually explain these levels, so I just write the whole code and we demonstrate it so you can understand how these log levels work. Say info, we say logging and dot which level this log belongs to. The log we are going to write now, we're going to say which level this log belongs to. And now whatever the log I'm writing here is belongs to the info level, which is this one. And then I write and say try. I'm gonna do the same. Okay, for now I write a try here, so it tries to do these operations. So it creates a variable amount equals 100, just like we did before, and then total equals int of amount. See that? So we did converted the amount again to integer before we summing up that value with the integer 50. So this actually works, right? And we create another log which belongs to the info level, and the log says total amount calculated is to total. Um, and we used f strings here. F string is basically, like I said, it is used to create dynamic strings more easier than using print. Did I say that right? Uh, yeah. Basically, this whole part is a static string. This won't change, but we can include the dynamic part just by using flower brackets anywhere in the string and write the variable name. Type in the variable name inside the flower brackets. So here, this whole thing is a normal string, but right when this flower bracket starts, this is a dynamic part. So inside, anything inside this will be dynamic. So it searches for this variable's value, which is this, and it prints that value here. So that is how f strings basically work, and there are a lot of other ways to use f strings. I might explain about it if time permits, but I don't think that's a very important topic, but if I can, I will explain it. I will explain more about it. So that is how basic left strings work. So we use that to create this log, and that log belongs to info level. Now we write an exception again. And now, just in case, if this particular task raises any error or exception, we handle that exception using except, and instead of typing the actual exception, we can just say exception as we can just say exception here, which will get executed if no matter what exception it raises. So it doesn't care about the what type of exception it raises. Whatever the exception will be, it's still this particular code block will execute no matter what the exception is. That's why we say exception instead of just saying, just actually defining what exception you're expecting. You can just say exception, and this will get executed no matter what the exception is. And we say exception and we alias it with E, right? And then we create another log. But this time, this log is created at error level and not info level. And the error level is here at the second place from the bottom. So this is where the error level is at. And we created pipeline failed and the exception that raised and that caused the pipeline failure. And let's add one more log, info, pipeline finished. Now save this and run this code. And there you go. So this code actually generates those logs for us. And here's the difference. Instead of writing the print everywhere we want the logs from, at every position where we want to put the logs in, instead of writing the print statements where it basically prints these lines, just the log lines. Instead, what logs offers is these features on top of that basic logs. So it also offers the time when the log is created and at what level the log is at. So now we got access to the time when the log is created, and we also have access to control the log levels. Right now, only info logs are printed, right? So this log is printed, and this log is printed, and finally, this info log is printed. But the error log is not printed because the exception never ran, because this did not raise any exception. But if we change this, if we took the integer conversion out, now if we run this try will raise an exception and this trigger to run this except, and then this except will create a log at error level. Now let's do that. So if I save that and run the file again, now you can actually see there is one info level log created, which is this one. There is one error level log created. Pipeline failed can only concat string, not integer to string. That is the error level log that is created, and we can actually see those logs. Now we know how these logs work, but we don't know how the log levels work, right? So this is how the log level work. We have all these levels, right? We have debug, info, warning, error, critical. Right now we just used info and error. That's it. Now let's see by using all these 5 logs at one place, so we can compare them. Okay. So what I'm going to do is I'm going to just copy this and paste it multiple times. 1, 2, 3, 4, 5. So we need 5 of them. And one for debug, The other one for info, warning, error, critical. Debug, warning, error, critical. Now when I run this, what output are you expecting? So what this prints is, it prints pipeline started 4 times, not 5 times here, just 4 times. From it starts from info level, it prints warning level, error level, and critical level, but it will not print debug level. Now let's run that and see how what happens. You see that, right? So info pipeline started is given, and the warning is also given, created. Error is also shown. Critical is also shown, but the debug is not shown here. Let me zoom this in. So the debug is not shown here. And the reason for that is this is the way the levels work. When you configure the logging, you configure a level, right? Here I configure the level as info. So when I configure the log level as info in a program, it only shows you up to all the levels that are underneath info and the info level. So it shows the info level and all the levels underneath info, which are warning, which includes warning, error, and critical, but doesn't include debug. So that is why debug is not printed. So when you define the error level, when you configure the error level as error, only these two will be printed and the rest of these three on the top will be ignored. Let me show you in practice. So I'm going to switch this into error level. Now let's run this again. Okay, now let's run this again. See that, right? It only prints error level and the critical level logs, not any logs that belongs to the levels that are top of error. These three logs will not be printed. That is how we control these logs. These levels are depend on the severity of the log. I mean, the critical logs are system failures, so that has the more severity, and the task failed has less severity than critical, but it is still uh, it is still important, more important than warning. A warning is just not, warning is less dangerous than error, right? So it is this level, the severity is quite less than an actual error, the warning level. And the info loggings, this is just the information. So the severity is much lower than warning, error, and critical. So it is on top of these three levels. So it depends on these levels depends on the severity of or priority. Should we say severity? Yeah, these levels depend on the severity, and there is debug level where it only shows the developer related details. So instead of saying priority, we say severity and draw a line. So let's use the same error and say severity instead of priority here. So the severity goes from less severity to high severity, and that's how these levels are divided. So the high severity levels are shown to, are shown for almost any level. So if the level is critical, the critical will be shown. If the level is error, the error and critical will be shown. And if the level is warning, an error, warning, error, and critical will be shown, and vice versa. And I'm going to say low and high. Okay, that is how they are. That is how they are divided into layers. Now, I think you got the concept of these uh, logging levels, right? So that is what logging offers us. Instead of using print to actually print the logs, we can use logging to show the logs. These have more features on top of the print, just printing the logs. So these are just more cleaner and time stamped and searchable rather than using prints. Okay, that is it with the logging. Let's move on to the next topic. Okay, our next topic is debugging. This is the actual real deal. This is about how to recognize the error that got triggered. So if you run a program, whatever the error that Python pops, it is not a random thing to just go through all the errors and see the words that are familiar to you and think that is the error. That is not how we debug in the right way. So now we are going to talk how to debug an error in the right way, how to read the error statements and what tells what, so we can fix errors ourselves. So after this, you should be able to fix the errors by yourself instead of depending on others or asking other people for help. Okay, let's start with an example. Let's trigger an error willingly, and then I explain how to debug an error. Let's create a new file, debug.demo.py. By the way, I'm creating all these separate files for the demonstration instead of just using one single file, just to save these files with me and upload it into GitHub repository and then give those files to you. So when you go through this masterclass, and if you have any doubts, you can just go through these files. So I'm just saving every instance of demonstration into a single .py file, and I'm not deleting any of those. I'm going to give the link to you guys so you can use those files. Okay, we are here. I'm gonna close these two as well. So I'm going to define a function. Okay, now I written a simple Python code, okay? So now I define a simple function as well, which returns whatever the dictionary that you give this function, it returns the amount, the value of amount times 2. And we also defined the order dictionary here with amount and the value as 100. And then we pass that dictionary as a parameter into the function, so it executes. Now this will execute just fine with no errors at all, right? Let me also include print here. Okay, now this will execute with no errors, but I'm going to spell it wrong wantedly, so it will raise an error and we see how to fix it. Okay, now let's go to the CLI and run that file, run that Python file, Python. It will raise an error. Now let's see how to debug it. Now what I do is I straight away read the last line. I straight away go to the last line of the error. Basically, the error structured in this way. The last line will be the error type, and everything that is on top of that last line will be the call path. So I have to remember this. Let me write that down. Okay. So the last line will be the error type. And the lines above will be the call path. So this, you have to remember this when you read an error. The last line. So what I basically do is I just go to the last line and see the error type first, which is this one. And the error type here is key error, and it actually says what key actually raised the error, and the key is amount. But it shows the right spelling, AMOUNT. Now we know there is some sort of key error, right? We know there is an error while we refer to the dictionary, the key from a dictionary. Now we need to find where that key error occurred. To see that, we can just go to the top lines and read those lines. It says, right here it says file, and it says the file path debug underscore demo.py, right? And then it says at line 5, which is this one, in module print calculate underscore total of order. So it says this line because this is the function call and that failed. But the reason that it failed is because of this. So it says file and the file path, of course, again. So it says, and now it says line 2, which is line 2, this one. Calculate total, return order of amount times 2. So it thinks, I mean, we are human, so we can read which one's wrong. For us, we spelled this one wrong. But for debugging an error, we have to think as a compiler. What compiler does? It reads this dictionary and thinks this spelling is correct, right? So it thinks it is correct, and then it just sends this dictionary into this function, and then it runs this. So it tried to return order of, instead of searching AMONT, it searched for AMOUNT. So it thinks there is something wrong with this line, something wrong with that key, and not the one that we initialized. So and then it says, so there is this key that is not that doesn't match with any of the key that from the dictionary that you gave me, that you sent me, so I cannot run this operation. So that is how compiler thinks. So we have to think like a compiler instead of a regular human, not like a regular human. We have to think as a compiler. So but when we see, it is saying this part is where it made the the program to fail. We can actually confirm it, because we can actually confirm the key is what spelled wrong, because we can see here the spelling doesn't match with each other, right? And we can just fix it. Now when we run it, that will execute. That's how we debug. If that is not clear, let me use another example. Instead of using a dictionary here, I'm going to use order equals the same error that we raised before, and say order times 2. Now it raises the type error, right? So let's run that again. No, this won't raise. It will raise the type error if we add it. There you go. Now what we have to do, we can find the type of the error at the end, at the last line, which is this one, and the type of the error says type error can only concat string or a not int to a string. So it should be, they both should be strings or they both should be integers. I mean, they cannot be of different data types. So one cannot be a string and the other one cannot be integer. So it should be same data type. That is what it says. Now the call path says file, and the file path here, and it says line 5, which is this one, because this function fails. This function failed. We know that already. And then it says the file path again, line 2, which is this one. It says calculate a total return. It clearly points to the error, and it says this is where the error occurred, and by the type of the error and the position where the error occurred, we can actually determine what went wrong. Because it is a type error, it is because the 100 is in string format and not integer format, and we fix it. That's it. That is how we we debug it. Okay. Now we're going to talk about defensive fix instead of this. To talk about defensive fix, I'm going to add 2 more lines in the function saying if amount not in order, raise like that. So I spelled it wrong again, and run the same file. Oh, I'm not executing it. I forgot to type Python in front of that, the path, the file path. Okay, now do that again. There you go. So now what happened here is, instead of waiting for Python to raise the error, we can raise the error before it reaches to the end. So that saves the computational power and the time. I mean, in this small code, it doesn't uh, make sense. But when you write a long code, when you write a lengthy code, and you know there is a chance that this error might occur, you can uh, just type in this prompt, this statement. So the code fails early, and you don't have to wait to execute multiple statements before this code actually fails. What I mean is, let's say this return order of amount is the last statement to be executed in the function, and there are multiple lines. There are like something a equals b plus c, or there are a few more lines of codes in between, and you don't want to wait this longer to actually see if the error raises. And if you want, just to not waste your time, you can just check if that error actually raises right here on the top itself by raising it yourself, by checking it yourself, so you don't waste your time. That is how uh, defensive fix works. You don't wait for the error, you raise the error prior to that statement, so you don't waste your time and you can fix it. Okay, with that, I think we're done with this hour as well. And to wrap it up, in this hour, we gone through the error handling methods and the logging methods and the logging levels, and we also talked about exception handling. That is it with this hour. Let's head to the next hour's topic. Now, for this hour, our topic will be databases and APIs. We'll see how Python talks to the outside world, like databases, and APIs. Databases, that includes the Postgre, Snowflake, whatever it is. But for now, we're going to take an example of Snowflake, and we connect to the database in Snowflake and then work on it. So we see how to do that, and also how to connect to an API and retrieve the data from it. Firstly, we'll talk about the database drivers, the database, Python connecting to a database. In this case, we're going to connect to Snowflake, a database in Snowflake, and then we work on it. In order to actually connect to Snowflake, Python cannot directly talk to Snowflake. It uses a database driver to talk to the database. And because we are going to talk to Snowflake, the driver that we use from Python to talk to Snowflake is Snowflake connector Python. We have to install that before we actually can use it in our code. So let's install that. So to install it, we go back to the CLI. Here we run it as pip install Snowflake connector hyphen Python. I spelled the install wrong. All right. Pip install Snowflake connector Python. So this installs the database driver that that is required to talk to the database. Now, at the beginning of the masterclass, when we set up the environment, I talked about creating the requirements.txt, and I talked about the importance of this, creating this, right? So we have to we have to create this requirement.txt so we can replicate this environment in any other environment. So we have to list all these tools that are installed with those appropriate versions. And now, because we installed a new tool, we have to change this a little bit to include this Snowflake driver as well. So let's do that. To do that, let's run that command again. I think the command is freeze greater than. Is that correct? Let's see. Requirements.txt. Freeze requirement.txt. Run it. No, that the command is wrong. The term freeze is not recognized. Okay, let me see what the command is. All right, the command is pip and then freeze requirements dot txt. Now this will replace the requirements.txt file with the updated one. There you go. And here it has numpy, and we have to make sure the Snowflake is here. Snowflake connector Python. So whenever we want to replicate this environment into a different environment, we just have to install all this requirement using the command like this, pip install -r. So that is anything that we use in the command line that starts with minus is a flag. And according to the alphabet that we use after the minus or else the hyphen, that defines what flag we are using. Here, -r represents read. So we use that to read this text file. So we use -r, the flag, to read this text file and then install everything that is in that file using pip. So we install them into that environment. So whatever the codes, the programs that we run in this environment can be run in that environment too after we install all the requirements.txt. That's how we replicate one environment into another environment. I think now you got the concept clearly. Okay, we're done with that. And we have so the main purpose of drivers, like I said, the driver that we just installed, the Snowflake connector Python, the main purpose of this driver is to talk to translate, to give instructions to into SQL into SQL, yeah, to give to helps Python to give instructions to SQL to run in Snowflake. So that is how the driver works. It's like a translator. And now, using the driver, we can control when things happen using Python, and Snowflake decides what happens to the data. And we say what to do to Snowflake through Python driver. Now, let me draw out the flow of this in a new slide. I'm going to duplicate this. Name it Python to Snowflake flow, and we don't need these bottom ones. So this is how the flow goes. First, we write the Python code, and whatever we say, the commands that we pass will be uh, converted, translated using the Snowflake driver, and those commands will be given to the Snowflake, and Snowflake executes what happens. So we are saying we use Python to say when to happen, and Snowflake decides what to happen. So, and we use driver to translate what to say to Snowflake, and then Snowflake execute what to happen on the data that is in the tables. This is how the flow goes. We're done with the flow, and let's head back to the demonstration. Let's create another file again. Name it snowflake demo.py. Now what we do is, well, to edit the table, it can only be done by Snowflake. It cannot, I mean, it can only be done by SQL. Python cannot edit the table. But what we can do using Python is, we can pass this SQL queries from Python through Python, from Python through the driver to Snowflake, so that the Snowflake can execute these SQL queries that we send through the drivers. And these queries can be executed on the table. To make it much more clear, I'm going to demonstrate how this process actually goes so you can actually see what happens. Now I'm importing this package from the tool the driver that I installed. I'm going to import snowflake.connector. So this package allows us to connect to Snowflake. To connect to Snowflake and start a cursor. I'm going to explain what a cursor is, but yeah. Now we imported the package. Now the next step is to configure the connection. I'm going to write the comments just to make it clear for you when you go through the code. We talked about these things, right? These are the comments. These are not part of the code. These are just for the readability. So these comments says what this code block is executing. First, I'm going to write the syntax of that configuration, and then I fill the details with my details. So this is the basic configuration syntax we need to connect to Snowflake through Python. You don't have to remember this. So, I mean, because it depends on what database you're connecting to, and these configurations differ a lot, and there are a lot of configurations. So these configuration will not be remembered by us. It depends on what database we're connecting to. We can just Google it, or we can use AI to get the configuration that we need to connect to the database, and you can find them. This is the syntax that you will get. Now, we're connecting to Snowflake. Before connecting to Snowflake, if you're doing this task parallel to me, I have to also talk about Snowflake, right? Because if you are doing parallel to me, you cannot understand what I'm doing here if you don't know what is Snowflake. So a Snowflake is a cloud data warehouse we're connecting to. The main purpose of Snowflake is it can act as a database. It cannot act as a data warehouse as well. It just stores the data. Now, before we connect to Snowflake, we have to create a Snowflake account. Let me open that. So you have to search for Snowflake free trial. Click on Snowflake trial. If you're logging in for the first time, you can create a free trial account in Snowflake. And the free trial lasts for 30 days, like it says here. And you will get $400 worth of free credits. And you can use these credits within this 30-day free trial period in Snowflake. And you don't need to, by the way, you don't need to put in any of your payment details like it says here, no credit card required. You don't have to put in any of your payment details to start up, to sign up. You just need to fill the basic details like first name, last name, work email, or any of your personal email will also do. Your personal email will also do, and say mention the reason you're signing up for. Is it a company considering Snowflake? I mostly use training and certification for my job or personal learning. That will do as well. And click on continue. And after you click on continue, it asks you for a few more basic information like choosing a cloud provider. You can choose any cloud provider because we are just connecting to it through Python. So anything will work for now. And that's it. It'll send you a sign up link and you have to create a password and you can log in directly. This is how Snowflake works. I already created an account, so I'm going to just log in into it. Even to log in into Snowflake account, just go to here, click on sign in, choose my account, put in my credentials, and then click on sign in. This is the home page you will land on when you open Snowflake. So if you want to know more about Snowflake, I already did a Snowflake masterclass. You can go check it out. That is like 3.5 hour masterclass. You'll know everything that you have to know about Snowflake as a data engineer in that masterclass. And this is the UI you will land on. You can see the credits right here. Right now I have 28 days left in my trial before my trial ends. And yes, let's head back to the code. Well, connecting to Snowflake, we have to know what Snowflake is. You have to be familiar. But I cannot explain everything about Snowflake, everything about databases in this class. It's going to be so long, but I'm going to give you a brief introduction. I already gave you a brief introduction, but I'm going to give you more information while we work on it. Everything that you need, so you can, even if you don't know about it much clear, I'm going to just tell you a few points you have to remember about Snowflake when you connect to it. So here, the details we need is the username, yes, and the password of your account and the account ID. And I'm going to show you how to get all these information. And you also need a warehouse name. So username will be your username and password will be your password. And there is for every account you create, there will be a unique account ID that will be created. There is account ID and there is username, and they both are separate because one account name can be used by multiple users, right? And these multiple users have different usernames. And that is why there is username separately and account separately. They both are not same. This is the common confusion when you work with Snowflake. So you have to remember that. So you put in the account ID and there is warehouse where we run these database and basically where this database belongs to. So we create a database inside, and inside the database we create a schema. Schema is like a folder. Schema is like a folder in our mobile phone. It just segregates the tables inside the database, so we don't get confused between them. So that is schema. In order to connect to Snowflake, we first have to create all of these information. Right now, I've shown you how to create an account. So you will have the username and password and the account ID with you. And by default, you will also be granted with a default warehouse as well, so you don't have to worry about it. But I'm going to show you how to create a database and a schema in Snowflake. So let's head back to Snowflake. and click on Create SQL file. Right now, if you want to see what warehouse you're connected to, click on here on the top, on the left, bottom left, click on Compute, click on Warehouses. So these are the warehouses that you're granted with. Basically, any Snowflake account primarily will be connected to this warehouse unless you create your own. You will create to this warehouse. You'll connect to this warehouse. So whatever you connect will be created in that warehouse. And here, this is the catalog. I'm going to delete this database. So here, this is the catalog. You can find all your database that you created. Here, I created this demo database because I do this. I create these databases before I explain it to you. So I already created that. Now I'm going to drop the database and create it again. I dropped it now. Now I head back to the worksheet, the SQL worksheet that we created. Here you can see it is by default connected to this warehouse, compute WH, like I said. Now for now we don't have any database. To create a database, we run this query. Demo DB. So we are going to create a database named DemoDB with this query line, with this command line. Now we should not supposed to call it a command line, we have to call it a query. With this query, we're going to create a database. So when we run it using this button here, we just have to select the query that we are going to run like that and run it. And the output will be displayed at the bottom. It says database DemoDB successfully created. Like I said, I'm going to show you the basics, but if you want to learn more about this Snowflake and working with it, you can just go refer to that masterclass that I created. Now we have the database created. We can make sure that is created by going to catalog and see here, refresh it. Now you can see the database created. But for now, and yes, like I said, inside the database, there are schemas. By default, you can see two schemas. One is for the information schema, and there is one empty schema that will be created by default by Snowflake that you can use, or you can create your own schema. For now, we don't actually, this is not a Snowflake masterclass, so we're not going to create the schema here. Just for the demo, I'm going to use the public schema. That's totally fine. So that's totally fine. We're going to use the public schema here. So now we have the database and the schema as well. They are ready. Head back to the code. Now we also have these two ready, the database name and the schema. Now we fill this thing out, the configuration out. Firstly, my username. And my password, I'm going to type in my password because I'm going to change it anyway after. I think it is, forgot my password. You know what? Let me change my credentials and use them instead because I forgot my password. And now I did change my password. It's like goes like that. And then for the account ID, I have to go to Snowflake you can find your account ID when you click on your ID on the bottom left and click on session details. Here you cannot directly copy this thing for some reason, so you have to copy to clipboard. Click on this button and then go to a new browser, paste it, and from here the part you have to copy is this thing up to here. So I have to copy everything after those double backslash and before the dot snowflakecomputing.com. So you have to copy everything between that and head back to the program and paste it here. So that is the account ID. And for the warehouse name, we already talked about warehouse, where to find it. So click on the compute on the left pane and choose the warehouse that you're using and copy paste the warehouse name. And the database name, we created the database name and we named it DemoDB, demo database. And for schema, we are going to use the public schema. And that's it. You just need to fill in the configurations uh, respective to the tool. For Snowflake, this is the configuration, and for Postgres, it is different. So whatever you use, the configuration will be different. You have to search on the internet accordingly, and you find it, and you just paste the syntax and fill the details of your own database. Okay, that is the configuration is done. Now what I did here is using the configuration, the connection settings, I opened the cursor in Snowflake. A cursor is nothing but uh, a way, so we can, cursor is a way we can interact with Snowflake and run queries in Snowflake. Yeah, the cursor basically allows us to write SQL queries in Snowflake. It is like an execution engine, so it just gives us access to that. So we define the cursor here and we assign it to this variable cursor. Then now, after defining the cursor, whatever we want to execute in Snowflake, we can open cursor.execute and define whatever we want to execute in Snowflake, because now by this line we open the cursor and the cursor is active now. So whatever we execute will be executed through the cursor in Snowflake. Here you have to use 3 quotes, double quotes. Then we write whatever the query we want to execute. First, we created the database, right? And we also got the public schema that is already created. But in order to work on Snowflake, we need a table, and the table has to have some data, right? So what we are going to do is we create the data, we create the table first, and we insert the data into table, and then I will show you how we can select the data too from Snowflake. So I'm going to demonstrate all of those. Firstly, to create a table, I'm going to execute the query create. and close the query with the three quotes again. So the query beginning should begin with three quotes and end with three quotes. These how we say the cursor. This the beginning of the query and this the end. And the query that we wrote here, this is not an SQL masterclass like I said. So I'm going to just say what we did here. We are creating a table basically. We're creating a table named orders with three columns in it. Order ID, and the column type is integer, so it only takes integer values. There is amount, which is also integer, so it will also take integers values only. And then there is country, which only takes string values. Now this part is not necessary, but if you include it, that's fine. It works even if that doesn't have if you don't write it as well. Just to make sure, only create the table if that doesn't exist, but if that table does exist, do not create a new table. That's what it says. We have that. Now we open the cursor, but by the end of the code, by the end of the Python program, we have to close the cursor too, because cursor is not free. Cursor costs you money. It costs you money about how long the cursor is open. So right after you're done with the task, you should make sure to close the cursor, or else Snowflake will charge you more, a lot. So you have to make sure to close the cursor. And to close the cursor, we have to run that. So we close the cursor first using this line, cursor.closeOff. And we also close the connection, the total connection to the Snowflake as well, using connection.close. So this is the best practice I mean, not the best practice, this should be followed, or else you will get charged more for what you haven't used, because Snowflake has to create a cursor for you. If it is open, even if you're not using it, you are in trouble. You're going to pay for that. We have that. Now let's type in a few comments to say what actually is going on. Like I said, this is not required, but that is a best practice to have. Have that. Now let me save the code and run it. That's going to take a few seconds because it needs to open a cursor and create the table, execute that SQL query inside Snowflake. So yeah, I think it is executed and it did not trigger any error. So I'm assuming we can actually see the changes in Snowflake in our database. So let's go check it out. Switch to catalog, refresh, click on the drop down, extend the drop down again in public. You see that, right? We haven't created any tables here manually in Snowflake, but this table is created through Python as a user interface, and we used a driver to communicate to Snowflake and created this. These operations are these kind of operations are mostly useful when we create a DAG file in Airflow, Apache Airflow, and we automate it. So yes, I used this connector, the driver, where we connect Snowflake to Python a lot in my projects. You can check them out. Yes, and it also have all the columns that we created. Order ID, which is integer. Right here it says number, and amount is integer, amount, number. Country is string, country, varchar. So string is basically a varchar, spelled as a varchar in SQL. So these columns are all created. Now we have a table, but just an empty table, nothing else in it. So it says 0 rows. When we click on data preview, it says 0 rows. So basically, we have an empty table with us. Now let's see how we can insert data into it. To insert data, we just modify this program a little bit to insert data. So, and I insert a record into the table that we created, the empty table. Say let's use the try and exception handling here as well, because that is a best practice to do. And we do the 3 quotes. Here we type in the query that we want to run. Insert into is the command that we use, the method that we use to insert the data into the table. Orders of amount, say country, now define the values that you're going to insert. First we have to use the placeholders. And now the values. This is the syntax to insert data using a Python to Snowflake connected driver. Okay, and now after that we do the logs, right? We have to make sure it is inserted, the data is inserted. Unlike we did for this one, we haven't got anything out as an output here. So we don't know if it is inserted, but we have to assume that is successful. Instead of that, if we do this, we design an print statement saying insert successful. If the insert is actually successful, this will be printed and we can confirm the insert is successful instead of just assuming it. And if any exception raises, we print another statement saying insert failed, and the exception that is raised. Now let's run this. Now what would happen? So we are inserting into the table orders, and we have to into these columns: order ID, amount, country, and we say values of this syntax of SQL to insert data, and then we replace them with the placeholders first in the query, and then we pass these data to those placeholders outside this query. That is how we execute. That is how we pass the data. We pass the data to the placeholders. Then we, if everything goes fine, it prints insert successful. If there is an exception that is raised, it prints insert failed, and it shows the exception here next to it. And at the end, the opened cursor will be closed, connection close. Now let's run that again. Let's run the same Python file, the modified one again. Okay, we did got an error, and what is it? So we go to the end and say Snowflake connector errors, programming error, SQL compilation error, object orders already exist. Oh, got it. You know, when you remember when we used create table if create table if not exist, and then we say orders. That makes sure only to create a new table with the name orders if there is not another table that is named with the same thing. But if I write this, just this, it still tries to create a table named orders, but the problem is the table with the name orders is already created in Snowflake. So this query will raise an error because there is already a table named orders. That is why we have to use if not exists. So it makes sure only to create that table with that name orders only if that is not exist already. Now let's run that again. Insert successful. See that we got our log that we printed saying insert successful. So if we go back to Snowflake, refresh this catalog, then you should be able to see the number of rows changes. And when you switch to data preview, you will see the data that you inserted. We inserted order ID as 1, amount 100, and country US. 100 and US. That's how we insert the data into Snowflake. Now let's see how to select the data from a table. Okay. We are going to use one more execute here with the same cursor. Okay. Cursor.execute and say select order ID amount country from orders, and then we close the execute. So we are selecting order ID, amount, and country, all of them from orders table that we just created. And if we run this again, this thing is going to insert another record with the same data. So might as well just change the data this time so it inserts something different. So I'm going to change those data to a different record and now run it. Copy paste it, enter. Insert successful. Oh, we haven't used print to actually print the log here. So yeah, we have to assume the data. No, sorry. Now we select the data, but we cannot see it. So I forgot to write a few more lines to actually see the data, the selected data from the table. So to see the selected data, we create another variable. Now what we do is we create another new variable, rows, and we assign cursor.fetch all. So it fetches everything that we selected in that particular cursor, and the fetched data from that cursor will be assigned to rows. Right now, rows have multiple records of data. So we select one record at a time using for loop for row in rows, print row. So it prints one record at a time. Now we are going to, because now we are going to run it again, let me change the insert data again. 100, and we'll find. Now let's run that again. This time we have to actually see the data. There you go. First insert successful, and it prints one record at a time, looping through the rows. Then it prints all the 3 rows. The first one, second one, and third one. That is how we select the data from a table in Snowflake. Yeah, that's how, I think with this, the demonstration of connecting Python to a database using a driver is done. Now heading to the next topic. I mean, before heading to the next topic, I have to. I'm not sure if I mentioned this one. The whole purpose of me demonstrating all this, executing queries in Python, the reason is you might think, why are we executing queries through from Python in Snowflake? Why can't we just run these queries directly in Snowflake? That is because when we work with the tools like Airflow, let's say Apache Airflow, and we schedule the task, and that task is to create a table or insert a table. I mean, any task that is related to Snowflake database, it can be create, insert, or delete. To automate it in Airflow, it should be executed in Python code, right? So for that reason, we instead of using queries, we write the queries in Python and we send it to the through the cursor to Snowflake so it can run, and we automate these type of tasks in Airflow so they can run in a scheduled times. Well, I took Airflow as an example. Just I mean, there are a lot of other tools where we have to where we can do these type of uh, process using Python. So this is one of the important topic you have to know. Okay, now let's head to the next topic. Okay, besides the database, now we are going to talk about APIs and requests. Well, getting data from a database is one mode of data source, but there is one more mode of data source we have to talk about, is that is getting data from an API. Yeah, API. API stands for Application Programming Interface. So that is one of the way we can get the data from. API acts as our data source. The difference between getting data from a database and getting data from an API is the data that we get from a database is structured and it is well structured and good looking. So it is easier for us to work on it. But when it comes to API, when we get the data from API, like we already talked before when I was explaining data structures, the data that we get from APIs are so clumsy. It is kind of hard to explain, hard to understand the data that we get. It is structured in an odd way. So we are going to talk about how we can get the data from a API, how we can use it as a data source, and request is how we request data from an API. So there is API and there is request. Request is the mode of connecting to the API. To be clear, we use request to request the API to get the data, or to there are ways. There are the REST basics. So we can get the data, we can post the data, which means we can send the data. So there are a few REST basics we have to know. So yeah, let me list it using a PPT. And copy that. I'm gonna list it this way. I just want to copy this so I don't have to create that again. Okay. So first we have get. We use this REST command to get the data. I mean to fetch the data from an API. And then we have post, which we use to send the data to API. And then we have put or patch. We use that to update. Then we have, at last, we have delete. Like the name says, it is used to remove. So these are the REST basics you have to be familiar with when you're dealing with APIs. We mostly use get to fetch the data from API. We don't usually use these other REST API basics, but it is always good to have, good to know what they are. Okay, now let's head back to the code editor and create a new code. So, and there is one thing you have to remember when you are dealing with APIs. Getting data or accessing data from an API or is not unlimited. So it comes with a few limitations you have to know, and those limitations based on which API you're using. I think I used an API called FinHub to get the stock data once in my project, and whatever API you use, you go to that site and see the limitations for the free account, the free customer, and there is they increase the limits according to the subscription you take. So if you're free, there are a lot of limitations when you get the data or you access the data basically. So it depends on the API, so you have to be careful with that. Using APIs, using APIs, you might face a lot of problems getting the data from it. So whenever you face anything like that, if you think your API failed to get the data, that means your subscription might not be working or API is slow. It can be any of those reasons. So yes, those are the things you have to remember. But API I'm going to use now is not an actual API. It is a practice API that has unlimited uh, accessibility, so I can pull the data unlimited times. I'm using that because I have to juggle around all those data, and I don't want to have limitations with that just because this is a demonstration. So I'm using that API. If you're using any other API, you have to search on their website. You have to look up on their website for the limitations. Okay, now to access API, we use requests. So we import requests. And then we define the API URL. I already have it pasted in my notepad. I'm going to use that. Paste it here. Like I said, this is just a mock URL. So if I open this in any browser, this is what I get. So it is a list of dictionaries with random data. I don't even know what this data is about. I just know this API has no limits accessing the data, so I am using it for the demonstration. So this is the data that we are going to work with. Okay, so that is the URL. Now, we use the REST method, the get. So I'm getting the data from the API, and the API URL is this. So I use request.get of the URL, which pulls the data out, which fetches the data. Then data equals response.json of. Now I'm creating another variable which is named data. What that stores is it converts this response from the API to a JSON file and assigns it to data, a JSON format. And I'm going to print the last two records from that API result to see if that actually pulled the data out. Now let's save this and run it. Or this one, this one. There you go. So it prints out two dictionaries at the end. Two dictionaries at the end of those records, which so this part is one record and this other part is the other record. So it pulled two rows, two records from the list of dictionaries. So we have that. So that now that makes now that confirms we did connect it to the API and we did fetch the data from the API. And if you take a look at that, we already talked about it, right? The data that comes from API is maximum. I mean, maximum APIs out there. The data that is returned from those APIs will be in dictionaries mostly. And here we also here with this API we got dictionaries. So the data is structured in dictionaries, list of dictionaries to be clear. So that is how the data is structured, and it is so clumsy right now. Now what we do is we parse that data. We parse this clumsy data into a good looking one. I'm doing the same thing that I did when I explained the data structures. I'm just parsing. I'm creating an empty list first, and then pulling out one dictionary at a time and parsing one column at a time. So first, I'm going to choose the column post ID. It is lowercase d. Now I parse the data. After parsing, I'm going to print those two records at the bottom again and see what it prints, the format it prints. Oops. There it is. Now, this whole part is the raw data that we got, and after parsing, this is how it looks like. See that? This part. This is one record, and this is the second record. You see that? It looks good now. So, yeah, that is how we parse the data that we get from JSON. That is how we pull the data out. That is how we fetch the data out, and then we parse it. If you want to know more about uh, pulling data out from an API and parsing it and working on that data, I recommend you to watch the project that I've done um, that says stock market data analysis. I think it's end-to-end data engineering stocks analysis. So check out that project. So that in that project, I used an API to get the data out and parsed it and worked on the data live. By the way, that is a live API. That API changes over time, and I used FinHub for that. It gives me the live stock data. Now save this. And we also have to know about pagination. And what pagination is a topic which you have to know when you work with APIs. Pagination stops you requesting all the data at once. Like here, we did request it to fetch the data from the API, but this here it worked fine because the API itself has just 100 records. But imagine requesting the data from an API which has 10 million records. That will instantly crash the PC because of the load that gets while loading all the data at once. So that is where pagination comes into picture, and it also separates us segments. I mean, it also partitions the fetching. So instead of fetching everything at once, it fetches chunks of data. That is how it works. Now let's have a demonstration of pagination too. Let me create another Python file. Of course, we have to import requests to access the data from an API. We define a variable page. We define a variable named page with an integer 1 initially. And then we also define an empty list where we can store that data. Initially it is empty, so we name it all data. For now, we used a while loop. We say while true when we use while true to create an infinite loop. So this loops infinite times until we use the break statement somewhere inside the loop, or else it just runs over and over again. And the first line is response equals this request dot get. We already know what we are doing here. We're fetching the data, and the URL, which is this one. Now here we define the parameters, a few parameters saying to make the request to fetch chunks of data instead of fetching everything at once. Initially, for the parameters, we assigned page equals page. Initial value is 1, but we will increment it after every page read. So for the first loop, the page will be 1. For the second loop, the page will be 2. And the limit will be 5 records per page. So it just fetches 5 records for every loop. And it don't, so in that way, it don't, overloads the system, the virtual machine. And we make sure if there is nothing written from the API, response.json will be empty. So right. So in this condition, we used if not response.json, which checks if response.json is empty. So if it is empty, it executes this. It breaks the loop. It breaks the while loop and exits the loop. Then we used all data.extend. We extended that empty list. I mean, initially it is an empty. So we extend that list to the response that we get from the API. And then we increment the value of the page using the incremental operator. So every time it loops, the page will be incremented with 1. That's how we use that. And then at the end, we print the length of all data to make sure everything got, the fetched. So this is how we use pagination. So this reduces the load that gets onto the machine when we fetch everything at once. Instead, we fetch limited records at once. We can customize it according to our needs. Here I used 5. So it fetches 5 records for every page. So for every iteration basically. Now let's save that and run it. Invalid syntax. Perhaps you forgot a comma. Yes, I did. Here, this is sort of debugging. So it says syntax error, invalid syntax. Perhaps you forgot a comma. It also says what I forgot. So yeah, here. I forgot a comma before I defined the parameters and the URL, the actual API URL. That is the error. That caused the error. Now let's run that again. Nope. There you go. So it did fetch every record, and that API, like I said, that API only have 100 records. So yes, it doesn't matter. We don't have to use pagination if the API only have a few records, but most of the API have millions of records. So it is always best practice to use pagination to decrease the load, to reduce the load on that gets onto your PC. So this is one of the main topic we have to discuss, and then we have now there is one more thing about APIs we have to discuss, that is retry logic. When I said APIs have some limitations and it depends. Most of the APIs only allow a limitation like this. It allows one record per every second or one record per every 5 seconds, something like that. So we don't know the limitation. And according to the limitation, our request can be customized by ourselves using retry logics. So if it requests the API and the API doesn't respond, it retries again, but before retrying, it waits. We can make it wait like customized seconds, customized time before it actually retries. We can also customize that. And that is also a way we have to use when we uh, deal with APIs. Now let me demonstrate that as well. API.py. Here I'm going to import time to define the retry delay time. Then retries equals 3. I'm just declared a variable with 3 assigned to it, the integer. And now I'm going to open a loop for a for loop. The response equals request dot get of, and the link and then response dot raise per status print of request successful. So we are using this to fetch the data from the API again. We use .get to fetch the data. Then we use request.raise of status, response.raise of status. This returns the status of the request, of the response. So there are a few things you have to remember. If the response, the raise, when you say raise of status, response.raise of status, if the status is returned as a as an integer anywhere between 200 to 299, that means it is successfully executed. And if that returns anywhere between 400 to 599, that means there is an error that is raised, that is not successfully executed. And this works with every API. With these digits works with every API. So yeah. So 200 to 299 is successful, and 400 to 599, any integer between this range, is a fail. That is what you have to remember. Now we are getting the raise for status, and then print request successful. Break, and then say accept. See if in case there is any error, if let me tell you, print of, I'm going to use f strings, attempt plus 1, failed, time dot sleep of 2. Now let's run this. You see that, right? Now I'm going to explain what I did in this code. I wantedly did not import requests at all. Did you find that? Did you realize that? In every other APIs, in every other codes that I used to access the API, I did imported this package requests. But here, I wantedly ignored it to raise the error. Now, I haven't imported the package request here, and that is why I cannot use this. Because Python don't know what it is. Python don't know what request is. And that's why the error, the response from this raise first status will be anywhere between 400 to 599. And when that occurs, this particular code raises an exception. This particular line raises an exception saying any number between 400 to 599. And that's why it goes to the exception here, and then it tries again. It prints f attempt. Did I spelled it wrong? Attempt failed, and retry. And here in the next line, it sleeps for 2 seconds before retrying. So it sleeps for 2 seconds. This is the line that makes the code or the loop sleep for 2 seconds. So it sleeps for 2 seconds. Before looping again, we do time.sleep of 2. So it says 2 seconds. After 2 seconds, this loop will again try to iterate and then get the response from the URL again, and still it cannot get it because we haven't imported the package. So that is why all the 3 attempts all the three attempts that the loop made or failed. That's how we can raise the exceptions using raise for status. That's how we can retry. If there is any internet issue or the API is not working or the limitation is like 5 seconds, you say retry for every 5 seconds. Here, you say sleep equals 5, sleep of 5, and this loop will be this loop will retry to get or to fetch data from the API for every 5 seconds. That's how you deal with these exceptions in APIs. Now, if I import, to fix this error, if I import requests, and now this will be able to access the API. Oh, sorry, my bad. So this should be requests, not request. Okay, and now if I run the same code again, see that, right? Request successful, which is this one. That's how we do it. And that's it. That is how the retry logic uh, applies on APIs. With that, we are done with this hour as well. To wrap it up, we talked about what? We talked about how to connect to databases through API drivers to no to Python through Python drivers and execute operations in it. And we also talked about how to connect to an API, get fetch the data or from an API and then parse it. We also talked about the request basics. Get have get. What else do we have? So we have get, post, put, patch, delete. All of this, and we also talked about pagination. We talked about retries in APIs. Now let's head to the next hour's topic. Now our topic for the next hour is OOP, Object-Oriented Python. OOP is a tool that we can use to reduce the complexity of our program that we write. And there is situations where you can use OOPs, but there are a few other situations where you should not use them. It just, like I said, OOP is used to reduce the complexity and not create the complexity. So that is uh, the important thing you have to remember. We use OOP, we use a class as a group of functions. I mean, imagine if our program has a lot of functions and all those functions share a same state or yes, share a same state or share same memory, you can just group them together and call it a class. That is a good way to use a class, but there are a few situations where people create 15 classes for just 3 functions. That is like not, that is so not efficient. So we have to be careful where we use classes. We only need OOP when we need structure, state, and lifecycle control of that program. And if our program, our pipeline, our program is stateless and linear, functions will do. When I'm going to explain, I'm going to demonstrate what state is and what how this classes are created, how these functions are grouped together. I will demonstrate them, but these are the concepts you have to know. And there is a situations where we have to use class, which includes uh, if, let's say, if your Python or your program has configurations or multiple steps, or it has a shared state between all those functions, all those steps, and environment awareness. To fulfill any of these needs, we use OOP, or else we don't have to use them, or else we don't have to use class. Now let's head to the demonstration. Now, before heading to the demonstration, I want to clear up one thing. A final verdict is a pipeline class is just like a container of steps. I mean, it is just a container of steps. I mean, it is container of functions, which basically is container of steps. Instead of writing multiple functions which are separate from each other, if we think those functions share the same state, we can just combine them into one single container, and we call the container as class. Let me show you the basic class structure first. For that, I'm gonna duplicate this slide, take it to the end. The basic class structure that we use for a normal pipeline would go like this. So it starts with the root. In practice, this data pipeline will be the name of our class, and these are all the steps inside the class. Steps, which when I say steps, I refer to the functions that are defined inside one class. Don't need this, don't need this. And then not load data, should be extract data. Transform data. Now load data. And then run. This will be a basic class structure for our data pipeline that we create. Like that. So we use class, like I said, we use class when we have multiple functions that shares the same state, and we just kind of group all these functions into one single container, and we call that container a class. And in this container, each function can change all those functions, if all those functions share the same state, it can be declared at the beginning, and that state will be continued all over the class. Just remember this, but when I demonstrate it, you will understand what I'm talking about. We group multiple functions which are referred as steps in a class. We group multiple functions which share the same state into one single container, and we call that container a class. And instead of defining the state in every single function, we just define the state at the beginning of the class, and that state will be shared among the rest of the functions or the steps in the class. So you're just making things easier by creating a class here. And that is the difference between using class efficiently and not using it efficiently. When I say this is the class structure for a basic data pipeline, let's say you write a program for your data pipeline and you have multiple functions, right? First we have ETL. We have extract data as our first function, which extracts the data from the data source, right? And we have transform data function to transform the extracted data into a business ready data, right? And we have a transform function, and then at the end we have the load data function, which loads the data into the source. This will be the basic data pipeline that we have. But the thing you have to understand is all these three functions share the same state. They share the same configurations, right? So instead of defining the configuration again and again in every function, we can just combine them. We can just group them. And because they are sharing the same state too, they can just be combined into one container. And we add one more function at the end, which orchestrates the whole flow. Here, for these three functions, we're just doing tasks. So they are steps. They're actually steps. The functions, they are steps. The first step extracts the data. Second step transforms the data. Third step loads the data to the destination. And the fourth step, runoff, will orchestrate the flow by which these steps to be executed. That is how a class is defined in for a data pipeline. I think now we got the difference, but I'm sure you will get what I'm talking about when I actually write or create a class. Let's go ahead and create a class first. Create a new .py file. Pipeline.py. Okay, to begin with, I'm going to import CSV because I'm going to use the CSV file that we already created, which is this one, the dirtyorders.csv. I'm going to use this file. I'm going to import it. I'm going to extract it, transform the data, and then store it at a destination. So because we are going to work with the CSV files, I imported CSV package. Now to define a class, we define it using class and followed by the class name, which can be a data pipeline. And for the first function, we define the initial step to be done as init double underscore init double underscore. So whenever you call the class, this will be executed automatically right away. So you don't need to orchestrate it. Then we have of self, comma, source, comma, destination. And here we say self dot source equals config. No, sorry, not config. Source equals. Now we say we define the path of that source, which is data slash raw slash dirty orders dot csv. All right, and then self dot destination equals, and the destination be data raw slash, no, not the raw, data cleaned slash cleaned orders dot csv. So we are now defining the source and the destination of the file that we are going to extract, and the destination where we are going to load the data file, and the source will be data slash raw slash dirty orders.csv, which is this, and we define the path as well, data slash raw slash dirty orders. And we have to define this path because we're going to run the program in the main branch of the project. I mean, basically the root branch. So I have to navigate to the data.csv file. That's why I did that. And then we also define the destination as data, but this time cleaned slash cleaned orders.csv. So what happens is the output file will be saved in this destination under clean folder. The raw data, the dirty data will be under the raw folder. And that's it for this one. And this function, by the way, we don't call this, or we don't need to orchestrate this initial function. Whenever you call this class data pipeline, this will be automatically executed and the source and destination will be assigned. But everything from the next should be executed by ourselves. First one is definition for extract data, to extract the data from the source.csv file. Print, and we can use f strings and say extracting data from flower brackets open. Like I said, that is the dynamic part. From here we're going to start the dynamic part. Self dot source data equals, and create an empty list. Now you see, you already saw an application, right? We already encountered an application here, which is I haven't sent I haven't sent the parameters to this function, the source. I haven't sent source or destination parameters into this function, but still this function can get access to source by just being in the class and being connected to the class by using self as a parameter for that function. So it can get the source by using self.source. So that is how the functions can share the data between the same common data between all the functions in the class. source, and we created the empty list, and then we use with to read the data from the source.csv file. With open parenthesis open and self dot source comma, and yeah, you remember that, right? How we have to read from a .csv file. We have to first use with open and then define the path, the file path, or the file name, I mean the file path. If you remember when we created those files, where I can find it. Yeah, this one, CSC read. See that, right? So we are doing this one right here. So we're doing this line with open and the file path. Instead of the static file path, we used the self.source, which is already defined in the initial function. So we are sharing that data in this function as well. So we define the source there, and then now we define the reader here. Before we saw in here, we know how we can read the CSV file and read the data in the CSV file into a list using this method. But when you read the CSV file into a dictionary, we have to use dict reader, and we have to say new line equals and nothing. So that defines the new line, and then we have encoding format. We need to define the encoding format, which usually be UTF-8, and then we create the reader using csv.dictReader because we are creating a dictionary out of it, and CSV file, which is aliased here. It's almost the same thing we used before, but we are creating a dictionary instead of list of lists. Say for row in reader data.append and then from the data that is been read, we're going to take one row from the reader and then append it to this list by creating a loop, so it loops through all the rows. and then return data. So, and now this step returns data, which is the extracted data and will be a list of dictionaries. Now let's create. Now let's head to the next function, which will be transforming the data. F transform data. Self, comma, data. Now we print something before starting the transformation. So transforming data to just to know the transformation has been started. You can also add comments. Initialization. Now we create an empty and new list again, saying cleaned underscore data with a new empty list, and we clean the data and then append that clean data to this new list. Now we create a loop first, and we loop through all the dictionaries in this list. We all know, right? So we just extracted the data and saved the data as a list of dictionaries, and we called it data. And we then go through all those, and we then go through all those rows, all those dictionaries basically in the list, which is called as data here, using a for loop like that. Right now, these two functions are not connected, they're isolated. We will connect these functions at the end when we create the function named run off, and that is the orchestrator of this whole pipeline. Right now all these functions are isolated, they don't have any relation between uh, the relation to each other, they cannot talk to each other. When we orchestrate, that is when the magic happens. That is when we can pass arguments to these functions that are written by another function. Okay, so we are now iterating through every row in that list of dictionaries, which is called data. Then we do if condition, if row of amount Now we wrote a condition by choosing the column, I mean the key, which is amount. So we are basically choosing where is our dirty data. So basically we're choosing this column amount, and then I mean we are checking that column for every record, by the way, but for the first loop it checks for this column and see if that is not, if it makes sure that is not in any of these objects, I mean any of these formats. It should not be none, it should not be empty. This is nothing but empty. These are just double quotes typed side by side, which means that is to make sure there is not, I mean that is to make sure that field is not empty. And then we have null. So we are checking if the field is null or there's nothing in it. If we are making sure of that, if this condition satisfies, then okay. Here now we are checking, like I said, we are checking every row, every record. We are only checking this column, amount column, and seeing, I'm I'm making sure it is not equal to none, or it is nothing, or it is null. So we're making sure it matches with none of these. If that satisfies, then we replace that field, the value in that field, with float of raw of amount. We're converting the data type. If it is string, it will be converted into a float. That is how it works. Now basically what we did is we took out the null values. Here in this CSV file we do have, in this dirty order CSV file we do have null values. We have null value here. There's nothing in this column, and here as well. So there's nothing in those here and here and here. We do have null values in amounts, so we are filtering them out. Only the records that doesn't have any null values at amount position will be moved further, moved for the further process, and then that will be make sure it is in float format. I mean basically they are all in float format already, but I'm just for the demonstration I use this statement as well, which converts anything, even if it's a string, it tries to convert that into a float. After converting everything and cleaning the null values, then we append that that records with no null values to the empty list that we created, which is named cleaned underscore data. We append each row to, that particular row to clean data dot append. Clean data list, this one. This is just a small transformation. We took out the null values, but we did converted everything into float already in this dirty records in the previous programs, but we still included this line. I thought they were not converted, so I included that line. But that's fine. That doesn't make any difference. So we'll move on. Now this function will return the cleaned data list, which is the list of dictionary with the clean data, basically. And then in ETL process, we're done with extraction, we're done with transformation. And what is the last step of the process? Loading the data. Now we load the data into the destination. Load the data. Too many new lines here. We define the function first and say load data of, we return the parameters. Now we define the parameters self and data. Then we print to make sure this is getting executed. F strings loading length of data records to self.destination. Now here we all know about F strings, right? So this is the static string and this is the dynamic path. What this does is this prints the length of the data in between this at this particular location in the string, and then it also prints the destination file path which we are defined here. So it prints this at the end. And length of data, we say length of data because we know how the parameters work, right? We already talked about it. Whatever the parameters that we pass to this function, even if we pass clean data, the list named the list variable named clean data, it will be still aliased as data inside this function. So we will print the length of the data that is given to the function as a parameter. Then we start if not data and a full stop. Okay. So this is just to make sure the output does have data in it. If there is no data at all, this if condition will get satisfied and this will be printed. Imagine the data that is sent to this function has nothing in it. If it is empty, this will be satisfied. If not, data checks if the data is empty or not. If it is empty, it prints no data to write and returns nothing. But if it does have data, then with open the same thing that we used when we read from the file, the .csv file. This is the file path, the destination path, which means this. Right now, we don't have any .csv files inside it. So it creates one and writes. W means write. So it writes. And we also define new line, and then we define the encoding format, which is UT of 8. Then as we alias it with CSV file again. Writer equals CSV dot dict writer dict writer CSV. And what we're doing here is, in the first line, because our data is in list of dictionaries, we are choosing the first dictionary from the list, which will look something like what to say, something like this. Dictionary order ID. No. No, there is not enough space. So the first dictionary would look something like this. Order ID 1, comma, amount 100, 100.0, because we converted that into float. Then country like that. So this will be, I mean, the first dictionary from this list will look like this, something like this, right? Something like that. Now what we're doing is we're using dot keys of method, which picks only the keys in that dictionary, which means it only picks order ID, amount, and country from that dictionary. Only the keys, because they are the keys. Well, dictionaries are key value pairs. This is a key and this is the value. One is value. So it only picks the keys, order ID, amount, and country. And then it uses them as the header for the .csv file, right? We have to use these as a header for the .csv file, right? So that is what we did. So we used them as a header. That's why we separated them. And then the rest of the rows will be written using this writer.write rows of data. Then we write the rows of write the rows into the .csv file. That's how we convert a dictionary into a .csv file. That is what basically happened here. And now we're also done with the load data function definition. Now, the last step. Right now we have all these functions defined. They are all defined, but They're not connected to each other. So class doesn't know what to execute first and what to execute next. We execute one after another. But if we execute one function after another, it kills the whole purpose of creating a class. So what we have to do is we have to orchestrate everything with another function at the end. So now we are going to create a new function that orchestrate the flow that these functions or steps has to be executed. Now we're going to define the function with the name run, and we pass the parameter self again for this one, self. And then first, what should we run first? We should run extract data because we have to extract data first, right? So first we have to run extract data, this function, and then whatever this function returns should be passed into this function, right? The data, that the list of dictionaries, is that the list of dictionaries? Yes. So the data, the list of dictionaries that is returned from this function should be passed as a parameter into this function, the transform data, which is the second step. And then the output from this function, which is a cleaned data, which is also a list of dictionaries, should be passed as an argument into the load data, which is our third step in the process. That is what we have to orchestrate in this function. To do that, we say data, a variable named data, equals to self dot. Now we're accessing the function name using self dot. That is what the beauty of class. These functions are all sharing the same state. Now we use self dot extract data of. What this does, this extracts the data from the source, which is the dirtyorders.csv, and returns the list of dictionaries as the output, and that will be assigned to this variable now. And next, after that, we create a new variable. I mean, the name is same, but that's a new variable. And for this variable, what we do is self dot transform data of data. Now you see what we are doing here, right? Here we just call this function right away without passing any parameters. But here we're passing data as a parameter, which is this one. And data has all the data that is extracted and returned from this function, which is list of dictionaries, and that will be passed into transform data as a parameter, and then transform data will return another list which is cleaned data, which is also a list of dictionaries, and that will be assigned to this new variable, the so-called new variable. The name is same, but that is a new variable because we are assigning the new data, which is cleaned data, to this variable, which will also be a list of dictionaries. Now we connected to these two. We connected these two functions, extract data and transform data, but we haven't connected the load data yet. Now we're going to do that. Now at the end, we say self dot save data of data. Now we don't have to assign the output that is returned from this to any other thing because it doesn't make sense, right? This is the last step of our pipeline. So now what we're doing here is we are passing the data again, the cleaned data that we got from the transform data function. We are passing that data into save data function again. What save data does is, oh, wait, not save data. This is load data. Load data function. So what load data does is it loads the data into the destination, which is our destination.csv file, and it returns nothing, right? It returns nothing. It checks if the file is empty. If it is empty, it says no data no data to write and breaks or returns. If there is data, it just creates a new file and writes all the data into that file. This is how. This is the function which we use to orchestrate the whole flow. This whole flow. So basically, these three are the functions. This main one, this first one is the initialization function. This is not part of steps, but this will initialize the values that can be passed to all these the rest of the functions that are grouped together in this class. And at the end, we orchestrate everything, the whole flow, using another function at the end. That's it. I think now we got the concept right. We can do this. I mean, classes, using a class is not mandatory, but this makes the work easier. It makes the work easier and more convenient. Rather than, we can do the same operation with multiple functions and returning these multiple functions, the values from these functions into another function. We can orchestrate it, we can run it the same way, but this is a lot convenient than writing the raw functions without a class. And that is the beauty of object oriented Python. If you doubt it, try writing these functions separately without using class, and then you will see the difference here. Now let's save this and try to run it. No. If you run it, nothing happens. We are just defining the class here. We have to call the class and call the orchestration function in order to actually run the flow. What I mean is, at the end, outside the class, by the way, D is not part of the class. Now the class is, defining the class is over. This is completely done, okay? Defining the class is done. Now we are going to call the class and run the orchestration function, which is run. To call the class, we use pipeline equals data pipeline, which is the name of our class, data pipeline, right here. So we're calling the class, and then that's it. Now we're calling the class data pipeline, and we are assigning that to a variable pipeline, and then from that class we are running this particular step, this function, which is the orchestrated function. And now when you trigger this, it automatically triggers the orchestrator, trigger the rest of the files, because that is the orchestrator, and it follows the whole flow. It runs the extract data first, and then transform data, and then load data at the end, and you will get the data output. And the output of this will be, we will see a file get created in this data slash cleaned. Under this folder, there will be a file that gets created with the name clean orders.csv. That is our expected output. Now let's run this, And I'm sure I'm going to face a lot of errors because this is a big program. Okay, now what's the error? Type error, data pipeline init, missing two required positional arguments, source and destination. Okay, I found the error. What I did is I tried to define the source and destination inside the function without passing these parameters. Well, we can do this, but that kills the purpose of the class too. The purpose of the class is to uh, take a source and a destination outside the class. We cannot define a static path inside the class, right? We have to pass it when we call it here. We have to pass them as the parameters, and this will kill the whole purpose. So what we have to do here is, instead of doing this, what we do here is we cut that, paste it here, comma, cut this thing, paste it here. So we're passing the source and destination paths as the parameters into this class. Now, what I do here is I just assign those parameters to the actual self.source and destination that we can use for the rest of the functions. This is how we define it. Now let's run that again and see if we will find any other errors other than these. Okay, we did found another error, which is name error. The name row is not defined. Did you mean raw? I think it's raw. Where is it? It is at line 53. So it is at line 48, which is this. So it is at the extract data, and then it is line 17, which is this row. Yeah, I spelled it wrong. We called it as raw here. We looped through all this the data, and we called it raw here, but we appended when at the time of appending the data to the actual list, we called it row. Supposed to be raw. Okay, that is fixed. Now let's run it again. There you go. Finally, we did got the output. The program is executed. Now we can actually see the clean orders.csv file here. Now when we open it, there you go. There is our output. This is the dirty data, and this is the cleaned data. You can clearly see the difference. It took out the records that have null values in it at amount column. See that? So the second row is taken out because that has a null value. Second, fifth, and ninth. All these three rows are taken out totally, and the final output doesn't have any null values. Okay, that is how we use class. Now, for the next topic, So the main whole purpose of the class is to encourage clarity over the quantity, right? So we want everything, the whole process, to be so clear for us. That's why we created the class, and for the convenience too. Now, passing the whole path like this is not convenient too. We have to pass them as a configure as a files instead of just typing the whole path here statically. We have to pass them dynamically using path the file paths as config. I mean, basically like configuration files. Um, what I mean is, let me just demonstrate that to you as well. I'm going to use the same code. Don't you worry. That's gonna take like 5 minutes to demonstrate. So you don't worry at all. We are going to use the code that we used here, but we're going to change one single thing. Instead of passing this whole path here, typing whole path in the program itself, what we do is we just define these paths out of this program, out of this .py file by just creating a new file, a new JSON file, saying config.json, which stores the configurations inside it. And here we define the file paths, the configuration for the paths. Say and it should have the whole path. So I'm gonna copy the whole thing. There you go. So that's the source, and also for the destination. Okay. The reason why we chosen JSON to store this dictionary of configuration is we already talked about the reason, right? JSON format is the best way to store your dictionaries, because when you convert them back into a dictionary from JSON, it is a lot easier to work with that. Well, JSON can store any type of data, not just dictionaries, but dictionaries and JSON are the best combination to use. And for the clean data, the path is the same, that. Now we created a .json config file outside the program. And now we have to change this code a little bit. Instead of editing the same code, let me just create a new file and just copy paste it in that. Say pipeline config.py, because we're going to do the same process but using configuration file. Now copy that, paste it here. But instead of passing these two as the parameters into this function, what we do is we just pass config underscore path as a parameter, which basically will be our configuration file that we just created. Then in here, just take this down. I mean, we don't have to take this down. We're going to add 2 more lines. That's it. we're going to convert that JSON file into a dictionary and then read those source and destination paths from that JSON that is converted into dictionary. First, to convert a JSON into dictionary, we have to open it with, say, with a read. We have to read the data, right? So open of config path. By default, it will take as read. You don't have to define read, but if you do, that's fine. You can do this, or you can just leave it empty. Like we already talked before, we don't have to define if it is a read. By default, it takes it as read. If it is write, you have to define it with W and alias it as F. And then config equals JSON dot load of F. And what we do here is we change this one as config of source, then this one as config of destination. We got that ready. What we did is, yeah, just like we did in the conversion of JSON to dictionary, we just read the data in the JSON file. To convert the JSON into dictionary, we already know. To convert JSON into dictionary, we use JSON.loadof, and to convert dictionary to JSON, we use JSON.dumpoff. Here we're converting JSON to dictionary, so we use JSON.loadof, and the reader F, and that is assigned to the variable config. That is the now the config is the list is the dictionary with our source and destination values, and from that dictionary I'm assigning the source. I'm calling the source key, the value of the source key, and assigning to source, and the value of destination key from the config dictionary to destination, self.destination. This is how we use classes in real world. We don't just hard hard type all those paths inside the program itself like this. This is good for the development side, but when you work with the real world project, this is how we have to configure those file paths. Should be a separate file. If you do that, even if you run the same program in a different system, all you need to do is you need to you need to just modify this JSON.json file in that PC and it will work. You don't have to touch the code at all. But whereas in this code, if you copy this code and run it anywhere else, this might not work because the file path might differ. That is how we have to. That is why we have to use configuration files basically. Now when we run this, no, wait, sorry. I just changed this one, but I forgot to change this one. Here we have to pass our file config.json to that class config.json. config.json. And also we have to import JSON because we are using JSON methods here, json.loadof, so we have to import JSON. And I think that's it. Now let's run that. Almost the same name, but it is pipeline config.py. Run it. There you go. That still worked the same way. And it is more professional now than the actual the initial code that we written. This is more professional looking. Not just looking, not the looks. I mean, the technically as well. This is professional. These are we write the codes. Okay, I think with that we're done with OOP concept, object-oriented Python. In this hour, we learned how to write a class, how to define a class, how to call it, how to define steps inside the class, how to connect those steps together, how to orchestrate those steps, basically, and also the configuration, the file configurations. And yes, we're done with this hour. Let's head to the next hour. And now for this next hour, we're going to talk about performance optimization and concurrency. Firstly, talking about performance optimization, Python is slow. Python cannot actually work on the data by itself faster, and it depends on you how to write the programs. And that is why Python can work with a lot of packages, and picking the right package to do a task where it is necessary is so important. Instead of creating loops and conditions unnecessarily will slow down Python a lot. Instead of that, using the packages like Pandas to work on the tables using the data frame is a lot efficient. So picking those packages is very important. Mainly, the factors that influence that slows down the Python are like creating bad loops, unnecessary memory usage, or doing tasks that you are not supposed to do with Python. So you have to keep these factors in mind. Talking about the factors, the first one I have to talk about is memory traps. You should not load the data files that you don't need at all or that is not necessary. Loading those files will slow down Python, will reduce the performance of Python. And also copying data frame and holding those data frames for longer that are not necessary too. That will increase the memory usage, and you don't want that to be happen because that will also affect the Python performance a lot. Have you ever experienced this? Saving a huge data in the Python memory, I mean the data structures. I mean, see, when you run a Python code and you save, you hold the data in a list or a dictionary, that is basically saved in the memory while the runtime, right? Until the Python, the whole code get executed, those data will be stored in the memory. If the data that is held by the memory while you run the program is huge, that of course obviously affects the performance of Python. When I I bet you face this issue when you work with the big data and I mean not with the big data, huge data, and you hold a lot of data in one data type in the Python program for longer. If your laptop fan will sound like a jet engine basically. So you have to make sure to use or hold data only in where it is necessary, and yeah, doing that is a major backlash for the Python performance. So you have to be clear about that. I mean, it doesn't matter when you work with the small data sets, but in industry, I mean, in the real enterprise grade projects, that holds a lot. That makes a lot different. And now, the other thing we have to also look at is the critical things that we can look at is loops. Use vectorized methods instead of looping. you don't looping basically looping through the data makes Python slower. I mean, for the if it is the small data, that is just fine. But if the is data can be converted into a data frame, looping doesn't make any sense, right? Uh, let's say if you want to transform or work with the data that can be converted into a table format, basically a data frame format, but still you decided to loop through the whole data using a loop. It can be a for or it can be while. So you still decided to loop through the whole data and then work with it instead of using pandas by converting that data into a data frame and then using the vectorized methods. That makes the process a lot simpler for you and for Python for your PC too. When I say vectorized, what vectorized means is there are a few methods in Python, basically the pandas methods. They are these vectorized methods. They don't loop through the whole data. They just use C under the hood and they just work with the data. They don't loop through the whole data. They just work with the, I mean, you know, it is just an optimized way to work with the table formatted data, pandas. So instead of doing loops, go with the pandas. To actually demonstrate it in practice, I'm going to write a program where I'm going to loop through the whole data in at once and see the time difference of execution, starting of execution and ending of execution. And I'm going to use data frame, convert it into data frame, and I'm going to use pandas method to do the same exact task, but using a vectorized pandas method and see the execution time difference between a looping and using pandas method. For that, of course, let's create another Python file. Okay, and here let's import time to measure the time difference between start of the execution of that program and the end. So we calculate the difference between the start and the end and get that execution, the time taken for the execution. So we import time here, and then we also import pandas as PD. Now we define a data frame. PD dot data frame, parentheses open, flower brackets. Now the data frame includes, defining this data frame will be different than the other data frame we defined till now, because I'm going to define a million rows data frame, and there is a reason why I'm doing that. I will explain that at the end. The first column, I mean, we're going to create one single column for the whole data frame. And for that, we need NumPy to create that. Import NumPy, which is numerical Python, as np. Use NumPy. Now NumPy dot random dot randint of 1 comma 1000 comma size equals. Now what basically we're doing here is we are using NumPy. We're only creating one column, by the way, and the column header is amount, and we are using NumPy to generate random integers. Randint stands for random integers, and the random integers be in the range of 1 to 1000. So it'll be any random integer in the range of 1 to 1000. It can be anything. It can be 250 or 350 or 495 thousand till 1 from 1 to 1000. So it picks anything, and the size, these are the main things, and the size will be 1 million records. We are going to create 1 million records, and the values for that 1 million records will be anywhere between 1 to 1000, a random integer between 1 to 1000, and we are creating 1 million records. And the reason that I'm creating 1 million records is to show you the time difference for a loop and the pandas. If I do a data set with 1000 or 100 or maybe 10,000, the difference will not be visible to us. The time difference will not be visible. Even for this, it will be a millisecond. But in real world, we will, like I said, we will work with billions or millions of data, and then we will see the difference. But here, what I'm doing is I'm going to create a million records and then compare the execution time between the loop and the pandas vectorized method to see the difference between the execution time between both. So to have a bigger difference, I'm using a bigger data set. That's it. Data frame, not data set. So I think now you got it. Now you got it why I'm going to create a million records. Now, first, the slow method. Let me write the comments too. Create data frame, and now from here, I'm going to program the slow way, looping. Start equals time. We need time, so that's why we imported the time package. Time dot time of total equals 0. For now, the total is equals 0. So we created a variable, an integer variable with 0 as value. Now we're going to open a loop, a for loop. We will loop through the whole data frame. Call per val value in data frame df of amount total and increment. The incremental operator equals val. And now what this does, we open the for loop. We say for val in df of amount. We open the for loop. Now this loop iterates through every single record one after another, right? For the whole 1 million records. So it iterates for every one of them, and if for every value, this will be the total will be incremented using the incremental operator plus equals. It will be incremented with the value. What it does is basically, so this, by the end of the loop, we just get the total of the amount. We're just adding them up together and we'll get the total amount at the end. But the difference between this and the vectorized is this: here we are looping through the whole data, and there we're just using vectorized, and that doesn't loop through the whole data. It just right away creates that. Now what we do here is we calculate the time taken for this execution. Print of loop sum is to comma total. Now we print the result first. That's fine. That's totally fine. And then we print time taken as time dot time of, which returns the current time, minus start. So time dot time of returns the current time. What we did is, before we even start the loop, we recorded the start, the time at the start, right? Using the time dot time, we assigned it to the variable start. So the present time, the time before the loop even started, we are assigning that to start. And then we are going through the loop, and it loops through the whole, all the million records, and then it produces a total of that amount. And after that, we print loop sum of total, and then we print time taken, which is the time after the loop executed minus the time before the loop even start executing. So we're going to subtract end from the start, and then we will get the result, which will be the time taken to execute the loop. That is how we are going to calculate that time difference, the time taken. Now let's save that and open command prompt. Here, run that. Say Python src slash, the name is prf demo.py. Run it. Now we can see the loop sum total is 500369061, and the time taken is 0.0914 something. This is fine. Now to compare, let's write another way to do the same work that we did here with the loop, but now we are going to vectorize it. Now we are going to use a pandas method, pandas data frame method instead. We name it fast way vectorized. Now we do the same. We do the start equals time dot time of. We record the start time before the loop even started, and then I mean the not the loop here, by the way, the actual process even started, and then we assign the value, the total, the variable total. We define it with the value as df data frame of amount dot sum of. Now this just adds up all the values in that column. That's it. You don't loop through all the columns and then add one after another. What this does is It just adds the whole column at once. That is that is how it is faster and more reliable and uses less computational power than looping through uh, each and every record and adding one after another. This is one this just does everything one shot without looping. That is what vectorizing is. Now we print vectorized sum as total again, and also print the time difference, the time taken. Print time taken, which will be time dot time of, which is the present time after that is executed, minus start, the time before even we process the data, and that results that gives the time taken for the execution. Here I'm going to say vectorized time taken. Should I create another file, or should I just leave it like that and run the loop again? I think I'll just leave it as it is instead of creating a new file and doing just the fast way in that file and slow way in this file. That doesn't make sense. We're going to execute everything in one place. Now the output of this will be, this prints the total just like before. This is going to print the total, the loop sum, and the time taken as well, right? And underneath it, it will also print vectorized sum, which will be the same value. The value doesn't change, but the execution time does change. And underneath it will be the vectorized time taken, which will apparently be less than this value. So it takes less time than that. Now let's run it, save the file, and then go back to here, run the file. But there is an error, which is syntax error at line 25, which is this line, and it clearly points to the error, which is the semicolon. This semicolon is supposed to be inside the codes, because that is part of the static string. So that is the error. And now that is fixed. Let me just copy paste this, run it. We got one more error, which is vectorized sum total. What is it? Syntax error again. Invalid syntax. Perhaps you forgot a comma. But where? Oh, sorry. When we print something, before between the actual syntax, I mean actual static string and the dynamic value, we have to place a comma, right? I forgot that. So it actually says that as a syntax error. Now let's run that again. There you go. Now, like I said, the total value will not change. The total value will be the same, but the execution time will be different. So this is the loop sum, which is exactly same as the output of vectorized sum 500159521. That is exactly the same. But what changed is the time taken. It took the same, I think almost the same time when we executed before, 0.091. Before, now it took 0.098. Okay, let me zoom this in more. Okay, let's write them aside. So it took 0.098. If we round that up, it took 0.00, if it took 0.099. And the vectorized time is 0.000007 at the bottom here. 0.0007. And that is loop, and this is vectorized. You see the difference clearly, right? And because here we are just using a million records, that's the time difference we got. But when we actually do this same thing in the actual real world projects, this difference will be a lot. And being a good data engineer, you have to know about these topics when you work with Python. These might seem a small these might seem like a small topics to you right now, but this makes a huge difference between a senior data engineer to a junior data engineer. We have to know about these performance metrics as well before we write a code. We have to be cautious about these. Okay, with that, the demonstration for the looping and vectorized time difference is done, the performance metrics. And what we learned is, well, we got the same exact result, but with completely different performance. That is what we learned at the end of the day. And then what we have to talk about next is multiprocessing and multi-threading. Yes, you heard it right. Python can also multi-process and multi-thread. Python does have the concepts of multiprocessing and multi-threading, but it doesn't work like PySpark, where we distribute process. When we say multiprocessing in PySpark or SQL, or I mean Snowflake, we distribute the process. We distribute the jobs to multiple clusters to process. But here in Python, multiprocess or multi-threading doesn't mean distributing it into multi-clusters. Multi-threading and multiprocessing in Python still works on the local PC, the local system, one local system. It cannot distribute those tasks to multiple systems. But what does multi-threading means and what multiprocessing means in Python then? I'm going to draw a good a basic table to differentiate between multi-threading and multiprocessing in Python. So let me open the slides again. Let me duplicate a slide, maybe this slide, and drag it to the bottom. Perfect. Perfect. Now, first major difference I have to talk about in multi-threading is one process at a time. Then second one is shared memory. Skill bottleneck. I'm going to say what is skill bottleneck as well. And for multiprocessing, through parallelism. Okay, firstly, talking about multi-threading. Yes, it does have multiple threads, but it only executes, only one thread or one process can be executed at once. And all these threads have shared memory. They don't have separate memory. One single chunk of memory or cluster of memory will be shared between all these threads. And the talking about the drawback, it follows GIL. GIL is nothing but it only GIL is the one that makes multi-threading to perform only one thread executes Python code at a time. So that is the drawback. So and the reason for that is GIL bottleneck. So when I say it obeys with GIL, I mean first GIL stands for GIL Global Interpreter Lock. Let me write that down here. Global Interpreter Lock. So anything that obeys GIL, I mean multi-threading obeys GIL. So when it obeys GIL, what it makes multi-threading do is it can only perform one Python task at a time, whereas multiprocessing is complete opposite. It is true parallelism. So multiple processes can run parallel to each other. That is one of the step as well. So the first difference is multiprocessing, and these processes work parallelly with each other without waiting for one process to execute before executing another. These processes will execute parallelly. That is the difference between multi-threading and multiprocessing. And also, these processes have their own separate memory. When I say that, you don't you think like it has multiple clusters of memory? No. In the same PC, these in the same system, they divide this particular one single memory into separate memories and allocate these memories to those processes. That's it. We cannot distribute the processes. Be, we cannot distribute the processes between the systems. It can only still Python can still only be executed in one system, but it will allow multiprocessing in one single system itself with separate memory, multiple processes working running parallelly, Whereas multi-threading is quite opposite. It only runs one process at a time, but with shared memory. But they both have their own advantages and disadvantages. Multi-threading can be used at input and output methods where we do input and output processes, whereas multi-processing can be used at high computation situations where you need high computational power. So you can use both of them according to the situation. Multi-threading is for input and output and file reads. Multiprocessing is for high computational uh, what to say, high computational situations. That is it. I never worked with multi-threading and multiprocessing, but it is good to know about these two topics. I'm going to show you how these multi-threading and multiprocessing are defined. I have this notebook written already. If you want, I can also send this notebook to you guys, the Python readout. But yeah, just if you want to, just comment. I can send the link to you. These just notes that I written to prepare what to talk on the camera. And for the multi-threading, the code is here. There you go. So we import threading. We say and then we create the threads that work parallelly, but they don't run parallelly. We create threads, but one thread can be executed at once. But this is how we create threads. We import threading and then we create threads. This is how we create multi-processing. I cannot actually run these things. I can, but I am exhausted, so I just want to wrap it up faster. But you can do research on these multiprocessing. And this is how we define multiprocessing. This is the basic structure how to define a multiprocessing. Okay, that is it with the what is this concept name? Yeah, concurrency. That is it with the concurrency and scaling. Now, in this hour, we learned about optimizing the performance of our code, and then we also talked about concurrency. That is it with this hour. Let's head to the next hour's topic. That's going to be a small topic, but yeah, let's get into that. Before heading to the next topic, by the way, I forgot to mention one more point. I know Python still offers multi-threading and multi-processing, but still, like I said, even with multi-threading, multi-processing, it can only run in one system and it cannot distribute the work to multiple systems. And that is the major limitation of Python, and that is why we don't use Python for data transformation, but we use Python for logics between the to connect. We even use PySpark, right? And we want to know Python. We have to know Python to use PySpark. Python works as a user interface for PySpark. So we still need, as a data engineer, we definitely have to start by learning Python for data engineering, and then we have to go to the advanced topics. But yes, Python does have multi-threading and multiprocessing, but still it is not a good way to use this for analytical purposes in data engineering. It is good for data analysts or data scientists, but for data engineering, when we work with a huge data, when we work with big data, we cannot do that. Instead, we have to use Spark, which distributes the work with multiple clusters, basically multiple PCs and multiple storage clusters too. So that is how we run the data, or even with the SQL, with these modern tools like Snowflake or dbt, we still can distribute the work between multiple clusters and multiple storages and get the work done faster when we're working with the big data. But for the small data, or at the beginning stage where we test our data transformations, or our data when we want to understand what kind of data we are working with and what kind of transformations we can implement on the data when we work with the big systems, we can practice, or we can know about the chunk of data by by just taking a chunk of data from that big data and work with Python using Pandas. That is how the flow goes in the enterprise grade projects before you working on the actual big data. And yes, now let's head to the next topic, next hour's topic. Now, for our last hour topic, we are going to talk about managing the secrets in the real world production grade Python projects. This is more about the topic we just touched briefly in few of the demonstrations already, but now I'm going to talk about a new way about managing the secrets by using environment variables and pulling those data into the actual Python program. Managing secrets is nothing but covering up our user credentials from exposing it to the people who actually read the Python code. You might think, what that does even mean? In real world, all the Python codes that we write, every code that we write in the project will be shared to your whole team members, right? And you don't want your credentials that you may use in your Python code to be exposed to your whole group. But you still need to use those credentials in your program to actually run it. That might be a necessity. So to hide these secrets from your code, we can use environment variables instead of hard coding them into your Python code. And I'm going to demonstrate that way of that way of using environment variables instead of hard coding them. Yes, now let's go for the demonstration. For demonstrating it, I'm going to use something that I actually, one of the same files that I actually used my own credentials, which are exposed in the code. So I'm looking for the one that I used to connect to the Snowflake, where I connected to the Snowflake and created the table and ingested the data. So I'm trying to find that code, because I remember in that code I actually exposed my credentials in order to connect to Snowflake. So instead, yeah, there it is, Snowflake demo. There you go. Now here, I write this code, and this code works perfectly. That's fine. But I mean, the only, I mean, the backlash, one of the aspects that this code is falling behind is this code is actually exposing my credentials, my own credentials in the program itself, because I hard coded those credentials here. Now, anyone in my team can actually have access to these credentials, which I don't like. So to hide these credentials, there is a way where we can hide it. So what I'm going to do is I'm going to copy this code and create a new Python file just to demonstrate the environment variables, and say env demo.py. I'm going to paste this here. Now I'm going to show you how I'm going to do that. First, let me show you an example of these environment variables that I used in my previous projects. And the video for these projects are also in this YouTube channel. So you can get access to those videos if you are interested. Here, I'm gonna open this .py file. I think in this one, I connected to a storage space min.io where I need the access key, secret key, and also min.io endpoint, which will be the IP address basically. But I did connect it to that, but I never exposed my credentials by hard coding them in the program itself. You see that? Instead, I wrote this line without exposing my credentials. But I also created a .env file. Let me copy this and open in a new tab just to show you those two files parallel to each other. Now I'm going to open the .env file. And here I defined these values, the environment variable values here. And here, this is where I expose my actual credentials, which is the host docker.internal. This is the port, and this is the group name, and here the min.io for the min.io. This is the port, and this is the key, access key, and this is the secret key, and this is the bucket name. I defined them in a .env file. These are environmental files. Here I did upload it into my Git repository, but in real world, we don't upload these files to the Git repository. Because if we upload this Git repository .env file into the repository, everyone can have access to it, and that doesn't make sense. What we do is, when we upload, we just upload by adding this .env file in. Let me open another tab to show you. We create something called .gitignore right here. So we list everything that should be ignored when we upload something to the GitHub, and there we list .env as well. So that ignores these .env files, so they will not be uploaded into the GitHub repository. That's how we make sure our credentials are safe and not exposed to the whole team that you're working with. Now I'm going to implement this same thing into our code that we worked before, which is a Snowflake demo. Now we have these credentials. Now what I'm going to do is I'm going to create another file right here, new file, saying .env, which is the environmental file. And here I'm going to define all my credentials. The username, password, and everything. Let me write them down. The first, username, just like I defined here in the .env file. The first the username equals my username, which is J, and then password equals my password, which is Masterclass @321, and then what else? Account, which is this, and then we have warehouse name, which is compute underscore WH. And then we have database. I mean, database is not actually a credential, but we can, no, we don't have to do this. We also don't have to use that for warehouse. Warehouse is not a secret, right? It can be exposed. So these are the three things that should not be exposed to the team members. Now we know what to do. We have that. And one more thing, even if I want to upload this file, if I want to push this file into a GitHub repository, even GitHub will not let me do that because my actual password is exposed in this file, so it won't let me push it. So when I actually upload it to GitHub repository to give the link to you guys, what I'm going to do is I'm going to replace this password, by the way. Well, I changed my actual password, but because I already exposed it here, but still, I'm going to switch this to a random thing saying password or something, and then I upload it, or else it won't take the raw credentials into the GitHub. It will pop up an error. Okay, we got all these three secrets listed here in the .env, the environment file. Now, what we have to do is we have to call these values, these environment values that we defined in the environment file, into this program. So we just call them and not expose these credentials in this actual program. So to do that, we first have to, we first have to import OS. We first have to import OS, and from .env we have to import load.env. Let's do that. So we need what? We need import OS, and from .env import load underscore .env. Load underscore .env. These are the two packages we need to import. And also, I forgot to mention one more thing. We also have to install something in the environment before we can actually use these environmental files to get the secrets into the program. And that is, we need to install python hyphen.env. Let's install that. So we go to the CLI again and type in pip install python.env. Now we install another tool into our PC, pip install python-env. Install successfully installed. So we install one more file. So what we have to do, we have to update our requirements.txt, right? This one. So let's do that again. To update the requirements.txt, which has all the tools that we need to replicate this exact environment into another environment. So we run pip freeze greater than symbol and then requirements.txt. And like that, we updated our file, our requirements.txt file, which should also include the .env that we just installed right here, python.env, and it also has the version in it. That is done. Let's head back to our actual program. We done that. And what else? And then we have to define this at first. Load secrets from .env. We have to load them first before we use those environment variables. We have to load them. So we load them using that line. And now we can access them in this way. We say os.getEnv, saying stands for get environment variable, os.get environment variable of that particular variable key that we have to use. So let's do that. So here we say os, right? Oh, should be lowercase os dot get env of codes. And for the user, we have to put in the username, which is this one. We're going to copy that and paste it here for the username, and do the same for the password and the account. os.get env of, for the password, I think it is password, the uppercase password, and same for the account, os.get env of uppercase account, right? Right, that's correct. Now we have everything ready, right? Yes, we do. So we have everything ready, and we haven't exposed our credentials. We haven't, hard coded our credentials in the actual code, actual Python code, but still we are accessing our credentials, but not exposing them. This still works the same as this. Now, when we run it by using Python src / env demo.py, enter. What does it say? Say Snowflake connector database error, failed to connect to database, incorrect username or password was specified. Really? So the account is ready, account is correct. The username, did I enter the username wrong? 321. You know what? I'm gonna copy paste this. So just so I don't make any mistakes. I mean, if I use these credentials wrong for 5 times back to back, Snowflake's gonna temporarily ban me or lock my account like 15 minutes. So I have to make sure this time the credentials are correct. Password, and here these variables, username, password. I'm gonna copy paste these two. And the account. Oh. Okay, now let's try that again. Oh, that's a lengthy error. Oh, again, failed to connect to incorrect username or password was specified. Not sure what What's going wrong here? Should be something with these naming I did. I messed up somewhere. The username is correct. I just found out the reason for the error. To debug that, what I did is I took out all this part and just try to print what this environment variable is written, the username. What this should print. It should print J for username, and password it should print masterclass at the rate 321, right? But when I print these two, what the result I got is this. You see that? So for username it is JSC, and for password it is masterclass. The reason I got this is these are environmental variables, and there are a few predefined environment variables where the username means the actual username that I used in my PC, which is this, the same thing. You can see that, right? So that's why, because of the name, the key matched to that, it took that instead of this environment variable that I defined. So what I have to do here is, instead of using username here and also in my actual code, I have to use it as user instead of username. Now let's run the program again. So you have to be careful when you use these environment variables. You cannot use the predefined. You have to make sure these environment variables you're defining will match, the keys match to the actual environment variables that are already defined or predefined. So to debug those kind of errors, do the same thing. You just print those environment variable to see what those environment variables actually return, and that's how I found out this error. And yes, now the program is actually uh, successful, and that's how we use environment variables. And that is our last topic of this 10-hour Python for data engineering masterclass, I assume. Okay. With that being said, everything, every file, every resource, every single thing that I use in this masterclass will be given to you through a GitHub link. You can get these resources from there. Even the PPT too, the presentation that I created, everything will be given to you through the links. And yes, that is the end. If you I already exhausted. I'm exhausted already. I've recorded this video for 2 days back to back, and I'm exhausted. Yeah, if you think this class helped you and you got some sort of value from out of this masterclass, don't forget to subscribe, like, and do hype or something, hype the video, or whatever it is. I'm not sure what are all the things you can do, but make sure you can do everything: like, subscribe, share to your friends who actually want to learn data engineering, Python. Yes, that is how. If you want to, just if you want, I don't want to waste your time, but if you want to, if you can do that, do that. With that being said, that's it for the video. Adios. I'll be back with another video.